Hello, good morning, good afternoon, good evening, wherever you may be. Welcome to a decade, that's 10, of innovation with DynamoDB. And I have with me some really interesting folks. I'm gonna let y'all introduce yourselves real quick. But first, I'm gonna say your names. Are you ready? Okay, I'm gonna go with Chad first because that's warm up. So this is Chad Tyndall, right? Really
That's
happy
right.
to have you here. And this is
Happy to be
Joe
here.
Itziorek.
Close enough for all practical purposes.
Okay, close enough.
Good.
Joe, tell us how to say your name properly, and then tell us who you are.
Yes, Idzorik. Yes, it's the hard I. Changed over the years as folks came over, but no, folks, happy to be here. My name is Joe. I lead product for DynamoDB, and will be your host for a number of the sessions that we have today, speaking to a lot of fabulous people.
That's right. Yeah, it's super excited. Idzorik. There it is.
Idzorik.
Idzorik, man.
Got it.
You're so nice. Yeah, you're close here. Not even. So, Chad, tell us who you are.
Yeah, hey, thanks for having me here today. I'm Chad Tyndall. I'm a DynamoDB specialist solution architect. So I work with customers every day, helping them evaluate whether DynamoDB is right for their use case, and then if it is the right fit for their use case, how do they get to the point where their app works on DynamoDB and they deploy it and run it in production and everything they need to do to be successful with DynamoDB. That's what people on my team help with.
Awesome. Yeah, y'all stay busy, don't you? Lots
Very
of
busy.
DynamoDB going about. So I'm going to ask real quick, Joe, if you just a quick elevator pitch. So we've been talking about a decade of innovation with DynamoDB, and we're going to get deeper into this, but what's your elevator pitch of what is DynamoDB?
DynamoDB is our key value store for applications that need consistent performance at any scale, right? And we're looking at applications that, you're looking at the Zooms and the Netflixes and the Snaps of the world that really, need unlimited scale and that consistent performance as their applications grow from, say, 10 million to 300 million users without having to re-architect or rethink about how they use a database. And that's really why we built DynamoDB. And we're going to talk a lot about kind of why that was true why that was true 10 years ago and why that is absolutely the same problem we're still trying to solve and helping customers solve today.
Wow, your elevator pitch is way better than mine. I'm going to just be real honest.
Yeah, he's a pro.
I recorded that.
It's like he's done it before.
Yeah, exactly. So real quick, I want to say hi. We're getting a ton of hellos coming in from the chat. Hello to everybody. We're so glad you're here. We're watching on LinkedIn, we're watching on Twitch, and we're watching on Serverless Land YouTube. So tell us, when you're doing your hellos, tell us where you're watching from. I'd love to see we got some Seattle in there. We've got Brazil. So yeah, I encourage you to tell us where you're watching from. Now, Chad, 10 years. Now, a couple rules when I'm talking real quick. You all may have not heard the rules, but I do any number. This is any number I want it to be, and I do that a lot. So sometimes we're like 10 years. Like, that's not 10. It is today, Chad. So 10 years ago, we released this. We announced it, and you have a little something for us, do you not?
Yeah, in fact, I didn't know this video existed until Joe sent it to me last week. I think he didn't know it existed either until recently. But it's a video, it's a launch announcement with Werner and some other executives, some of whom will be on the show later today, talking about DynamoDB and what it is and really the launch announcement from 2012. The video itself is like about a half hour on YouTube, and we can put a link to that in the chat. But I just made like a short little, maybe minute and a half clip of Werner talking about DynamoDB and what it is, kind of his elevator pitch, why we built it and what we expect people to use it for. And I think if we just watch that really quick and then we can talk about it, and it'll kind of kick us off into this conversation.
All right, let's do it. Here we go.
So managing and scaling databases has always been the Achilles heel of any large-scale, high-performance web application. There's only two things that you can do. You can either buy bigger hardware, or you need to split your database over more and more servers. Then either scaling up or scaling out. But both approaches are increasingly expensive and complicated. So one of the things that we like to do at AWS is take many of the really nasty, complex technical and operational problems that we've already solved at Amazon, and then build out simple web services that make these problems go away for every developer. That's basically what we've done here with DynamoDB. Amazon DynamoDB is the result of everything we've learned from building large-scale, non-relational databases for Amazon.com and building highly scalable and reliable cloud computing services at AWS. So DynamoDB is a fully managed NoSQL database service that provides extremely fast and predictable performance with seamless scalability. It's designed for high-volume modern applications that require consistently low latency and high throughput at scale, while tightly controlling cost. So what's unique about DynamoDB is that it's a database that provides seamless scalability, but with zero administration. Before DynamoDB, these two concepts, scaling databases and the complexity of database administration, have always been linked together. So forcing developers and IT departments to manage all the muck, hardware, provisioning, setup, configuration, replication, cluster management, things like that. So DynamoDB takes care of all of this for you.
All right, great clip. Very, very interesting. I'll tell you also, Joe, yours elevator pitch was good. His elevator pitch is awesome. I'm just throwing that out there.
Nobody does it better. Nobody does it better than we're.
My feelings aren't even hurt. Thanks for joining DynamoDB. We'll see you later. So, no, that's great. Chad, tell us about this clip.
Well, I really like this clip because it calls out the fact that DynamoDB and many of the services here are built as a result of challenges that we faced with our own Amazon.com e-commerce store. And of course, everybody knows that's one of the biggest sites in the world, one of the most heavily trafficked sites in the world. So any problems that we face, if we're able to solve them for ourselves, it's really going to solve them for most other people that are out there as well. So if we can take the solutions that we built and make it available for people to use and consume in a very straightforward, very easy to understand the pricing of it. You know, it's not complex pricing. It's just a great thing for customers, I think. And so I really like that. That's how he started the conversation in that clip, and also that we haven't had to pivot. You know, a lot of people. And back then, AWS was kind of like a startup, and DynamoDB, of course, was like a startup within a startup. A lot of startups find that what they're doing is not working, that they need to pivot, and that's kind of a natural part of the startup environment and the startup ecosystem. But in this case, they really nailed it with DynamoDB. You really need a solution that is basically infinitely scalable just by turning a knob, and very easy to use. So it's nice that that part of the message hasn't changed in 10 years.
Right. So, Joe, let me ask you a question. Lots going on. You manage product here. What do you think is the most? And let me caveat. We only have a few minutes here, Joe. What do you think is the most beneficial feature of DynamoDB? And you get real granular, kind of broad, that to help customers scale.
I have to choose only one. No, I mean
just one. But remember, this is any number, so you can go one if you want. Yeah.
I mean, I think when we really look at Dynamo, there's kind of the first one is the consistent performance at scale. Like we kind of like we say that it's like okay, it's not until a customer goes from 100 million users to 500 million users they're like, oh, got it. That's what consistent performance at scale means. Is like I just 5x'd my traffic. I went from 100 million to 500 million, or 10 million to 300 million. And the performance stays the same. And I can go even further, and I'm not re-architecting my database, and all I'm doing is just adjusting how much capacity, or maybe they're using on-demand mode. They're not doing that at all, and it just works. For a database, that is remarkable. The second part, you said I got one, so I'm going to throw in two, is just the operations. It's just the lack of operations. DynamoDB is serverless for a decade. If you think about that, like serverless for a decade, the databases are now just starting to think about becoming serverless. And it just frees developers up from having to do a whole bunch of operations. You just get an endpoint, you have some APIs, scales, nearly limitlessly and consistent performance. It's a very predictable database to use.
I love the idea of an API and not managing connections. So my role, I didn't introduce myself. Again, I'm Eric Johnson. I'm a principal developer advocate from Serverless. I live, eat, and breathe Serverless. And so when I came, so I'm gonna actually go the other way on this real quick. When I came to Serverless, I started using it. DynamoDB made absolute sense to me, but not, yes, because it was scaled down the road, but because I could run very small, very inexpensive applications against it, have the same power that Amazon.com has at my fingertip, and then just and be able to take advantage of that without a lot of effort, without managing connections, without having to spin up clusters, without having to worry about redundancy, resiliency, scaling, all that. So hugely beneficial for serverless as well, obviously it being serverless. So very excited. Well, we have a huge day ahead of us. This is going to be 7 hours. Y'all are with me. I want to apologize right now for, the whatever that looks like. But I want to talk about some of the things coming up and throw in on this. But here's what's going on. If you're watching today, and it's great, we've had the farthest distance so far is Mars. We have someone here from Mars. So, but with Germany, India, Canada, Texas, Brazil, all over the place. So it's really exciting that you're joining us. Here's what to look forward to today. We've got a full day of educational sessions. We have product deep dive sessions. We've got roundtable with the DynamoDB experts, right? With the AWS leaders and DynamoDB customers as well. You look at the full agenda. You can see the screen, and we'll insert a slide here shortly where we'll show you. We'll put a link to that in the chat where we can put that in there. So here's some of the highlights. Right after this, we've got a leadership Q&A with VP Swami. Siva Subramanian. Yeah, not even close. So, Swami, I'm so sorry if you're watching.
Siva
Can you say it, Joe?
What is it? Chad's the best. Okay.
Yeah. Eric Slaughter's names again, Johnson, pronounced Johnson. So there you go. So he'll be joining us actually right after this. We have kicking off this afternoon. We have an evolution of DynamoDB, and we're gonna have a roundtable featuring the AWS Dynamo senior leaders about the past, the present, and insights for the future. We're going to hear from AWS heroes and how they got started with DynamoDB and their favorite pro tips. I'm really excited about this one as well. Alex Debris has done a lot of work around DynamoDB. Jeremy Daly also a lot of work around that. So really excited. And guess
Alex literally wrote the book.
Literally wrote the book. That's right, and it's a good book. I'm really impressed. He's doing a great job with that. Jeff Barr is going to be joining them. They'll probably kick me off, but he'll be joining them to talk through that. So later, then we're going to have DynamoDB customer stories featuring SmugMug and Dropbox, two companies that use DynamoDB pretty extensively, right?
Big users.
Big users. Yeah. We're going to do a Q&A with SmugMug CEO Don McCaskill. Darn it. DynamoDB's first customer. Dude, how about being the first customer? That would be so awesome.
He's got some awesome stories to tell. I mean, we're talking about working backwards from customers. I mean, he's customer zero for us.
Right. And that's one of the cool things is that you'll find, hopefully that, and I haven't, I don't know what he's going to say, but how much interaction goes between us and customers. It's kind of the AWS way is we're constantly interacting with customers, customer feedback, working to build for customers. So if you're just getting started with DynamoDB, we have a 30-minute session on that. So talking about how do I get started? What is this even? What is it? So, and then finally, we have an afternoon deep dive sessions with AWS heroes, where rather than just a chat, Alex and Jeremy both are going to deep dive into some work they've done, stuff we're doing on that. So we're simulcasting today across Twitch, LinkedIn, and YouTube. So I encourage you to put your questions in. Right, so we may not answer, like we've already had some great questions that we've collected that we'll be answering in the office hours, and that's the place where you get to ask anything you want. Joe, can you spell your last name backwards? Do it. And so Chad, can you spell your name at all? So for me, that would be no. I'm not good with but so the idea is bring it to us. Stump the chump, man. Hit us with your hardest questions. I say this because you guys will be there, not me.
Yeah, thanks, man.
I'm like, I don't know. And honestly,
convenient, Eric.
Yeah. What? So, in all honesty, hit us with the questions you're challenging with. If we don't know, we'll find it. And sometimes the answer is no, that doesn't happen. Yes, that doesn't happen. Or here's the best way to do that. So, yes, we've been asked for a link to Alex Debris' book. I think we can do that. We have moderators all over the place that are jumping on this, so we'll throw that in. All right. With that, we are going to move on to our next session. And I'm going to actually bring that up. And here's where we're going to have Swami, AWS Leader Q&A, VP with Swami. And we're talking about why did Amazon launch DynamoDB? All right, gang. Thank you. Enjoy the stream, and we'll see you afterwards.
Thanks, Eric.
Hey, everybody. Welcome to our day of Jubilee. We're here celebrating 10 years of the amazing NoSQL database DynamoDB. For this first executive Q&A session, I'm one of your hosts, Chad Tyndall, and I'm one of the DynamoDB specialist solution architects here at AWS. Along with me is my esteemed co-host, Joe Idzorek, who runs all of product management for DynamoDB.
Hey, Chad. Thanks for having me as your co-host and trusting me with such an important interview today. Glad to be here. But, you're a podcast guy. It's interesting seeing you here. Don't you have another podcast that you normally do?
I do moonlight as a podcast co-host. I have a podcast where we focus on tech sales and pre-sales, basically issues that are interesting to people in my job. It's called Can I Get That Software in Blue? And anybody who wants to listen to it can listen to that. But we're excited to be joined today by our special guest, Dr. Swami Sivasubramanian. Swami is the VP in charge of all database analytics and machine learning services here at AWS. So he's got a huge job with a ton of responsibility. Swami really, really knows what he's talking about technically when it comes to these services. He was one of the authors of the original DynamoDB paper, and he led the team that built and launched the original DynamoDB service here. He's going to be talking with us today and regaling us with fun stories about the origins of DynamoDB and how DynamoDB has really changed the entire database landscape. Swami, welcome to the show.
Hey, Chow. Really excited to be here. Thanks for having me.
It's awesome to have you. Before we jump into the real meat of the Q&A, one of our researchers was doing some deep background on you, and he told us, I don't know if this is true, you could verify, he told us that when you were a PhD candidate, Werner Vogels was one of your advisors. Is that right?
Werner graduated, got his PhD from the same university, Freie University I did. And he was actually also in my PhD defense. He was, if you look up my name in Werner's blog, you will probably see him posting about my PhD graduation. So, and as part of my PhD, that's where I think in a conference I met Werner, and he convinced me to come and intern in Amazon at the time. So that's how I got into doing all this stuff like Dynamo and several other things right now.
So you guys go back a long way, really, even before AWS existed, it seems like.
Yeah, I think Werner has been an amazing mentor and advisor as well for me since the early days, and really excited to I've had such an amazing opportunity as well.
That's awesome. That's really cool. Well, let's jump into it. I mean, the very first leadership principle we have on our list here at Amazon is customer obsession. And really all of our innovation begins with an unmet customer need. So I think we should start there. What was the customer problem that led us down to the path of really inventing and creating DynamoDB?
I'll start from the early days. This actually was when I was an intern around 2004, 2005. I was working as an engineer in Amazon.com. And historically, when Amazon has any peak day traffic, and usually it is around the holidays, scaling is a big challenge. Q4, Christmas holidays, and it is a big one. And one of these scaling periods is when Amazon experienced a serious scaling failure and the root cause of it was caused by a relational database engine from a commercial vendor that we were using, where database transactions were getting deadlocked. And Amazon historically is like an amazing, robust process when it comes to reviewing operational issues that we encountered. So we call it a bunch of engineers got together and wrote what we call as a COE, a correction of errors document, in which we say, what happened? We crisply lay out what happened, what was the customer impact, and then why it happened. We go through a 5 whys on saying why did this availability go down? And then why did that happen? And we keep going down. And then what we learned out of it and how we fix the issues and what are the action items as well and how we would avoid a recurrence. And the broader context is at this time, Amazon was transitioning from a monolithic architecture to microservices as well, where that means Amazon as a company was also moving from these large, big apps to lots of small apps, and each services were required to run its own service with its own API and managing its own state as well. So, and historically, this almost made the complexity of database and state management to hundreds of service owners, and they all need to understand all the database semantics and transaction deadlocks and so forth. So it was not surprising that these kind of transactional issues popped up at serious scaling. And one of the things I remember in these meetings when we were getting together and reviewing, and so as part of Werner's team and others, I remember few of us asking the question, and I don't know, maybe because I was 20-year-old or something, I was asking, why are we actually using a big relational database for this? This can be built much simpler with a simpler system. And normally most companies, they would not bother listening to an intern. So, but Amazon was a little special. And they actually turned around and said, so how would you go about solving it? And a few of us, it's not just me, but few of us had lots of ideas around leveraging state-of-the-art and scalable distributed systems, sharding and resharding and synchronizing. And that led to the genesis of what we call as Dynamo, where we asked ourselves, what does it take to do a highly scalable, highly available distributed data store that enables us to handle the scale of Amazon's services without getting impacted by the monolithic relational architectures. And that was the big unmet need that led us to go ahead and invent these new capabilities altogether. So, and once we launched it internally for Shopping Cart and few other services, the thing we realized is we learned a lot, because it's not just about doing an amazing design. Operating these large-scale distributed systems is complex in its own way, because you got to set up replication groups. You got to learn how to operate it. If you get paged in the middle of the night saying, hey, there is a hotkey issue on these things, or these nodes need to be taken out of service. So Werner, myself, and a bunch of us decided that, hey, we don't want to write these design paper externally until we have learned enough on what it takes to operate these kind of amazing critical services. So, which is what eventually in 2007 that we did publish the Dynamo paper, probably like 2-3 years down the line, to describe our design principles, the problems we were trying to solve, and what were the learnings we took out of running the original Amazon Dynamo as well. And it was very, I mean, over the years, we saw several variants of Dynamo paper providing, similar scalable solutions, just like Amazon as well. So it's really gratifying to see that. And it was even more, it's like very exciting to see 10 years down the line, I think SSP also giving Test of Time award for that paper as well.
So Swami, you actually bring up an interesting point is, when we talk about DynamoDB a lot, it wasn't the end. DynamoDB is kind of the end, but the beginning journey was actually something distinctly different, which was called Dynamo, which was kind of the origin of the paper that you wrote about. What was, can you give a little bit more, context on what Dynamo was and kind of what its strengths and weaknesses were as its own individual database, kind of distinct of what we know DynamoDB as today?
First of all, you're absolutely right that Dynamo was a predecessor to DynamoDB, but those are different things altogether. So just to continue the story, after a couple of years of us having Dynamo and Amazon, and Dynamo was adopted by several core services in Amazon as well. And many of the engineers, they loved the performance and scale that they got out of it. And scaling was not a big effort that you got to go through like huge amount of benchmarking and swapping one server for a bigger server and scaling up. Instead, they got incremental scalability and so forth. But one of the repeated themes that we kept getting back was that when we talked to our customers, which are internal engineers, were that they really, while they love the reliability, performance, and scale, they wanted to simplify the operational complexity of running systems. To some extent, operating large-scale Dynamo clusters were very, very hard at the time. And teams still had to deal with installing, configuring, and operating these systems in our data centers. And what became obvious was at that time, our customers really wanted the equivalent of Amazon S3 for databases. And that's what they love, the simplicity, what they get with S3 for storage. And they wanted the equivalent of that kind of experience with Dynamo. And Dynamo might have been the best technology in the world at that time, but it was still software you had to run yourself. And nobody wanted to learn how to actually set up replication groups, what is a sloppy quorum, or how to do Merkle-based merges, all these things. They're all super cool technique, let alone DHTs and all these things. But developers, at the end of the day, they had a application to run and the business need to take care of, and they just wanted a service. So that kind of was the next evolution of Dynamo as well, which led to DynamoDB.
Why did you guys decide to write up your learnings and publish it as a DynamoDB, as the Dynamo paper? Like what was the thought process there, and what resulted from that?
For us, writing this paper was a great way for us to, one, tell the industry also and start the conversation around why, what is another way to support these large-scale systems with a different kind of database. Because you got to imagine, these things are obvious now. The term NoSQL is like a mainstream obvious thing and so forth. But at that time, even the thought of like us building our own e-commerce company, because we didn't have AWS at that time, building our own large-scale distributed data store to actually replace a database was kind of was not obvious. And we wanted also the broader industry to think through, hey, there is not always only one solution, one relational database running on giant servers that you scale up all the time is the only way to solve it. That there are other ways to go ahead and start building these kind of systems. And it's not an easy thing for everybody to get going from there. And we leverage some of the best techniques all the way from hash tables to Merkle trees and core technologies and so forth. But nobody has put all of these together to run a production scale system like what Amazon did. And we thought the broader science community will leverage from it. We'll get great inspiration and leverage. And Dynamo was probably one of the first papers, if not the first paper we wrote in Amazon. Now, my team across database analytics and machine learning, we probably publish hundreds of papers in a year. So, but this has been something we feel strongly as a way to also move the industry forward.
Yeah, how do we go about making that decision between, publishing it and sharing it with the world and moving things forward versus kind of keeping it as a proprietary secret sauce? I mean, I'm sure we don't publish everything we do. So what was that kind of conversation like?
It's a great question. We thought about it quite a bit on saying like, hey, are we giving away our secret sauce if we were to publish Dynamo as paper and what the technology is like? And one of the biggest decisions that Werner, myself, and a few of us realized is this as a technology, it will also help the broader industry think through there is more than one choice when it comes to your database architecture. And we felt the industry needed a few alternate thinking. And we thought Dynamo would be a great conversation starter because we already got tons of learnings from running Dynamo that the next evolution of DynamoDB was already way beyond what the original system is, and it involves different architecture altogether. But the design philosophy and principles we thought was an important one. So, and we also think it's a great way to also encourage like the next generation of PhD students, like need to say, hey, these are the meaty problems that are actually faced by large-scale systems to inspire them and also to attract also some of the best talent in the industry as well. So it goes And all these were the pluses and minuses as well, so that we evaluated.
Oh, that's great.
How did you guys?
Go ahead, Joe.
How did you guys come up with the name Dynamo, or what was kind of the origin of that name?
That's a good one. The Dynamo name was something. I think I remember one of our colleagues. We were debating. He had various names. I can't even remember what the code name anymore is. For Dynamo. But we were looking for a name that actually symbolized something that is always on, because that was, and we were looking for various clever acronyms like highly available system and various other things, and we didn't like anything. And I think there was one engineer, he was very hands-on, who liked to work with motors and various other things to build a bunch of stuff in his garage, and he was the one who suggested it. So we all liked it when we actually kind of heard about it and said, oh yeah, actually that makes sense. It kind of is a little abstract if you don't connect the dots on what Dynamo symbolizes, but we loved it so much. So.
No, I think it's hard to name services, so I think you guys came up with a good name, and thanks for that.
I agree. I agree.
So what came after Dynamo? Like, so that, DynamoDB is still many years in the future. What came in between Dynamo and DynamoDB in our our managed service in non-relational journey at AWS?
Yeah. I mean, after Dynamo, even my own personal journey, I moved on. I mean, I finished, I guess, my PhD and then joined AWS full time. And I joined to also go build S3, parts of S3 and various other things. And meanwhile, I think AWS, while building S3, they also were proposing to build Amazon SimpleDB as a NoSQL service. And people love the operational simplicity of SimpleDB. Even though it had actually various limitations, like the core table, or what we call this domain, cannot be beyond 10 gigabytes. And it's non-predictable latency because it supported all kinds of queries and issue along with its eventual consistency model. So, and that was one of the big one on this front. And one of the biggest learnings out of SimpleDB that led us to also the evolution of we can talk about what it influenced on Dynamo on that front, but it was around that one. Well, people love the operational simplicity. The domain scaling limitations means we push the complexity back for customers to keep sharding across multiple domains and so forth. And then the lack of predictable performance with SimpleDB, because a single query, you don't know, depending on if you have, let's say, 100 rows or 100,000 rows, suddenly your query performance might be very different as well. So, and these are all the things that customers said, hey, I don't want to deal with sharding and resharding constantly. And this is becoming the same problem we had with traditional MySQL. So the apps that needed amazing seamless scale and so forth, almost all customers wanted the equivalent of S3 for databases. And this is where our customers like Don McCaskill, I know you'll be talking to him later, he actually was one of the vocal advocates for us to actually go build DynamoDB as well. And that led us to actually the journey of building DynamoDB.
No, it's kind of, and I get this a lot from customers when people I talk to about DynamoDB is that kind of skipping right from the learning in 2004 to DynamoDB as a service. But one of the things I really kind of love and appreciate about this origin story is the iterations and the different steps and the different learnings, and how it kind of came together between what we learned about managing databases is really hard, and we had a really hard time with it with Dynamo, to SimpleDB was great but simple, to bringing kind of those two, the best of those two worlds on, really the third iteration to create what is now DynamoDB. So as you kind of, we kind of move forward, we start to think about DynamoDB, and you guys are thinking about, as you were the GM at the time, what were the hotly debated topics before launch? What were some of the things, like you think about product scope and you think about some of, the technical decisions you had to make, what can you share some of those as best you can and as you can, what those debated topics were?
First of all, these learnings led us to actually build DynamoDB. In a way, the vision for DynamoDB was that what does it take to build a cloud database that had the exact simplicity of S3, except it allowed us to seamlessly scale, irrespective of whether a customer is storing 100 rows on day one, and then in 1 year down the line, they might be storing 1 billion rows, but they shouldn't be re-architecting. And then the second thing that was a big one was around also customers deeply cared about consistent performance. This was the era where mobile apps were starting to take off and these things. And the ability to having to seamlessly scale for big launches like Super Bowl moments or actually voting shows, major voting shows, they all needed this kind of amazing scale that you should be able to scale to like hundreds of thousands of million requests per second and then scale down. These are all not possible before, or it took like 6 to 12 months for teams to do. And in DynamoDB, I remember one customer saying like literally they scaled up a few hours before and then they scaled down after. And they couldn't believe it, how easy it was. And these are all the core properties, and we also actually that we were shooting for. But the hotly debated topics, one was, having been part of the original Dynamo paper, which supported eventual consistency. Strong consistency was a big one. That almost internally we debated if I changed camps, and I went to the evil side, so to speak, where I also advocated for strong consistency. But it's not that. People also forget I built RDS too. But nevertheless, I think that was led by customer use cases where customers in many cases did need strong consistency, and we actually were able to build a high throughput system that could actually handle the writes. And we also provided an optional eventual consistency read flag as well. And it was a big topic. And the second big topic was around a lot of debate was around the having to use SSD optimized storage at that time, and being able to guarantee single-digit millisecond latency performance. Again, all these are table stakes. No-brainer now, but flashback in 2010, and at that time when I floated this idea, almost everyone was like, "You should be crazy. These things are incredibly expensive, and nobody will." We can't actually make it accessible for everyone and so forth. And but the team did some amazing work in actually being able to leverage SSD-backed cloud storage and optimizing the storage engine behind it and being able to deliver. These are some of the big topics, and it's fun to look back and see how they played out, but it's always gratifying to see some of these stations resonated well.
Swami, given that the original problem that led you down this path was scalability and operational limitations with the off-the-shelf relational databases that we were using, did you guys first try or think about what it would look like to build our own, like a very scalable relational database before going down this path of something totally different like Dynamo?
We did think about also building relational databases. One of the number one guiding principles, so to speak, that we use internally in AWS, and this I have a strong belief in, is that there is no one database to rule the entire world. That used to be the world in 2000s. Every major old guard vendor, they will always if you have any application and you need database needs, they will always give you the answer irrespective of what kind of application you run. And the answer is, hey, that is my database X. It doesn't matter if you are trying to store blob or if you're trying to store documents or anything. And now, having actually built, at that time we built S3, and then we had SimpleDB for certain use cases. One of the things, and I also had RDS built at that time. Relational databases always started with the fundamental assumption that the entire data is queryable with a single space. And traditionally, they have always been all around how you can actually, so if you need to go from like 100 terabyte to 200 terabyte, or at that time it was 100 gigabyte to 200 gigabytes, you had to scale up your servers. And but the scale at which we were talking about and our customers wanted, the scale-up model would not work. And then we were actually starting to think through, so what does it mean to scale a relational database? And very soon we realized that the whole intertwined relational model forced the anti-pattern of seamless scalability, which was in conflict with seamless scalability, at least at that time. Now the world might be different in terms of network bandwidth and various other things. And this led us to realization that it's not about building a sharding layer on top of RDS. It is about asking ourselves from first principles, if you were to build a database for the cloud and to provide seamless scalability, extreme availability, and consistent performance, and you are not constrained by decades of what traditional SQL database and that model was, what would it be like? And that led us to actually build DynamoDB from where it is today. And since then, DynamoDB originally started with features like hash key and then hash range key for partitioning. And then we slowly started adding secondary indexes and then Dynamo streams and backup restore and so forth, but all with the same fundamental tenet around seamless scalability, consistent performance, and so forth as well.
Now, the original Dynamo paper used an architecture which was a leaderless model, and eventually that morphed into, when we finally got to DynamoDB, that there's really a strong leader approach. Every partition in DynamoDB has a leader on the storage node, and that replicates to other nodes that are listening, that are following the leader. So how did you get to that decision to make such a fundamental architectural shift between Dynamo and DynamoDB?
Yeah, this is what I was touching on the hotly debated topic, because this is a topic that people love to debate in distributed systems regarding the consistency models. And the crux of the issue comes down to write availability. And when it comes to being able to deal with conflicts in terms of how do you handle conflicts in the event of a network partition? And one of the biggest simplifications we did when we look at 99% of customer use cases is that read availability was of utmost importance to them. And that means, and strong consistency was a big thing, because they wanted to be able to do read after writes, where they say, hey, if this exists, I'd like to update it this way, or if this doesn't. And if we don't propose what we were doing, then essentially optimistic concurrency control and various things, we push the complexity back to the application developer, who had to suddenly become a distributed systems expert and consistency expert. And that is what was a big reason for us to work backwards from the customer demand, because we were imposing too much cognitive overload on our customers when it comes to handling these kind of use cases on them. So that's why we led to supporting strong consistency. And so far, I'd say this has resonated really, really well with our customers, because they do need these kind of support. And the simplification we did was, even though we support strongly consistent reads, we actually still provide eventually consistent reads as well as an option, so that even if they had to read out of other availability zones and they are partitioned away or so forth, they still have the flexibility. And now the world has moved on so much. Now 10 years down the line, we have like global tables, which uses a whole different architecture altogether, and it is able to manage conflicts across with some hooks for customers as well. So, and it's exciting to see that evolution.
Definitely. Yeah, I mean, when we talk with customers, we do still spend some time kind of explaining to them the difference between eventual and strong consistency and when they want to use one versus the other. So it is interesting to hear that the architectural shift, I mean, sometimes customers come to us and say they read the Dynamo paper, and so they kind of understand it, and it's like, whoa, that's like totally different. I mean, the architecture's changed, and so it is interesting to hear that the reason that the architecture changed was so that you could offer this strong consistency model as an option.
Now, Swami, as you mentioned earlier, Don McCaskill, who's going to be with us a little bit later today, was, I kind of like to call him customer zero. And there's some great customers internally within AWS. Launching the service, it must have been a really fun experience just to, it was so groundbreaking, and it still is at this time. What were the surprises or the interesting things that customers did that you learned shortly after launch that, surprised you, or, they did something or thought about DynamoDB in a way that, you may not have anticipated?
First of all, I'd say the breadth and diversity of customers using Dynamo is actually like mind-blowing on its own. So all the way from, it's not just Amazon and Amazon.com, AWS internally, but it has so many customers with various use cases, like from Disney Plus to Snap to Zoom to Netflix, Capital One, or Lyft or Airbnb or whatnot. So that shows that, and we end up learning so much based on this, all the way from early days when we launched Dynamo. I think Super Bowl was an interesting time. I think we launched sometime in January 20th, if I'm not wrong. And then Super Bowl was literally 3 to 4 weeks from then. And we had a customer who was doing a major campaign on Super Bowl, and they wanted a database that can handle these vital moments. And normally, the thing is, it just takes like months of planning, and they didn't have that time, and they needed a database that can handle that kind of scale, where the entire country is actually going to go check out their website and the app, and being able to handle the state and whatnot. And that was amazing to see. They were able to build the app over the weekend, and they actually launched it. And then after the Super Bowl was done, they actually were able to scale down from like hundreds of thousands or million transaction or whatever was the number to literally like 1,000 TPS, and everything actually. And normally this would have taken like 3 to 6 months of like 4 engineers to do what they did literally over the weekend. So, and that was like an amazing moment. And these kind of stories, we kept hearing during the early days when it comes to any kind of voting competition and that people used to do. And these talent shows or so forth, let alone it is really exciting to see what Disney Plus did for their major launch to support their application, or what Zoom has done during the past couple of years to go from 10 million to almost like an order of magnitude increase in terms of daily participants. That demonstrates the original vision still continues to resonate, and Dynamo has become a database, the default database for customers to be able to build these amazingly scalable applications.
We made a big announcement in 2019 about Amazon turning off its final Oracle database. Did DynamoDB play a big part in that transition away from using these off-the-shelf databases?
In a big way, yes. And if you see Amazon, I think they had something around more than 7,000 Oracle databases or so. You all should correct me if I don't have the absolute number. But at the time, these Oracle databases were like the giant, how do I say, hammer. So when all you have is an hammer, everything looks like a nail, and people were using it for all kinds of workloads, from like simple key value store workloads to actually document workloads to data warehousing workload and so forth. And in this migration, Amazon were able to migrate primarily off to Dynamo for its major transactional, highly scalable workloads for key value and document workloads, to also then in some cases where they really needed relational semantics, they were able to migrate to RDS and Aurora, and then for data warehousing to Redshift as well. It was a big moment for thing. And I still remember many engineers emailing me saying, like, I can't believe how quiet my pager is now. And for folks who don't know what pager means, Amazon engineers, and I still carry one, maybe not the physical pager, but the app. We also build an owner culture where we actually get notified and when there is an issue, and we like to fix the bugs that impact customer. And the biggest thing I remember engineers telling me is not just they're off this giant black box, but also how predictable their application latency is, and how less operationally intensive now for their on-call is as well. So that was a big one, let alone huge savings in the underlying cost structure for our customers internally.
Well, how much do you think the process of designing and operating and iterating on DynamoDB influenced the design and planning for other AWS services down the line? Are there particular things that we learned that we then took forward into these other services?
Dynamo being one of the early AWS services absolutely was kind of very instrumental in how we thought about how to actually build services and what are some of the key learnings we got out of them, for sure, as well. So I'd say when you think about it, so broader context, Amazon, our process when it comes to defining any services is we go through a customer working backwards process where we write a press release and an FAQ. So pretending we are about to literally, what would we say on the day of launch to the press and also to the developers to explain what the service does and so forth. And when you're explaining a new concept like Dynamo, again, it is super obvious now, but in a world at the time, databases meant everybody thought of SQL databases. Explaining this concept and why it is different, why it needs to be different, what are the benefits, kind of forced us to think about also getting crisp in communication. Let alone we had some innovative concepts like provision throughput and how do you explain all these things. So as we started doing more and more AWS services, I still remember people asking me, and I don't know, Joe, if they ask you now, what is the original DynamoDB PR FAQ like? It used to be called, I think, Big Bird, I suspect. So that PR FAQ is probably still popular internally among product managers, right, Joe? So.
Yeah, it's funny how many people ask me for it, and when it comes up. I think one of the questions it happens is, was it serverless at launch? And I think, we kind of reflect back on it, like DynamoDB was serverless, it was NoSQL, back in 2000, back in 2012. And, we have this saying that we talk about a lot is, there's really no compression algorithm for experience, right? We've been operating, serverless NoSQL at, internet scale with consistent performance. What have we learned over the years, from DynamoDB, operationally, and how has that really benefited customers as we take, not only as we just turned the crank on the product definition, but as we've operationally got better at running a database over a decade to the point where it is for customers now.
As well, yes, actually, Dynamo was a serverless database, even I guess before the term serverless existed. But the biggest thing I would say is, first of all, the need for extreme, always on, highly available, and highly reliable, seamless scalability is ever so important than even 10 years ago. So nowadays, you don't run into any websites we go and you say, hey, we are down for maintenance and come back maybe tomorrow morning. Because and those kind of apps, they actually you don't even run into them anymore. And we don't even accept it from if you are like a 100-year-old bank anymore. So that kind of Dynamo set the bar. However, as we actually progressed through over the years on Dynamo, one of the things we learned was that people still wanted more and more query flexibility, so which led us to add capabilities like secondary indexes and document interfaces and storing document databases and so forth. But and then they wanted the ability to bridge transactional and analytics workload, which kind of led us to start also building things like Dynamo Streams. And then now in the world we live in, it's not just about replicating data within availability zones, but they want to be able to also do things like also replicate across multiple AWS regions. And this has led us to start building global tables as well. And where you actually get, without having to set up any major replication pipelines, all these things, being able to do that as well. And but the biggest thing I would say, all these features, we still hold ourselves near and dear to our heart, is that it should not compromise the core tenet of high availability and seamless scalability as well. And I'm leaving out so many other features like backup restore to various other encryption at rest and whatnot, but still the message is the same. And it is very, very interesting to see 10 years down the line where we are. And I also think we, as a broader industry and database, also think the learnings is not to push the complexity to customers on bridging from transactional world to analytics world and being able to do machine learning. So Streams was a great story of how you can build the bridge, but we will continue to innovate more and more on behalf of customers also to make it easy for customers to be able to analyze their data on Dynamo and all our database services so that they can put that data to work on behalf of our customers.
All right, everybody. Dr. Swami Sivasubramanian, thank you very much for joining us today. This has been a fascinating retrospective on the last 10 years of DynamoDB, and it really makes me excited to see what happens in the next 10 years. So thank you very much.
Same here. Hey, thank you for having me.
All right, what an amazing conversation. If you didn't learn anything from that, you're crazy. There's a lot of good stuff going on. I'll tell you, we have a great chat going on. If you're not involved in the chat, I encourage you to jump in the chat and follow the discussions going on. We have moderators from the DynamoDB team in there answering questions. So you have the experts watching this, answering questions. We're also going to grab a lot of these and talk about them in the office hours, which appears later today. You can see here, I've got the agenda posted. So if you're looking for what's coming up later, check it out. Or you can also open it on your screen at s12d.com/DDB-agenda. Okay, coming up next, I'm pretty excited about this. I'm going to go ahead and bring him on, Jeff Barr. Welcome, Jeff.
Oh, hey, Eric. Good to see you.
There you are. Good to see you too. I'm also going to bring on a couple of heroes. Now, there was some Twitter banter going on that the four of us really would be on screen together, which is nothing but shenanigans. But I'm going to take off in just a second. But I'm really excited, one, to hang out with Jeff. I love hanging out with Jeff in chatting. Jeff has incredible Lego sets. So there you go. That's probably more important stuff, but those are cool. Jeremy and Alex both have tremendous respect for. They both do a lot of work in the serverless community in general, as well as with DynamoDB. You've heard the joke. Alex literally wrote the book, and he really did, and we'll be posting links to that as well. With that, I'm going to turn it over to y'all. I'm going to get out of the way before they jerk me off. So before they pull me out and I'm not allowed to talk. So we'll see y'all in a bit.
All right. Well, Eric, thanks for the intro and the kind words. And Jeremy and Alex, great to see you both. So before we dive in, I've got one tiny caveat. I'm actually waiting on a repair person to show up. And the highest resolution of time he could give me was sometime this morning. And so odds are that he won't show up while we're streaming. But if he does, you'll hear my dog bark, and I'm going to have to go and let him in, and then I'll be right back. But I'm sure between the two of you, you can more than hold your own for a minute or two. So it's been a really exciting 10 years for DynamoDB. And I went back, I took a look at my original blog post, and looking at that, I'm thinking, wow, I was actually pretty excited, because this is how I launched that post. I said, and I'm quoting myself here, quoting 10-year younger Jeff, but we want you to think big, to dream big dreams, and to envision and then build data-intensive applications that can scale from 0 users up to tens or hundreds of millions of users before you know it. We want you to succeed, and we don't want your database to get in the way. Focus on your app and on building a user base, and leave the driving to us. Well, I don't think I can hype something much more than that, but it has been a pretty amazing first decade. I always try not to play favorites, because people always say, well, pick your favorite launch or your favorite service. And I say, hey, it's like picking your favorite child or your favorite grandchild, which you'd probably not want to ever do. But some of the things that I look back on and say, wow, what were things that really jumped out at me as a big step forward. So first the initial launch in 2012. We launched JSON support in 2014. The streams that Swami mentioned in 2015. 2017, a couple good launches. We had auto scaling and the global tables, which I think are super cool and really, really powerful. We did encryption and transactions in 2018. 2020 were particle queries. I picked 5 just because I happen to have 5 kids, and so far 5 grandkids. No pressure to have any more from my kids. I know at least one is watching, but 5 grandkids so far. I loved how Swami talked about how a customer could scale up to a trillion objects, which is like, that's a big number. And usually when you start to think about a trillion, it's like, wow, how many different things do we need to rethink and redesign and rebuild and migrate? And it's like, nah, none of that stuff. Just keep throwing data at us, and we'll take care of all the messy stuff behind the scenes. Anyway, so let me introduce Alex and Jeremy really quickly. This is how Alex describes himself. He says, my core specialty is in Amazon DynamoDB. I'm the author of the DynamoDB book, a comprehensive guide to data modeling with DynamoDB, and the external reference recommended internally within AWS to its developers. I've been recognized as an AWS data hero. I've spoken at many conferences, including multiple reInvents and AWS summits. And I've helped many teams with DynamoDB, from designing or reviewing data models and migrations, providing professional training to level up developer teams. All right, so that's Alex. And Jeremy, he says, I'm a senior technology leader, more than 20 years of experience managing the development of complex web and mobile applications for domestic and international businesses. I spent my early career running a web development agency. I worked with more than 200 companies to spec, design, and build custom implementations to help achieve their corporate goals. Later, I moved into executive management roles that focused on product strategy and development, leading cross-functional teams to concept, engineer, and launch consumer-facing and B2B products and platforms. So we've got the true experts here. We've got we've got the book author, we've got the tech leader who's been helping customers to use DynamoDB. So Jeremy and Alex, great to see you both. Alex, why don't you tell us how did you get started with DynamoDB?
Yeah, sure thing. First of all, Jeff, thanks for having me on. Honored to be here with you, with Jeremy, enjoying this event. It's great. So in terms of when I first started DynamoDB, I always sort of break into segments. I used it first, and I used it incorrectly at first, and then eventually I figured out how to use it correctly. But the first time I used it was at a previous company I was at called Huddle. We were making like an internal Slack application where we just needed to store some data, a small bit of data for like internal applications. And I was like, hey, this is great. I can use AWS Lambda, API Gateway, DynamoDB. All this is just sort of easy to manage. It's not going to cost a thing. I don't have to worry about operations. And it was awesome. I used Dynamo completely wrong. I didn't model it very well, but it was small enough that it didn't matter. And then after that, I went to Serverless Inc., which is where Jeremy is now. I was working with a lot of folks in the serverless community. Everyone's sort of latching on to DynamoDB for the same reasons I was, right? Like it's no operations, super easy to use and integrate into your serverless application. And I was still using it wrong for a while. And it wasn't really till December 2017, I watched Rick Houlihan's reInvent talk like 15 times over Christmas break and like figured out how this all works. And then it sort of took off from there. So that's my journey to Dynamo.
That Rick's video is a must watch, and watching over and over again.
Yep,
definitely
absolutely
worthwhile. It might be one of the highest traffic videos I've seen on the regarding DynamoDB.
I think so, and especially for like talking reInvent talks, I think it's the most watched reInvent talk of all time. So it's definitely a popular one for folks, and it sort of blows a lot of people's mind.
Hopefully someone will drop a link to that in our chat.
Yep, sure.
Jeremy, how about you? How did you get started with DynamoDB?
Yeah, well, again, thanks for having me. It's awesome to be here. This is such a great event. I love that this product, which is my favorite product from Amazon, is getting a featured day as it well deserves. It only took 10 years. But actually, I started with DynamoDB way back in the days of yore, like back in 2013. So I think they had just introduced JSON support when the startup that I was working for at the time. I had joined a small startup. And they had just started using DynamoDB, and they were essentially using it as a sort of like really durable cache. So it was kind of funny. This company I was working for had a whole bunch of engineers in Finland, a bunch of ex-Nokia engineers, and I think the goal was like, let's use every possible AWS service that we can. Like that was our architecture at the time. So we had RDS and sharded databases, and we were using Memcached, and we were using Varnish, and we were using EC2. We were using everything. But what was very cool is that we had all these layers of caching, but DynamoDB actually served a really, really good purpose for us. So we could have things in memory. We did use Memcache to do some things, but having these collections of products, we were sort of a product price comparison company, and having these collections of sort of pre-baked, sets of products just cached in DynamoDB and being able to serve those back quickly. So those were, of course, cached in Varnish, and I think cached in Memcache, and then cached in DynamoDB. But that's how we started using it. It was sort of an interesting use case, and at that point, of course, DynamoDB was. I mean, I looked at it as a nice key value store. So that's how I got started with it.
It's fascinating. I think both of you said we try to use everything, and I've jokingly called that the drink all the Kool-Aid architecture.
Right.
Like we got all these things at the buffet. We might as well just try them all and see how it works out.
Yeah, that's a much bigger task here in 2022 than back in 2013 trying to use all the AWS services. But
indeed it is. But maybe a really interesting challenge for a hackathon or something.
Yeah, exactly.
There you go.
I've got some ideas for that.
To be a multiple day hackathon, I think.
Yeah. So Alex, what after all you've done, all you've learned, what would you say is your favorite use case? When what matches the pattern you say, okay, this is where DynamoDB fits in really well?
Yeah, sure. I mean, I always say it works for almost any OLTP application, so you can use it for that. But like the places I love it, and I think it's just like such a clear step above would be like, hey, serverless applications. Jeremy's going to talk about this later today, so everyone make sure you check out that talk. But just the way it sort of fits with the serverless ecosystem, both in terms of like billing and operational aspects, but even just like the practical aspects of connection management, HTTP, not needing a VPC and all this complicated networking stuff. It just really works great for that. So I'd say that'd be my favorite. I also really just like DynamoDB streams. If you need to insert that item, but also do additional work sort of asynchronously after that. You're not sort of writing it to a database and then writing it to a queue or triggering a step function. You can put it in the database and then asynchronously process it with DynamoDB streams and trigger that step function or fan it out to your other services, whatever you need to do there. So just, having that sort of asynchronicity just built in and chain streamed, I love that part of it.
Awesome. How about you, Jeremy? What's your favorite use case?
Yeah, I mean, I'd say serverless as well. Like when I first started with DynamoDB and I was thinking of it as just a key value store, it was like, oh, this is good. I can use it for caching, or I can use some of these things. But like Alex, I watched Rick Houlihan's 2017 video. My brain exploded. I spent an hour picking up pieces of my brain from around the room. But once I figured out the relational aspect of it and some of those things you could do, for most serverless applications, it is just perfect. And like Alex said, I'm going to talk about this later on today, but essentially, the workflow model of serverless applications, which is this ability to launch a completely independent application stack with all independent resources right there for you, completely isolated. You can give them to your developers. You can give them to all your pull requests and all your feature branches, and then, of course, all of your sort of permanent stages. DynamoDB fits in there perfectly because you can just do an on-demand table, right? And so even if you're only, hitting it a couple hundred times as part of a series of tests or something like that, it costs you nothing to have that, but you still have that independence. And then that's pushed out to your actual production stack where it can handle, thousands and thousands and thousands of requests per second and just kind of laugh at it and keep going. And so being able to take that, have that as part of that application stack, have those independent stacks is just a really, really powerful use case. And if you understand, the relational modeling that you can do, the single table design stuff, there's some pretty powerful things that you can build without needing a relational database. And again, like Alex said, the DynamoDB streams is just a way that says, hey, if I really have some, analytics processing type, workloads that I have to do off of this data, you can do that by just kind of shuttling that somewhere else with streams, but still take advantage of, again, single digit millisecond, latency and just, the isolation stack. So, obviously I love it for serverless, but there's just, it's quite limitless. So, there's a lot of use cases for it.
So I want to dig in a little bit on something that both of you have mentioned in different ways. So Alex, first you said that your first app, you were doing it wrong, which sounds like I'm sure I've seen lots of memes to that effect in lots of different contexts. And then, but Jeremy, you mentioned relational quite a bit, but then if someone who's very much used to a SQL database comes in, they might look at DynamoDB for their first time and say, how's this relational? There aren't joins, and there a lot of the things that they thought were part of a relational model are not there at first glance. So how do you think about that, and how do we reconcile this, and how do we bring the relational means joins folks into the DynamoDB model and do it right, to use
right.
Alex's term? Either one of you, feel free to jump in and help there.
Yeah, I can. I'll take a stab at it, and then Alex can go. But essentially, if you think about relational databases, we're always writing things into separate tables. We think about denormalization. That's the big thing. Third normal form, right? We want to make sure we're not duplicating any data. So when you start moving into higher scale, even if you're using relational databases, you quickly learn that you can't deduplicate all that data. So you have to have data duplication. You have to be able to write data in multiple places so that you can optimize those access patterns and you don't have to actually join tables together. So what's nice about DynamoDB is because it has this partition key and a sort key structure, essentially a partition key, I look at it as a folder. So you say, this is my folder for user 123, and then anything you put in that SK, that sort key, is essentially a file name if you want to look at it that way. So that can then store a document. So if you say, I want to get all of the billing records, for example, for customer 123, then you can use user 123 or customer 123 as your PK, and then you can do like billing record or billing star or something like that, essentially, or billing you can do a wildcard there, right? And so then you can bring back, or it begins with, sorry, I'm thinking of our implementation for serverless data, but essentially you use begins with, and then you can get any record that is named or any SK that's named with that begins with. So that'll bring back multiple records for you, and that gives you that ability to do that relational piece of this. Now, there's a whole bunch of strategies, tons of them in Alex's book. I have a course coming out on DynamoDB modeling, so it's not an easy thing to do necessarily. It does take some time and some effort to sort of learn it, but the benefits of it gives you the ability to break things up into very small chunks, so you can even break up records, right? And you can have that hierarchy of here's my customer record, here's my order record, here are all my order items that are in that particular record. And there's a lot of duplication in there, which is not a bad thing, because then you also have that history, you have that state that is persisted, so you know what the email address was when you actually placed the order, as opposed to what we might have changed it or updated it to in a relational database. So that duplication of data is a big thing that you have to think about, but it's very powerful. And being able to use just a couple of these small techniques, sparse indexes, things like that, you can do a lot of relational patterns, even though it's a NoSQL database.
Wow. Absolutely. And one thing I would just sort of add to that, I tell people, like, with, a relational database, you're often relying on that query planner, and it's doing a lot for you, right? That query parsing and planning, it's doing a lot of work to assemble that query for you, but it's pretty opaque to you. And then also it can get you into trouble down the road if you don't know what's going on. In contrast with DynamoDB, you become the query planner. It forces more work up front, but I also like the clarity it gets at, where you really have to think about your constraints, really have to think about your actual application needs, and then plan for that directly. And then you get all those awesome benefits that Swami was mentioning, that Jeremy mentioned, around consistency, around predictability, around that, at any scale.
So I heard third normal form, and I had this totally bizarre flashback to 1980 something in undergraduate computer science. And this was way before MySQL and PostgreSQL, and databases didn't come across as very exciting. It was all this like weird math and set theory, and this total insistence on like normal forms as the only thing you were supposed to care about. And I'm pretty sure we had to use like mainframe batch processing to access our database. So it wasn't a really enjoyable thing. And I remember the first time I used MySQL 3. Something, it was like, wow, all this stuff that took us hours and was so tedious and seemed like math is actually really interesting and really powerful. And I have to say, really actually fun.
It's true. And normalization is a good thing. Generally, it's really good, especially in analytics systems. If you have ad hoc queries, it's good as you're learning data modeling to understand normalization. But I think, as Jeremy's mentioning, it's nice to know the benefits of normalization, and also when you can sort of relax some of those things and duplicate some data, or maybe nest some data onto a parent object, something like that. Relax some of those constraints and get the benefits of that.
Right. And it's also understanding a little bit about your data, about what's mutable, what's immutable, right? So the data that's not going to change, duplicating that data to sort of enhance or to make an access pattern more performant, is not necessarily a bad thing. And then sometimes you do have data that is going to change, that you might need to replicate in multiple places, but DynamoDB has introduced transactions. I mean, there's all kinds of ways now, that we can deal with that. So it's a powerful system to do all these different things.
So some of this really here is thinking differently and not bringing too many of your preconceived notions of what a database is or isn't as you step forward into the DynamoDB model, it sounds like.
Right.
Yeah,
right.
Absolutely.
Cool. So we talked a little bit about use cases, but let's talk a little bit more kind of like actually building things. So what's your favorite thing you've actually built with DynamoDB?
Sure, I can go first. I can't actually take credit for building this one, but actually helping out with it. I worked with Seesaw, a learning company, back in the summer of 2020. This is like an application that's used in, I think, like 75% of US classrooms. It's a way for like teachers to share stuff with parents, things like that. And, they just had their usage really spike when COVID happened. We had more remote learning, and they just had, a lot more usage than they had before. And they're in the summer of 2020, and they can see this fall spike coming in. Think of the variability they have, not just within a day or within a week, but actually within the year. Think how much more traffic there's going to be during the school year as compared to the summer. and they want to have predictability around that, around cost, around performance, around operations, and all sort of that stuff. They sort of had a mix of DynamoDB and Elasticsearch, and Elastic, I think, was being a maintenance burden there. So just like working with them and working with, terabytes and terabytes of data and figuring out how can we optimize this and get some predictability around our performance, around our costs, around existing features and new features that we want to roll out. How do we think about that stuff? And I just think it's so interesting how you can do that with Dynamo in a pretty predictable way, in a way that I think is really hard with a relational database. I mean, you can do some load testing and things like that, but it feels hard for me to like get good confidence around how that's actually going to perform as compared to DynamoDB, where it's a lot more straightforward.
So you don't have to think about the database as the thing that's ultimately going to get in the way.
Exactly. Yeah. Not like it pushes all your sort of scaling decisions up front, and it's very predictable about what's going to happen there, rather than having this black box and being like, man, I really hope that works, or I hope we can at least scale it up enough till it works. With Dynamo, you have that predictability. You can also scale up and down, right? So Seesaw, they have, like I was saying, way more usage during the school year or during the school week as compared to the summer or the weekends. They can scale that back down and save a lot of money, which is really tough to do with a relational database. It's usually just a one-way ratchet going up there.
It's funny how all of the scalability talk just sounds theoretical until you actually have to live it. And if you don't have to think about, okay, what if we get 10x as many users as we planned, or 100x or 1000x? It's like, okay, well, surely there's things we're going to have to work on in our system, but it's likely not going to be the database.
Yep, absolutely.
How about you, Jeremy? What's your favorite thing you built?
Yeah, so I mean, actually, my favorite thing that I built, I think, are tools for DynamoDB. So I have spent probably half of my career building abstractions and trying to find the right abstraction. I always say I don't think I'm a great programmer. I think I'm a pretty good architect, but from a programming standpoint, I just want to make my life easier. And one of the challenges I had with DynamoDB when I first started using it was the API. And it's like, what is this? Capacity. You saw all these different things, and you're like, what do these things even mean? And scan forward index false. Like, what are we talking about here? And these things just sort of became the terminology was kind of tough. So a couple of years ago, I built an open source tool called DynamoDB Toolbox. And essentially what I did was build sort of a thin layer on top of the API that just made it really easy for you to define entities for a single table design. And then you could use that. It would write into the record itself, or into the item, an attribute. It would write what type it was. And then when it came back out, this package would automatically modify and transform it so it was back in the right format and the right structure for that particular entity. And I love that. A lot of people are using it now. It's super exciting. I've fallen a little bit behind on that. So anybody who is using that library, I will put some time into it, I promise. But the reason why I haven't put time into it, because over the course of the last year or so, working at Serverless Inc., we've built out this new system, or this new platform called Serverless Cloud. And one of the first things we built for Serverless Cloud, and I have some very smart people working on other parts of it, but the data piece was sort of like mine. Like, I'm like, nope, I want to do this. So I built another sort of like a DynamoDB toolbox, but it is the most simplified form of an interface into DynamoDB that I think you will see. It's simply set, get, and remove, and then it has some semantics built into the way that you structure the key, the actual item key. So you say, users : 123, for example, and that automatically creates, the PK and the SK for you. You can do GSIs with labels. So it is a very, very cool interface. I really love it. It makes working with DynamoDB so much simpler. And so, yeah, I'm pretty proud of where that is now. We've got a lot of other things we want to add to it, but that has automatic streams built in. So then we have this thing where you can do data.on and read right off the streams and process things asynchronously that way. So it's a pretty cool. It's sort of like the best abstraction I've built in a long time. So I'm very excited about it. And would love people to give it a try and give us some feedback on it.
It sounds like fun, and probably the biggest frustration of my job is that I get to talk about all these really amazing things, and I used to be able to actually build stuff with them, and now I get to think about, wouldn't it actually be kind of cool if I still had the skills and the time to build stuff with them. Right. That sounds really awesome. So you've both clearly learned a ton about DynamoDB and how to put it to use, but what's next on your list? What do you want to learn? Maybe what do you want to learn, and what is your learning style? I always like to understand how people go about learning something new.
Yeah.
Jeremy, you want to go ahead?
Yeah, sure. So, one of the things that I love about DynamoDB is obviously the potential for scale, right? 40,000 RCUs and WCUs right out of the box. You can always raise those limits if you need to. So we're talking about thousands and thousands and thousands of requests per second, and not that big of a deal. Now, I had a couple of applications that we've gotten some good amount of traffic to, but most of what I've built has been, relatively small admin interfaces, things like that. So I really would love to spend some more time digging into scale and the scaling characteristics of it. Right now at Serverless Inc., DynamoDB powers our event bus. We have millions of events that run through that bus every single day. It powers all of our user accounts. So all of the signups, we have tons of telemetry coming from the serverless framework. That all goes through DynamoDB into Mixpanel and all this other stuff. So we're using it pretty heavily there. And again, it just works, right? Just go. So I'm really curious to get to a point where I can look at what happens when you try to send 1 billion requests to it, and where does it actually, does it start to fall down? What's the replication lag when you have to replicate GSIs? What are the benefits of maybe skimming down, not replicating all of the data to the GSIs, but just having certain things? Like, I would really love to dig into that at some point. So I don't know, maybe some Cyber Monday, I'll see if I can sneak into the back room at AWS and watch the team manage that.
Interesting. So you keep pushing the gas pedal down, and it just keeps going and going and going. You're like,
right,
surely I'm going to hit some limit somewhere, and it's not quite happening. Alex,
Absolutely.
how about you?
Yeah, I mean, I agree with Jeremy on a lot of that stuff. The thing about Dynamo is you can learn like the basic concepts and handle a bunch of your applications right away. So I think, once you learn some of those, you can do a lot of powerful stuff. But I always like learning about more advanced patterns, and especially trickier patterns. So if you think about like geospatial or time series or aggregations, like what are different patterns we can use for this? I even bought like a algorithms textbook to like sort of look through some of that stuff and be like, okay, if Dynamo's given me the underlying access to these data structures, how can I structure some of these problems to make that work well? So that's one thing. Another thing I really like is just learning more about like the underlying pieces of Dynamo. Like the Dynamo paper is awesome. The stuff that Swami was talking about was awesome. There's an AWS Dynamo engineer, Jasso, that did a DynamoDB under the hood talk at reInvent, I think back in 2016. That was just fascinating, and just seeing how all these different things work and how that plays out in the different consistency models and replication and all that sort of thing. And we've seen a lot of really cool features since then, transactions, on-demand billing, this new storage IA class, like hashtag AWS wishlist. I would love to see like an updated version of that talk at this year's reInvent, because I just think it's so fascinating to see how it works under the hood. It's
kind of funny, as developers and architects, we love abstractions. We love the fact that we just say, here's the abstraction, here's the API, here's our conceptual model. And we're supposed to be very comfortable and say, no, don't ever think about what's inside. And then the very first opportunity we have to get the slightest glimpse inside, we've actually got to like pull the cover off and say, hey, what's actually inside this, and how does it really work?
Yep. Yeah. It's just fascinating. I love the user facing stuff and how that all works, but it's fun to see what's under the covers too. So it's really interesting there.
Well, as engineers, we always want to know what's happening behind the scenes.
Exactly. Totally. So give us a tip or two for someone who's wanting to get started with DynamoDB. Maybe what's the first couple things that they should start by learning or doing?
Yeah. Without plugging our stuff, I got the book, Jeremy's got the course, definitely get those things. But I would say like, first thing you should understand is working with DynamoDB is very different than working with a relational database, and do that first. Don't try and model it for a relational database, because I think a lot of people do that and then get frustrated about how that works and give up. But like, understand that it's different. So do some work to figure out how it's different and how you should be approaching it. Understand how the primary key works, and especially, composite primary key, a partition key, sort key. What are those patterns for doing some of that stuff? Get a sense of that and try that out, and make sure you're really modeling Dynamo first rather than trying to fit a relational normalized model onto DynamoDB.
Ooh. So you really actually need to understand your application's data needs and the way DynamoDB can meet those. You need to really have a good sense of both of those to get a good start, it sounds like.
Absolutely, yeah, and it's access pattern first design. You have to know your access patterns and design your table specifically for that. So to do that, you need to understand your application. You need to understand what Dynamo gives you, the access to sort of the lower level tools of this database, and make those merge for a really good experience there.
Jeremy, what tips do you have for us?
Yeah, I mean, I agree with Alex. I would disagree a little bit about always needing to know your access patterns first, though. I think that, if you design your table properly, meaning that you follow like sort of first principles for DynamoDB single table design, you get a lot of flexibility out of that. So you're really not trapped. You always have the ability to add another GSI. And the biggest advice that I give, I know Alex gives similar advice in his book, is you want to make sure that any of the PKs or SKs that you're using, whether they're for GSIs or for your primary index, you want to make sure that those are independent, right? So those are their own, they're their own attributes. So if you're storing an email address for somebody, store that email address separately in an email attribute. And then, if your key is, user : email address or something like that, no, store that there. But there's no problem duplicating a little bit of data there, right? So don't worry about that. It's very, very low cost to store an extra, 20 bytes of data or whatever it is. So I always suggest that. And when you do that, that gives you a lot of flexibility on those secondary indexes, and you can go ahead and run something that will update all those secondary indexes for you if you need to, without messing up any of your primary data or any of the data that's stored there. But I would say, again, I think the big thing to look at is there's a lot about breaking up data, which is different than the way you would break it up in a relational database. So in a relational database, you might have the customer, you might have the orders, and so forth. What I like to do is say, if you think about what data you have to retrieve in a single go, and if you have small bits of data that you need to retrieve, you can break that up into a single item. And if you need to get more than that data at the same time, then design your keys in a way so that you can actually retrieve multiple bits of data at the same time. So you might want to just get an order record. You might want to get the customer in the order. You might want to get the customer in all the order records and all the shipping information and all this other stuff. So it's fairly easy. I don't want to say easy. That's the wrong way to say it. But it is possible to design your table in a way to handle that. And a good example I like to give, especially because I think we talk about scale a lot. Not every database needs to scale to 78 billion transactions or whatever it is that, happens on Cyber Monday. So a really great pattern is think about, using multiple GSIs, especially if you don't have a ton of data. And by the way, by a ton of data, I mean a couple hundred gigs or more than a couple hundred gigs. Anything below that it's child's play for DynamoDB. But a great pattern is this idea of saying, use the first couple letters of an email address as your partition key, then the full email address as your sort key, and then you can do type ahead. So you type in JE, that immediately goes to that PK, and then you can do a begins with on the PK and filter down emails. So let's say you're building how many accounts are you going to have in an accounts table? Even if you had a couple of million, again, not even a problem to use a pattern like that. So again, that was a lot, but there's so many cool things you can do.
That's
Jeremy,
actually really cool. Oh, Eric's got a question here.
Would you use configuration over code on that?
I probably would, yes.
Yes, I love it. All right. Well, rarely am I the person sent in to stop the talking, but because I usually increase it. But I wanted to let you all know that we're going to wrap up. I think Jeff, you had a couple wrap ups you wanted to do though, real quick.
Yeah, Jeremy and Alex, this has been a totally awesome conversation. Really enjoyed seeing and speaking with both of you. Give us a 37 seconds each on your upcoming sessions.
Sure. I'm going to go first. Okay,
Sure.
So I am doing a talk on serverless plus Amazon DynamoDB as being the perfect data companion. So it's a little bit high level. We're going to talk about the different serverless services that AWS has available and sort of what the integration models are, as well as the security models in order to integrate from your serverless application into DynamoDB. And then we'll talk a little bit about security more. We'll talk about some best practices around that and some data integrity stuff, and then wrap up with just a few sort of insights on serverless development workflows and how DynamoDB and just serverless services in general sort of fit in really well to what I would call the ideal sort of development workflow in the cloud.
Sounds great. I'll be watching. Alex?
As will I. Yeah, excited to see everything today. My talk today, it's going to be about data modeling and really about the data modeling process with DynamoDB. This is something I talk about a little bit in my talks, but I want to go deeper on like what that modeling process is like, how it's different than relational, and how you should be building out your data model. So I like to call it data modeling process plus, where we really just like sort of dive into stuff about the data modeling process and hopefully learn like what that pattern is like.
Nice. I'll be watching that as well. All right. I thank both of you for your time. This has been awesome. I have learned a lot. I hope our audience has as well. And Eric, back over to you.
All right. Thank you very much. So we're going to actually bring in Giselle. And Giselle is going to be discussing, she's going to be talking about several things with DynamoDB here. Tell us what you're talking about, Giselle. Uh-oh. We got you, Giselle? Can you hear us? Okay, we cannot hear you. I think we have an issue with your mic. Let's see if we can get that fixed. If not, all right, so I'm going to pop in here. So one of the questions we had, I asked Jeremy, hey, what is configuration over code, or would you use configuration over code? One of the examples of that in actually Jeremy's specific conversation was we could actually connect API Gateway directly to DynamoDB. And that's done through VTL. Now, I did have someone post in the chat say, "Oh, I didn't even know that was possible." It is possible. It's not for the faint of heart. I'm going to be real honest. It can be a little challenging, but there's a lot of power in that. And I have a link to some examples that I'll post in just a minute. But we do have Giselle coming in here.
Can you hear me now?
Yes, we can.
Awesome.
Wonderful. You're going to be talking about DynamoDB customer stories featuring... Who?
Featuring lots of customers.
There you go. Very good. Yes.
We've got lots of customers. Thanks, Eric. Gotta love technology. Really enjoying everyone's sessions here. And we're going to actually kick this off with a little bit of a customer segment, if you will. So I'll kind of review some of the high-level, most recent customer stories, right? DynamoDB has been here 10 years, and we've certainly got some customer stories to share. And then right after me, we're actually going to talk about, Smug Mug CEO, Don McCaskill, is going to be joined by Joe Itzurek again. So we're going to be able to hear from him. And then we've also got some engineering leads, and Anureed Jayakumar from Dropbox, who will be joining us as well. So with that, let's go ahead and get started. All right. So first off, thanks for joining our Decade of Innovation with DynamoDB event. My name is Giselle Goikachea, and I'm the Senior Product Marketing Manager for DynamoDB. I'm going to spend a little time here reviewing what these customer stories are, but really showcasing the scalability and performance that this fast, flexible NoSQL database can provide. So let's go ahead and go to the next slide. All right, so as you may have heard today, Amazon DynamoDB is a fully managed NoSQL database service that provides fast performance at any scale. Web applications often encounter database scaling challenges when faced with growth in users, traffic, and data. But with Amazon DynamoDB, developers scaling cloud-based applications can just start small with just the capacity they need, and then increase the request capacity of a given table as their app grows in popularity. So some of the key benefits you can see here, obviously performance at scale. We've been talking about that a lot today. Enterprise ready, fully managed, and built-in integration with other AWS services. I won't go through all of this right now because we'll actually have a getting started session a little later this morning where we'll review our core features and capabilities in a little bit more detail. But for now, let's go ahead and jump into our customer stories. So it's been 10 years. And obviously, we've got hundreds of thousands of customers who have chosen DynamoDB. And right now, we're going to go through some key use cases. This is just an overview of some of the key use cases that DynamoDB, where it's the right tool for the job. And we're going to cover some from gaming, retail, media and entertainment, and software and internet. So we'll start off with Amazon.com. Now, we know that every year's Prime Day is an annual tradition for many consumers around the world, and AWS plays a critical role in making Prime Day a success, and DynamoDB is one of these key services. Amazon DynamoDB actually supports multiple high traffic sites and systems, including Alexa, Amazon.com sites, and all Amazon fulfillment centers. So get this, over the 66-hour 2020 Prime Day, we knew that these sources made trillions of API calls while maintaining single-digit millisecond performance and peaking at 89.2 million requests per second. So the internal Amazon.com herd system, as it's called, supports hundreds of millions of active workflows. So you can see after they migrated the Amazon.com from Oracle to DynamoDB, there are some extremely big benefits. Improved customer service, reducing cost, and reducing complexity and risk. So let's move to the next one. The Pokemon Company in the gaming space. They wanted to address the complexity of managing NoSQL and memory caching systems for a database of more than 300 million users. In this case, the Pokemon Company migrated to several AWS purpose-built databases. So they use Amazon Aurora as the main user database, Amazon DynamoDB to kind of help reduce the bot login attempts that they were getting, and Amazon Elasticache to enable dynamic caching of user logins. The key benefits, as you can see here, reducing bot login attempts by 90%, eliminating database licensing costs, and experiencing 0 hours of downtime. Be sure to check out the case study for this on our DynamoDB customers page, and we'll be sharing that link in the chat. Moving on to Snap. So Snap was founded in 2011, a year before Dynamo, and is a social media company that empowers people to live in the moment. But its flagship app, Snapchat, with over 290 million daily global users, was getting to a point where they wanted to reach the scale, and they needed to modernize their legacy monolithic infrastructure. So Snap was born in the cloud, and as part of its evolution to provide this compelling experience for hundreds of millions of users, made the move to AWS. So they actually use DynamoDB across several use cases, including obviously that mission critical messaging service. It helps them to scale, it helps them to reduce latency and save on infrastructure costs. So this modernization also enabled Snap to build the regionalized database structure it needed so that they could have low latency to users around the world. So you can see the key benefits here, obviously reducing the latency, scaling up to handle over 10 million queries per second on some of these really high traffic days, enabling consistent low latency performance for users around the world, and optimizing the annual infrastructure costs. Again, this is another key case study that we have on our DynamoDB customers page, so check that out. All right, now Mercado Libre. So with nearly 79 million active users in 18 different countries using its businesses, Mercado Libre needed to standardize and simplify its data management for thousands of core applications. So my favorite tidbit of this one is there's literally a team of 6 engineers, and without having to change a single line of code, they were able to migrate 5,000 databases to Amazon DynamoDB, gaining that automatic scalability to just basically grow and have the cost savings that they wanted at the same time. So some of the key benefits, obviously, you can see here, reducing the costs, generated a combined latency of 6 milliseconds for the 99th percentile of read requests, and then improving availability for customers by using this multi-region architecture. So although Mercado Libre originally selected DynamoDB as kind of a way to offload some of the operational overhead and support its massive scale, they're actually continuing to unlock new capabilities, which is allowing the company to kind of continue to innovate and grow in Latin America. They also did a case study, and that is also featured on our website. And now we're going to move to Disney Plus. Now, many of you have obviously heard when they launched in November 2019, they're the home of Disney, Pixar, Marvel, Star Wars, and National Geographic content. And Amazon DynamoDB is proud to be one of the technologies that supported this global footprint. So some of the key things, key reasons rather, why Disney chose DynamoDB was being able to help with this multi-region replication, to get to that single-digit latency, obviously across the world to its customers. Adding AWS region and global tables helped them launch in new countries. and then scaling some of the recommendations and bookmarks so that they wouldn't have this operational overhead. So having the ability to switch back and forth between some of these capacity modes also helped them as well to save on costs. Definitely check out the reInvent session from our Disney customer from 2020, and they go deep dive a little bit more into how they used it to deliver popular features such as continue watching, watch list, and personalized recommendations. All right, so we've got Dropbox. Now, Dropbox has more than 600 million registered users across 180 countries. We're actually going to hear from Dropbox in a little bit from Anirudh, who's going to be joining us, and he's actually going to be deep diving into this architectural solution in just a moment. But in the summer of 2018, Dropbox experienced this capacity crunch on its on-premises metadata store due to fast data growth. So they had less than 2 years, they kind of estimated, before they kind of outgrew that homegrown solution. So they sought out a fully managed cloud solution with AWS, and ultimately they chose DynamoDB and Amazon S3. So you can see some of the key benefits here. They were able to migrate this audit log data from a legacy database in less than 2 weeks. They were able to launch that metadata storage system in a year. And then they were able to scale for virtually unlimited user metadata with high performance, ingesting data during the migration of up to 600,000 queries per second. But ultimately, they were able to save money to the degree of reducing a per user gigabyte cost by a factor of 5.5. And then we'll end here with the customer stories that we've got to share today from Zoom. Now, obviously, Zoom video communications you may have heard of. They're a leading provider of video-first unified communications. We've all been in Zoom meetings for the last couple years. And so Zoom used Amazon DynamoDB global tables to help them scale to meet the growing demand caused at the start of this pandemic. I won't read this to you, but here's the quote from our customer Zoom. I think the biggest thing to highlight here is that they saw this unprecedented usage grow from literally 10 million to 300 million daily meeting participants from new and existing customers. So with DynamoDB, they were able to manage that surge with absolutely no change in performance. So that's a really compelling quote we definitely wanted to share. And hopefully you learned a lot about some of our customers today.
All right. Amazing, amazing stories going on. And we have another one coming up. Joe is joining us, and also Don McGaskill, CEO of SmugMug. Really incredible story here. And Joe, I turn it over to y'all.
All right. Well, thanks for having us. And thanks, Don, for joining us. For folks out there today, Don McCaskill is the co-founder and CEO and chief geek of SmugMug and Flickr. And Don is particularly relevant and a big part of this day because Don is, I like to call, his customer zero for DynamoDB. We always work backwards from customers. And Don was really one of the original customers we worked backwards from many, many years ago, and one of the big reasons why we're here today. So Don, thank you for joining us. And to start out with, if you can share for the folks just to kind of set the context for what we're going to talk about as we kind of progress on SmugMug and Flickr's usage of, what SmugMug and Flickr do and the problem that you folks all set out to solve. And then we'll talk about all the weedsy backend database stuff that supports those customer use cases.
Yeah, thanks, Joe. So I co-founded SmugMug 20 years ago, and we just couldn't find a great place to host our own personal family photos online. We're a family of photographers that was high quality and durable and kept track of every single pixel, every single byte. So we built one, and over the years, it's grown into a very large platform used by millions of people all over the world. To safely store all of their priceless photos, their memories, to operate their photography business if they're a working professional photographer or something. And then about 4 years ago, we had the opportunity to expand by acquiring Flickr from Yahoo. And Flickr is now about 18 years old, so also another long-lived, very large platform. And combined, hundreds of millions of people use the two platforms every year. Flickr is the largest photography-focused community in the world, and the best place to get inspired by photography, connect with other photographers, and share your work. So we've had a ball building both companies, and in particular, that Flickr acquisition was really interesting from a DynamoDB perspective, because we had to lift and shift Flickr, a very large platform, out of multiple Yahoo data centers and into AWS while keeping it online and running. And DynamoDB was one of the most important core technologies that enabled us to do that.
I can't wait to hear all about that. No, and thanks for spending the time. Your continued support and influence on a DynamoDB product is really legendary. So thanks for being with us today, Don, and taking the time. All right, so let's kind of go back. Let's go back before DynamoDB. What did your database architecture look like back in those days, and kind of what were some of the issues that you were struggling with, and some of the design patterns that you were using?
Yeah, so we're a pretty traditional LAMP stack. We are using MySQL on our own servers in 5 different data centers. And we were just running into staggering scaling challenges and complexity, because that database was just a single point of failure that had to stay online and be operational, and was getting more and more use as we got more and more customers, and those customers shared their photos with more and more people in their lives. And so we had to resort to all kinds of harebrained partitioning schemes to start chunking our data up across multiple clusters, and all kinds of replication, and lots of pain around failover when we'd have a primary die or something. And it was just it took up a huge amount of our time, effort, and energy, and was yet a super core component that without it being online, our service wasn't online. So, our customers depended on us behind the scenes to kind of make this spaghetti mess of lots of MySQL clusters fast and operational all the time. It was definitely one of our major scaling problems.
And when you think about how did you actually use MySQL in a way to help you scale? This is kind of before the DynamoDB genesis it came about, but what were the different things that you did to kind of constrain your usage of MySQL to help you scale?
Yeah, so, a whole bunch of interesting technical things were happening right around this time. We were finally able to get commodity servers that were 64-bit CPUs and had more than one core. So we could make our servers bigger, which we did. We bought as much RAM as we could and as many cores as we could. These were AMD Opterons. But even then, we were running out of capacity. And so as we analyzed our data access patterns, both reads and writes, it became really, really clear that we were just consuming way too much of our capacity by using complex relational data model stuff. So things like joins and stored procedures and stuff like that were not only consuming a lot of our resources, but they were contributing to a lack of predictability on our front for the application being able to know, hey, is this query going to return quickly, or is it going to take a long time? And of course, there's thousands of people, millions of people in some cases using the system all at the same time, all issuing these variable return, time queries. And it was just clogging our infrastructure. So we began to just ban using a lot of relational data model and relational techniques from our code base and our applications, just to try to minimize the load on the servers and maximize the predictability of our queries. So we essentially converted MySQL into just a plain key value store with indexes. And that enabled us to, like I said earlier, start partitioning our data in really interesting ways, because when you don't have to join across it and you can rely on the data being in wildly different clusters, it gives you a lot more flexibility at the database layer. But it does complexify some of your code, right? You have to do those join-like operations in your application code instead of down at the database layer, which improves scalability, improves predictability, but does result in quite a bit more complexity. And we were quite frankly using a system, MySQL, for a purpose it wasn't designed for. It's not a key value store. We proved that it could be used as one, but that wasn't its original design and intent.
I always, it's funny. It's like, it's kind of very similar to, Amazon.com's use case. And I always say, hey, any relational database can be a great key value data store if you use it like one. Can you tell us the story about when you first started to learn about DynamoDB? What were those conversations like with AWS leadership and kind of the role that you played there, and some of the feedback that you were kind of giving to, Werner and Swami and the folks back at the time?
Yeah. So, luckily, we were also the first customer for Amazon S3. And so we had been using S3 for quite some time, since late 2005, which predates its public launch even. And so Amazon was kind enough to invite us to sit on their customer advisory board as we learned about some of the other services coming in the pipe. So we got to learn about EC2 and SimpleDB and SQS and all the other early services for a couple of years. And we got to contribute a lot of feedback for improvements on those services, that, we needed more than one instance size in EC2, and we needed a bunch more features in S3 and all this sort of stuff. And Amazon was listening very diligently, and months or a year or so later, they would ship those features and then come back and ask all of us, the advisory board members, for more requests. Well, at the same time, we were dealing with this scaling nightmare on MySQL and had made this technical transition to treating it like a key value store. And I had read the Dynamo paper, and there were beginning to be open source implementations of the Dynamo paper, like Cassandra. And I knew Dynamo, the technology, was in use behind the scenes at S3 too, and presumably other AWS systems. So I just started asking the team, especially Werner, to build a database that we could consume, that would be Dynamo. And initially, he was listening. He's a great listener, but just kind of felt like maybe that was kind of too big, and that we were an outlier customer, and there maybe weren't other customers that necessarily were doing this crazy stuff that we were doing. But he listened very carefully, and I just kept pestering him, and I kept saying, hey, look, there are open source versions of this coming out. We're going to switch to that and use that. If you don't provide one, we'd really like you to provide one. And then we had some discussions about, hey, isn't SimpleDB enough? Well, no, because we're talking about vast quantities of data and growing at a really fast rate. So we had already outgrown SimpleDB, the first AWS cloud database. And eventually I pestered Werner so much that my understanding is he shot Swami an email and said, hey, can we have a meeting and talk about this? Because I really need to get Dawn off my back. And so Werner, Swami, James Hamilton, and I sat down and talked about it. And I just, again, laid the plan out. And this time around, everybody looked at each other and said, okay, yeah, this is compelling. We should probably go build this. Let's go talk to some other customers, make sure Dawn isn't the only one, which they did. And turns out, no, I wasn't the only customer. There were other AWS customers, and they went off to go build it.
I love that, just from the fact of, and I know you and Werner are kind of going back and forth on Twitter a little bit of kind of being pestered by Dawn is kind of a meme or a rite of passage, if you will. But, we build products at AWS. We work backwards from customers. But a lot of the times I tell my team is, I want to know who the customer is, right? Like, don't just tell me it's, SmugMug. I want to know it's Don at SmugMug. And I want to know what his problem is. I want to know why is his problem. And I just love, these kind of early stories about, some of the kind of most influential people we have in AWS working backwards from customers and taking that feedback and going out into, developing products that, now, hundreds of thousands of people use. So clearly you're onto something, in your usage. So Many people might not know this. On the day of the launch, on January 18th, 2012, you were actually live in studio with Warner and Swami and Ariel, doing a live broadcast, which we found on YouTube. What was it like on that day? And how cool is that to be a customer, being part of that event as well, and now kind of being here 10 years later?
It was super fun. It was thrilling to just be invited to participate. We had already been using it in beta, and we were super, super thrilled with its performance and especially its predictability. Just, that continues to be my favorite feature of DynamoDB, is just how predictable and consistent the latency and performance are. So I was super thrilled. And of course, Werner and Swami and I had been talking about it throughout development. I don't remember if it took 1 or 2 years, but about 1 or 2 years to develop and beta test and ship and everything. And so we were all pretty giddy about it at this point, because it had become even more clear during development and as other beta customers began using it that this was going to be a game changer. And it was something radically new and different, and was really kind of the continuation of something that had begun with S3, which was what we now call serverless, right? This idea that you can have massive, massive systems without running any of the systems, right? You just make API calls and magic happens. And so they invited me to come up to Seattle for the live announcement. I think this is the very first service announcement Amazon had ever done live. Well, it turned out that Seattle was frozen over that weekend, and so we could barely even get up the hill through the ice to get to the studio. And we were thrilled when we finally made it and sat down and got ready to announce what we all felt like was going to be a game changer. So that was a super enjoyable, fun experience to be reunited with them on the morning of launch, having sort of ideated the idea just a couple of years earlier.
It was a fun video to watch, and hopefully somebody can share it. You guys all aged extremely well, so I'm very jealous. It was actually fun. So go ahead, Don.
It's out there on YouTube, so it's pretty easy to search for and find. And anybody that is into databases and stuff, you'll probably want to watch it. It's pretty neat watching sort of a new era being born.
Yeah, it's a great artifact to have and to be able to go back to. And we kind of played an earlier clip of Warner just kind of pitching DynamoDB, and it kind of resonates with a lot of things you're saying. Is the core message and the core value prop really hasn't changed. We've added a bunch of new features, we can do a bunch of new things, but that consistent performance at scale, and then the serverless and no ops is still very true to the core of what we do. I also noticed on that launch day, you were wearing a Superman shirt. You're also wearing a Superman shirt. Is there a connection there?
Kind of like Werner is famous for wearing rock band shirts when he speaks. I tend to wear superhero shirts when I speak. And when I watched that video just a couple days ago for the first time in, I think, 10 years, I noticed I had been wearing a Superman shirt. So I went rummaging around in my vintage superhero t-shirt collection. I was sure I had that t-shirt, that exact one, somewhere. I couldn't find it this morning, but I did put on another vintage one that I've worn before, and I when speaking, and I don't know, I'm obsessed with superheroes and always have been.
I appreciate the attention to detail, and I noticed, so it was appreciated. So, after the launch, so you launch that event, it goes live. How did the technology world react to this new database that Amazon and AWS had just put out? What was kind of the reaction in the community at that time?
I think the short-term reaction in the first few days, few weeks, was kind of skepticism a little bit. That is this really possible to deliver something that really delivers that scale and that predictability? I remember during the launch, Swami had pulled up some charts with numbers and everything, and the latency line was just flat, even at very high scale, just flat, which you really don't see in a database system, as certainly didn't a decade ago, but it's still difficult to achieve today on many database systems. So there was a lot of skepticism. And it kind of reminded me of when S3 launched. There's a lot of skepticism, like, oh, really, who's going to like trust their binary data to a bookseller, which people were thinking Amazon was back in 2006, right? But it didn't take very long, I think a couple of weeks at most, before people were to begun to get around among the database community, among the engineering community, that, oh no, this thing is so easy to set up and so easy to use. There's only a handful of API calls. You basically, create a record and update a record and delete a record and read a record. That's basically it, right? You got, it's basic CRUD operations, and they were fast and predictable, and it did exactly what the label said it did on the tin, right? So pretty rapidly, within a few weeks, people were building really incredible things on DynamoDB. And my understanding is the internal AWS numbers blew away even the largest projections, internal projections. Everybody was taken by surprise at how successful the launch was.
Yeah, I think just part of just the simplicity, I think, and the consistency have always just kind of been kind of the hallmark, capabilities is, people kind of like when things are consistent, and that kind of helps remove some variables. What did DynamoDB, as you kind of progress, past launch, what did DynamoDB mean to your companies? Obviously your customers just want a great experience, but what did it mean to your teams in your company as you guys progressed and built on top of it?
Yeah, initially it was just great to have a second database option when engineering new systems, right? It used to be, well, it's all MySQL all the time. All of a sudden we had this different system to choose from and work into the mix. And it had very different characteristics. We still use MySQL, mostly Aurora today, because it's a valuable, useful data store that's different from DynamoDB. But this was kind of the beginning of the age of us having selection, right? There was finally a purpose-built database for what is the vast majority of our workloads. And of course, now today we know that there are a lot of purpose-built database systems, and now we have choice in the form of like a dozen different systems. But just moving from one to not one was a really big step for us, and it definitely accelerated our ability to both prototype new things. Like, it's way easier to set up a Dynamo table and fiddle with it and then tear it down or rebuild it or something like that than it is to like set up a full MySQL cluster and do the same thing. So it really enabled a lot of prototyping at much faster pace for us. It featured in lots of our internal hackathon projects and things. And then most recently, I don't think we could have migrated Flickr without DynamoDB. So it literally enabled us to do something that was borderline impossible. A lot of our friends in the industry said, you're never, ever going to migrate something that large, Flickr scale, live without downtime in under a year the way you did. And so it's been awesome watching this progression where essentially DynamoDB went from this shiny, amazing new tool in our toolbox to just being our default de facto go-to whenever we're designing new stuff.
Yeah, can you tell me more about that data center migration? I want to hear that story of kind of what the challenge you guys were faced with, and what is the scale of what you're operating at, and the timeline you had to perform that migration in.
Yeah, it was a little scary as we were thinking about making the deal. This is one of the big considerations for us is, could we actually do this in time? Because the deal had a timeline. Like, we couldn't just sit in Yahoo's data centers rent-free for forever. So they needed us out as soon as we bought Flickr or as soon as it was feasible. And they really felt like if we worked really hard, we could do it in a year. And we felt like that would be impossible. And so we're kind of at an impasse. But, we did a prototype architecture stack design and tested it out. And DynamoDB was a major core component of it. And we said, OK, well, we probably can. And just to give you some sense of the scale, that was hundreds of, hang on just a second. I have, I think I left the chime open. Sorry. Okay, I'm back. Just to give you some sense of scale, Flickr was, and still is, hundreds of petabytes, tens of billions of photos, more than 100 million users, members, and just staggeringly complex legacy systems. Right, it's an 18-year-old product. And it was built and scaled mostly inside of Yahoo in their physical data centers using proprietary Yahoo technology. So we couldn't take that proprietary technology with us when we were moving to AWS. So we had to refactor and rewrite from the ground up many of those systems using modern cloud-focused AWS services and our own internal expertise. And we had to do it while one of the largest services on the internet remained online, right? That old adage about repairing the engine on a jet while you're flying it in midair, that was what we were doing. And we had 12 months to do it in. So we did it, and we ended up with a couple of weeks, about a week and a half, maybe 2 weeks to spare. Whew, that was pretty tight and pretty close. And it was just a few hours of downtime. Total for the whole year, and DynamoDB became the home for, I don't even know how many, probably trillions of records, and it's just been stable and predictable and consistent like a rock ever since. So it ingested everything as fast as we could throw at it, and it's now every single photo that everyone all over the globe is viewing on Flickr all day, every day. Those are all DynamoDB operations under the hood that are making that possible.
Yeah, I love making that connection. I've been a Flickr user for a long time, and it's always fun, when your product that you work on and people that like there's that connection, that personal connection. And the numbers of that migration are astounding today, let alone 10 years ago. So that's a pretty impressive feat that you all did back then. Even if you did it today with everything that we know now, it's still hard. So that's
yeah, I think it was an incredibly fun, exciting, thrilling, stressful, exhausting year. But I think it's got to be one of the biggest, if not the biggest, live internet data center migrations of all time. So certainly top 10. I can't think of too many other examples that are sort of at that scale. And it was fun and amazing. I still kind of pinch myself, not quite able to believe we managed to get it done.
Yeah, those are ones where it's fun to tell the story many years after, and you look back at it fondly. But I'm sure that was real work. So. Over the years, of course, you've had a front row seat, and you've been an influencer on a lot of other things that we've built in DynamoDB. What have been some of the innovations in DynamoDB or the additional, capabilities or features that we've added that have, helped you guys do more over time?
Yeah, one of my favorites, it's now been there quite a while, but certainly wasn't there at launch, are secondary indices. That was super, super helpful for us, right? I mentioned how we had basically morphed MySQL into being a key value store with indexes. Like that was the extent we were willing to go beyond just reads and writes. Was we did want to be able to list things, and so when DynamoDB added both local and global secondary indices, that unlocked even more applications for us to be able to build around DynamoDB. And then sort of more recently, just in the last few years, I think global tables is pretty amazing. So we are beginning to build out systems that are sort of multi-region by design. And it used to be such a pain to handle all of the data migration between regions and keep them in sync. And it was, quite frankly, it was kind of like a mini version of the MySQL replication headache all over again. And so the fact that it's just been abstracted away from us and we can just add additional regions whenever we want to any given table and magic happens, essentially, is another game changer and is letting us build and innovate around application design in ways that we haven't been able to in the past.
Yeah, I know. Global tables is one of those kind of, active replications, kind of one of the holy grails of databases. And then to do so just with, just having an API and you can blow away tables and create them at will. It's been a big game changer for a lot of customers, and glad to see you guys are able to use it and think into the future. As you guys, if you think about how you're building now, how else do you guys see yourself leveraging DynamoDB, or where does DynamoDB fit into the future for SmugMug and Flickr?
Yeah, I think we're gonna continue to build new systems. I'm working on a pretty interesting new multi-region system right now. You mentioned active, but this system is designed to be active, as many actives as we want, and we have customers locally in that region. We're just going to keep adding regions. Like I think sky's the limit, quite frankly. So that's pretty exciting for us. We still have plenty of legacy systems that we haven't migrated yet to DynamoDB that are still using some of those old sort of MySQL key value kind of paradigms. So even just continuing to lift and shift those into DynamoDB and realize that increased performance and consistency and reduced cost is going to be really big for us. It doesn't sound as shiny and as glamorous as moving Flickr, out of data centers and into the cloud, but it's certainly important to our customers and important to us. So we're excited to get that work done too.
Now, one of the things I've always really appreciated about you is you have this, this title, this chief geek, and it's not something that is just a title. It's, you can tell by talking to you, and I think folks can appreciate how deep you are in the technology and how involved you still are, given all the responsibility in the role you have. What is the origin of the chief geek title, and how do you find the time to stay so connected to the details?
Yeah, so in the early days at SmugMug, we just didn't have titles. Everybody got to make up their own titles. So my mom, who ran our finances for a few years, she called herself the Countess of Cash, for example. And I just thought CEO was so boring, and I wasn't a very experienced CEO 20 years ago either. But I was an experienced technologist. I had been doing technology work for many years. So for me, I just felt like Chief Executive Officer was so boring, but Chief Geek was so exciting. I'm into nerdy stuff and geeky stuff, and so that's the title I gave myself, and it has stuck.
I like your style. I always well done. So appreciate you being with us. I know that Eric wanted to jump on. We had a question from I think Alex that he wanted to ask.
I did. Yeah. First of all, I love Chief Geek. That's really cool. I wish I could take that, but I leave it to you. That's a great name. Alex Bree asked a question. A quarter every time someone says it. That's fair.
Exactly.
I like it. Yeah. So we have this question that came in from Alex Bree. This question for Don. Do they use, I'll just put up on the screen here, do they use some more of the advanced or above key value features from DynamoDB? And I know you may have talked to this, but give you a little more chance if there's any others. But examples could be composite primary keys plus query, DynamoDB transactions, streams, global tables. Are any of those being used with SmugMug now?
Yeah, we certainly use composite primary keys pretty extensively. I think that's a really interesting feature of DynamoDB. And we're certainly using queries, in particular with those secondary indices that we talked about earlier. That's really unlocked an entire new realm of additional applications we're able to build on DynamoDB, which is great. I don't think we use transactions at all. As I mentioned, we kind of became totally transaction free internally long before DynamoDB was even a thing, out of necessity. And so I think we feel pretty comfortable. Transactions certainly have their place, and they're very valuable for certain applications and workloads, but they can, get in the way of scalability and things like that. So we have sort of engineered our way away from transactions whenever we possibly can. So I don't think it's possible we use it somewhere deep inside of one of the platforms, but I don't think it's a common pattern for us. And then streams, I think, is really interesting. We've used streams in lots of different ways. I think one of the really interesting ways that we're sort of playing around with now is using the combination of global tables and DynamoDB streams in each region to achieve eventual consistency on our distributed caching infrastructure. And I think jury's still out because we're still fiddling with it, but I think that's going to prove to be a pretty important step for us. So it's pretty exciting.
But when you decide, let us know. We'd like to.
Okay.
I always like to hear,
Yeah.
exactly how that's going and how we can make it better. I love the overall story of the two-way interaction. Yeah, I'm a DA. I'm a developer advocate. It's what I do. It's part of my life. But I love when customers come back, and there's always an approach of this would be better. This is great. This would be better. Sharp edge. We want this. Those kinds of things. That helps drive us. And I love your story. And it was great to meet you. And I appreciate it. And Joe, as always, well done, sir. So,
All right. Thanks, brother.
all right.
Thanks so much for having me.
Thanks,
Do you have
Don.
any plugs you
fun.
want to throw in? Any links or anything, Don, before you kick you off here?
Nope.
All right.
I'm good. Thanks.
We'll see you in another 10 years, Don.
Sounds great.
That's
See you
right.
then.
20 years of innovation. That's right. All right. Thanks all.
Thank you.
All right. Next, we are bringing on Anirudh Jayakumar. And Anirudh, I'm going to bring you on. You tell me if I said that right.
Yeah, you're right.
Ah, look at that. Okay. And Anirudh is from Dropbox. He's a senior software engineer. He's going to be presenting. Also in the chat, we have Jonathan Lee, who is software engineer lead at Dropbox. He's going to be supporting you. So if you have questions, ask in the chat, definitely. And Anirudh, we may have some that'll come up, and I'll come up at the end and ask. But ask in the chat. Jonathan will be answering. And with that, I'm going to turn it over to you, and I'll bring on your screen. And there you go, sir.
All right. Thank you. Hi, everyone. My name is Anirudh Jayakumar. I'm a software engineer on the persistent systems team at Dropbox. And today I'm going to talk about Alki. It's a service that we built. It's been about 2 years since we started building it. And it's a service that's used to store cold metadata at Dropbox. Cool. So let's jump right in. All right. So today I'm going to talk about a little bit on the background as to why we built Alki in the first place. Then we'll go sort of a deep dive into Alki's architecture. We'll also look specifically what sort of DynamoDB features and what sort of things Alki stores in DynamoDB. And then we'll talk in detail about a recent project of optimizing Alki's cost even further. And then we'll end with Q&A. All right. So what's the background? Why did we build Alki? So the summer of 2018, EdStore, which is our on-prem metadata store, faced a capacity crunch. So why did it face a capacity crunch? It was because there was a lot of write-heavy workloads that was taking up a lot of the CPU as well as the storage resources of EdStore. So we had like 3 options at this point. One was like double the on-prem storage capacity for EdStore. Why do you have to like double it? It's because EdStore has some like inherent like deficiencies. It's a sharded MySQL DB, so every time you sort of split, you end up like splitting for like multiple shards from a single DB into, say that like 4 shards in a DB. You end up like having like 2 shards in each DB, thereby like doubling the storage for the shards. That was not a great option for us because at sort of EdStore scale, that would mean like millions of dollars in additional spend on buying up all these storage nodes. The other option that we had was like go ahead and delete some of this metadata. Obviously, that's not a good thing to do. You don't want like product teams to know that some of the stuff that they stored is going to be deleted. That's sort of taking a backward step. The other thing that we could have done was to like move some of these write-heavy workloads to like a different store. More cost-effective, because most of these write-heavy basically means that it's read infrequently, and we didn't want to like spend too much money on like storing stuff that are infrequently read. And that's what we did. We sort of built Alki to move some of these write-heavy workloads of EdStore into Alki and like store them at like much cheaper cost. So we also had like a couple of other sort of issues. One was that we had to build it fast because the EdStore split was like projected for late 2019. So we have about an year and a few months to like build this new system, move the data out of EdStore to Alki, and also to like delete stuff from EdStore. And we also had like limited resources. We just had like a couple of engineers who had like cycles to work on this project. So we decided to sort of take the managed route of building something on like existing very reliable system. So we sort of build Alki on top of AWS DynamoDB and as well as S3. DynamoDB specifically because of its like sort of infinite write capacity, because these are like write heavy workloads. S3 because we also wanted to like have like a cheap sort of storage option. So like nothing better than S3 for that. Cool. So a little bit more about Alki. So Alki is a metadata store similar to HStore. It supports things like dynamic schemas and indexes. As I said, it's tailored for like really write-heavy workloads with like infrequent reads, uh, and mostly for like very large volumes of data. Uh, so the supported APIs by Alki are put, which is like a way for you to like add a record to the DB. We support two kinds of reads. One is a point read, which is kind of a key value store. The other is range reads, which is essentially like for a key you have like multiple values. So these are like stored as different indexes within Alki, and we also have a set of batch upload APIs for like bulk uploads, things like migrating something into Alki from like an external store. So those are typically done via the batch upload APIs. So we wrote a blog about Alki a year ago. It sort of describes like in detail about like what sort of capacity crunch issues that we had with that store, what sort of other options we chose, and like what sort of like more detail in terms of like the Alki architecture and like what issues we like faced during our migration. So let us dive a little deeper into Alki's architecture. So this was like the V1 architecture, like the first sort of system that we built to like migrate some of those write-heavy workloads from HStore. So we had a bunch of API servers on EC2. Then we had like two storage tiers. One is a hot store, which is AWS DynamoDB. Then we have cold store, where we sort of offload some of the data from DynamoDB end of the day. So we spoke about like two different kinds of reads. One is the point read, other was the range reads. So for all the range indexes, we would like offload end of the day to S3. And for the point read indexes, we sort of retained that data in DynamoDB because the point reads have like typically more sort of latency requirements. So it was like best to serve them from DynamoDB. And we also, on top of like the actual data, like user data, we also store an index of all the cold store data in this table called blob index. And we also have like another table in DynamoDB called blob metadata to store like information about each blobs. So data runs themselves are like a collection of different S3 objects, and blob index gives like an index into into the data run, and blob metadata allows us to like store like information about like individual blobs. So this worked well. This is sort of the system that we built to bring in to migrate some of the write-heavy workloads from HStore. And if you sort of look at this, it sort of resembles an sort of LSM tree. It's sort of a database technology to like, instead of using B trees, LSM trees is another way of building databases. It's still not a complete LSM tree because we don't offload all kinds of data to S3. For example, like unique index is still stored in Dynamo, and typical LSM trees also do like compactions from the cold store. We don't do that here. So this was like a semi LSM tree that we built at that point. And how does Alki use DynamoDB? So it obviously uses it for like all the live writes coming in. We use it for storing the sparse index of all the cold runs. We also use it for storing blob metadata. We also store it for storing like the metadata of each data run. And we also use it for like schema propagation. So Alki allows you to add indexes, add fields to tables. So these sort of schema changes are like propagated via DynamoDB. So we have different components of Alki sort of polling DynamoDB for any changes. And if there's a change, there's this other component that takes the new schema and pushes it to DynamoDB. We also use it to store encryption keys for certain use cases which have like compliance requirement for deletions. So rather than like deleting stuff from S3, we sort of encrypt them and like write it to S3. And when it's time to delete, we first delete the encryption key so that we sort of render whatever is written in S3 sort of unreadable. And then we have like a async job that goes and like clears off the data. So these are like the different sort of use cases within Alki for which we use DynamoDB. Now coming to the original migration. So we migrated this this use case called audit log, which you can imagine is sort of write heavy because any sort of activity that happens in Dropbox needs to be logged, and audit log is that log. And you can also imagine that this is like really write heavy. It's probably only like read by a few sort of business administrators, not necessarily by like everyone. So this use case was really ideal to like move to Alki. So this use case had around like 5 different indexes for range read, 1 point read, and right from like whiteboarding the Alki sort of architecture to implementing Alki, rolling out Alki, migrating data from EdStore, the audit log data from EdStore to Alki, and serving data from Alki. It took us just around a year, a little above 1 year, with just 2 engineers working at any given point. So this sort of the advantage that we had, like building on top of like existing really reliable distributed systems, rather than like building something in-house. So we migrated all this data directly to the cold store, and once we started serving data from Alki, we found that so just the storage cost of storing audit log data, when you compare to the same storing it in EdStore, was about like 5.5x cheaper. So that was like really great for us. So it gave us 2 wins. One was it allowed EdStore more time before the splits happen, so that the EdStore team can like come up with a more incremental capacity sort of features. And it also allowed us to like build this new system that can ingest this write heavy workloads at like really cheap cost. So it was like a win-win situation for us, in terms of, even though we started primarily like to move data out of EdStore, but we ended up like building this system that's like really cheap and really great for like write heavy workloads. So I also encourage like listeners to go to this case study that we wrote with our AWS partners. It sort of goes over some of the details I spoke in sort of more detail. So Alki was running great. We sort of ran it for almost more than a year, 18 months. And we also started ingesting sort of onboarding more use cases onto Alki. At which point we started looking at the design again. We started looking at what optimizations we could do, and we found like there is some more ways we could like optimize like Alki's cost even further. It was already like way cheaper than EdStore, but the fact that we are like ingesting a lot of data, the absolute cost of Alki was sort of going up. So we wanted to see if there are like ways for us to like reduce the cost further. That is when we thought of also offloading the unique index to S3, and like come up with a set of features that will allow us to read at lower latency from cold store. So the idea of having unique index within the hot store was always sort of so that we could like serve this data at like low latency. But the cost was sort of going up, so we thought, okay, let's do something where we can still store this data in S3, but we would still be able to like serve this data at like a lower latency. So what are the benefits of doing this? Obviously, the biggest one is that it's saving costs, and also from a software engineering perspective, we didn't want to have like 2 different notions of an index. So we had like a unique index and a non-unique index with different like key formats. So anytime you're like building something, you need to make sure it works for both. You need to like write tests for both. So this sort of gave us like just one notion of an index. And also it sort of completes our LSM tree story, where we now offload everything to cold store. And as part of getting like higher latencies, we also had like compact these data runs. I'll get to that in a bit. So it sort of also allowed us to like build this complete LSM tree, and it sort of makes it easier to like reason about the system and to like build features on top of it. The concerns, obviously, as I mentioned, was high latency. We also were breaking our original offloading logic. So our original offloading logic assumed a range read index, which typically has like multiple values for each partition key. So you could like take a partition key, fill like an S3 blob with those multiple values, and then write it to S3. So this changes because with unique index, you just have like one value per key. And also the fact that we were like building like new things, we were like introducing even read points to S3 basically meant that the blob index table, which stores like the sparse index of the data runs, will be hit harder than before. So we'll also look into like how we sort of worked around these issues. We'll start off with like how we like reduce latency by like compacting. So if you look at it, if a system runs for like a year with like daily offloads, you have like 365 daily data runs. And to find like one value from these data runs, you could either sequentially read them, at which point you're going to take like tens of seconds. Or if you like parallelly read for each request, you're going to end up like reading like 300 data runs. And that's going to cause a lot of memory pressure because you're going to read in a lot of S3 blobs. That's going to add more to your CPU because you need to like deserialize these blobs. That's not a great idea. So what we did was to like limit the number of data runs, and how do you limit it is by compacting these together. So we use a size tiered compaction. So what that means is anytime there are like, if they assuming a fan out of 4, every time there are like 4 data runs, we could compact them and move it to an upper tier. So in this case, if they're like 4, and so tier 0 takes in all the daily data runs, and if there are like 4 data runs in tier 0, you could like compact all that and move it to tier 1, and so forth. Even if there are like 4 in tier 1, you could like compact all that, move it to tier 2. So with this scheme, assuming like 4 years retention, we would like end up with like 17 data runs at the end of 4 years. So this is great. Like we start off with like hundreds of data runs. Now we're like restricted to like 17 data runs. Obviously with compaction, because data runs are immutable, like compacting data runs basically means the data runs that got compacted are now inactive. So you need mechanisms to like delete that. So we also had to like build in like GC jobs to like remove them. And also because we are now removing data, we also need like some sort of recovery mechanism in case like we ended up like deactivating the wrong data run, or if there was a bug in the vacuuming code. So for recovery mechanism, we use the point-in-time recovery feature for DynamoDB, and also for S3, we don't expire objects up to like 14 days. So if we screw up, we sort of have, and we know about it, we still have like 14 days to like recover the data. So this is great. So we started with like hundreds of data runs. We limited it to 17, but even for like every single request, even reading like 17 data runs can be a lot. So we wanted to like limit it even further. So what we did was we added Bloom filter to each blob index record in the blob index table. So before we go and read stuff from S3, we would first look at the Bloom filter, which is stored in the blob index table in DynamoDB, and then check against the Bloom filter. And only if the Bloom filter says, hey, yes, there is a chance for the data to be in this data run, only then we go and read S3. So at a 10% false positivity rate, we read around like 2 data runs instead of 17. So from like hundreds, we brought it down to 17, and now we brought it down to 2. So this has worked great for us to like reducing the overall reads to S3, as well as the overall latency, like reducing the latency as well as the reliability of these APIs. Now coming to the third problem. So we said as part of introducing point reads from cold read, we had like more load on the alky blob index table. So where is this additional load coming from? So point reads bring in additional load. Compaction brings in additional load because you first need to like walk these individual data runs. That's essentially RCUs against the blob index table. And to create a new data run, those are like WCUs against the blob index table. And even things like vacuuming, where you like delete stuff from the blob index table. And the fact that now we are storing additional data per record in the blob index table with the introduction of Bloom filters basically meant that there is additional load. And the fact that most of the load that we added to the system are async, which basically means these are coming from some offline jobs, sort of creates this problem of like uneven distribution of load across like backend DynamoDB partitions. Let's imagine like a compaction job that got kicked in would essentially add more load to the partitions where the data runs live. So this sort of causes us issues because we are always concerned about our live reads and live writes. We're okay if the offline loads are sort of throttled. So this is where DynamoDB's feature, which comes within the adaptive capacity features, it's called throughput boosting. So what it does is, if there are free cycles in other partitions which are at any point cold, DynamoDB has the ability to move all that throughput to hot partitions instantly without any sort of wait. So this is great. So we are okay like spawning async offline jobs at any point, knowing that even if a partition is hot, DynamoDB can like move some of the additional capacity not used by cold partitions to the hot one. So this obviously has some limitations around like you still will get throttled if the total capacity on the partitions is above like the per partition limits. But generally we've had like we haven't seen much issues in spite of the fact that like we have like at least like 10, 12 compactions that's running at any given time. So there's a blog that sort of gives more information about this feature. I recommend everyone to go read it. So the other issue with the load of blob index is like hot data runs. So a data run translates to like one partition key within a DynamoDB partition. So we spoke about a hot partition. Now we're talking about a hot partition key. So there are like a couple of ways with which this can happen in Alki. One is that for the higher tier data runs, which are typically very big, you could have like multiple jobs running on it because it takes more time to walk these data runs. And also the fact that they are big and we have some internal SLAs to meet. So we end up assigning more tasks to the jobs that run on them. So all that like leads to like more RCUs and WCUs on these. The other way it could we could get into this problem is when we could have like live requests coming for certain use cases. So one of the use cases that we have is of campaigns team using Alki to store some email tracking information. So let's say a term of service email was sent. So during that time, you have a lot of customers like clicking on some of the links, which sort of translates to a read point request in Alki. So there are like certain scenarios where you have all of a sudden more sort of requests coming in for one specific data run. So this is where, again, within the adaptive capacity umbrella, there is this feature called dynamic partitioning. So you're all aware of DynamoDB partitioning, like across partition keys. That's sort of a known fact. But one of the features here is the ability for DynamoDB to partition across sort keys. So in this case, if you have like hot data run, you could essentially partition this data run across like multiple backend partition split across sort keys. So this is like incredible for us. So we've had scenarios where we had a bunch of backend jobs, offline jobs that were running on the higher tier data runs, and we could see it would throttle for a while, and then we could see that the capacity all of a sudden like doubles. So this sort of has helped us in like numerous occasions in the past. So now the final outcomes of this cost saving projects has been like we've reduced Alki's cost even further, down to 6% further, and now compared like 5.5x cheaper. It's now almost 10x, even greater than 10x cheaper than Edstore. And the big thing was the latencies. So by adding Bloom filters and compactions, we were able to serve read points at around like 150 milliseconds at P99 and like less than 100 milliseconds at P75. And yes, that's it. And we were able to like unblock more use cases because there are a lot of use cases that were previously not storable because of how write heavy they were, how costly it would be. So now there are a bunch of those use cases. Now we could store them internally at like a very cheap price. So finally, I would like to thank everyone at AWS, right from all the premium support we have received when we're debugging issues, to all the PMs for constantly asking for like feedback, to all the solution architects for all the best practice advice on like all the different various AWS services, and finally to all the developers who are building these incredible services. Cool. So I'm open for any questions at this point.
All right. So I'm looking to see if we had any questions coming in. I'll tell you what, we've been reposting the stats and the blogs you had. We've got some good feedback on that. So if you have any questions you want to ask, go ahead and post them in the chat, and we can ask Anirudh now. Lots of great work going on here. So yeah, and John, if you have any questions, John he's in the background answering, getting all over it. He's answering these. So okay, we have a question. I don't think this is specific to you, but we see if how do you approach this? And it's okay to say, yeah. But when you're looking at estimating costs, when you think about DynamoDB, you think about the API. So the actual question is this quick question regarding billing. We can estimate the size of payload getting the object to DynamoDB, but HTTP response have more things around it than just an array of objects. How can you effectively calculate estimated costs around the network output in AWS? I am putting you on the spot, and I know that, but I'd be interested to see how you approach that, or you're welcome to pass on that as well.
Yeah, so for us in terms of cost, so for this particular use case, so our cost limitations are mostly around storage. So so that's why, and we didn't want to. So we wanted to make sure that when we store these infrequently read, we wanted to store it at some place where it's cheaper. That's why we chose S3. And but at the same time, we wanted to like, these are like write heavy workloads, so we want to be able to ingest them at like at the rate at which they are coming. So which sort of helped. That's why we chose to go with DynamoDB, because theoretically, if the incoming requests are like uniformly partitioned, you could technically go to like infinite capacity with DynamoDB. So that's sort of why we chose DynamoDB for ingesting the writes. The other place that we use DynamoDB like extensively used to store the sparse indexes. Again, primarily the reason why we want to have sparse indexes in DynamoDB is essentially the latency at which we can query, and also the fact that the ability for DynamoDB to like really scale out in times when they're like more load. So for us, in terms of like DynamoDB's costs, we're not too worried because for us, we are primarily using DynamoDB for ingesting and we're offloading end of the day. And the sparse indexes, because they're sparse, they don't like take up that much storage in DynamoDB.
Right.
So for us, DynamoDB is mostly a performance service than like a cost saving option. And for cost savings, we typically use S3.
Awesome. Excellent. So definitely tiered level of data. You what kind of data is it? Is it hot? Is it warm? Is it cool? Is it cold? Kind of break that out, which is a great pattern on doing that. Did have a question come in. This is Anirudh, can you explain with more detail on how you use sort keys in partitioning? How do you approach that? Cool.
So the sort key partitioning is something that is given by AWS. It is something that is so if AWS DynamoDB finds that a single partition key is hot, it has the ability to now partition this one single partition key across all its sort keys. So in our usage of the sparse index, we have the partition key to be the data run, and the sort keys to be the starting keys of every blob in the data run. So that's how we are like quickly able to like find which blob that could have the data. So you can imagine one data run having say millions of blobs, and we have like millions of sort keys, with each sort key having the starting key of each blob. So now you can imagine if there's a hot data run, now DynamoDB could like split this 1 million sort keys into say 500K sort keys and put them into like two different backend partitions, so that now you could effectively, initially you were like limited to like 3,000 RCUs for this whole partition key. Now we are all of a sudden increase your throughput to like 6,000 at a maximum. And obviously once if you are continuing to like hit these at like 6,000, they are going to like split even further. So maybe like 250K and in times 4 backend partitions. So this is something we don't necessarily have to do anything. This is something like DynamoDB does for us. And for us, it's great that DynamoDB provides that, because we do have these use cases where a single partition key is hot.
Okay, excellent. So we have another question. What's next? What are you looking at doing next for the application, for what you're doing? Is there, are we looking at more optimizations? Are we looking at more, more use cases? What's the next steps?
Yeah, so for us, we are looking at more use cases at this stage, because from the cost perspective, we're already pretty cheap. So we are looking for new use cases to come. We already have a couple of new big use cases coming in. One of them is the Magic Pocket team within Dropbox, which is Dropbox's object store. So they wanted to store some of their metadata in Alki. So that's coming up. We also have some use cases from the file system team, which is like a team that builds on top of Magic Pocket. So they also have some new requests around moving some of their data from their sort of MySQL DBs to Alki. And for us, we are building some features. One of them is like, so currently the range index requires you to like pass in the whole prefix. So we are building a partial prefix range read to able to sort of one index could like service multiple different use cases. So at this point for us is to build more features on top of Alki so that we get more use cases. And we could later optimize, because now we have more use cases, the costs are going up. So then we could look at more optimizations.
Limitless. See, the world is your oyster. All right. So I have a question for you. You talk about sparse keys a lot. You probably defined it a little bit. Let me ask you again. I know some folks have missed it. What is a sparse key?
Sure. So let's if you talk about like a typical DB, and you have like an index and a partition key. So in those databases, you essentially have every record in the DB index,
Right.
so that if you want to say search for key foo, you go and you'll have an entry for key foo. What a sparse index does is, let's say there are like four. Let's imagine there are four keys in the system. That's A, B, C, and D.
Okay.
What a sparse index does is it stores an index for A, it stores an index for C, it does not store index for B and D. And if you want to search for D, you'll basically do a binary search on an index, and you'll know that the data is somewhere between C and E. So you'll start now actually reading from C up till E to find data D. So you don't end up storing the whole index, because that's cost for us. So typically what we do is we store the index of every starting point of every blob, and every blob typically for some use cases have like 1K records, for some they have like 5K records. So you sort of have like this record of every 5Kth or every 1Kth entry, and so you can quickly go look at which blob that could have your value, and then you read the blob to actually see if the value is there. So rather than like reading a bunch of things, rather than scanning the whole data run, we have the ability to go to precisely which S3 blob will have the record. But once you read it, the S3 blob may or may not have the record, because that's sort of the disadvantage of a sparse index. You're not totally sure if the record is there or not.
Right.
That's where things like storing Bloom filters helps us to reading S3 less, and being more sure that once you're reading S3, you have a better chance, like in this case, like 90% chance that you are going to have the record there. So that's how the sparse index helps us here.
Yeah, I remember the first time I used a sparse index, I literally got up and danced around the office. It's like, this is so cool. It was really exciting. I think we have time for one more question. And I like this question because I'm a believer in right tool, right job. It says, he asked, or they ask, Anirudh, any requirements you were not able to implement in DynamoDB?
That's an interesting question. I don't think we had any. So one of the things that we couldn't implement is so Alki has multiple indexes per table, and in Alki, because most of the things are stored in S3, we sort of store a copy of each data with the index. So typically in a DB, you have like a primary index and the data. All the secondary indexes would point to the primary index. With Alki, we just store the data along with every index. So one of the things that at the point of us working on this was the ability, and because each index we store data separately, we would have separate DynamoDB tables ingesting this data for different indexes for the same table. So each record will go in like multiple different DynamoDB tables. We didn't have a way to like transactionally do it. I think it's available now. It was not like a issue for us, because for us logs are still sort of a right head log use case. So we don't really need a transaction. We're okay with like duplicate data going in. That's not like a big issue for us. But if it was there, that one we would have used it. But since we are not blocked on it, even today we don't use it, because we just want fast ingestion. They're okay with some duplicates. That's a perfect use case for us. But if tomorrow there comes a use case where we say no duplicates, then probably we might have to like use like multi-table transactions.
Yeah, so that's really interesting. Don actually earlier today talked about the fact they had gotten completely off the idea of transactions because they felt like it was blocking. But now DynamoDB does have transactional support, so that's phenomenal. Man, I just want to thank. There's a couple other questions in the chat, and I know we're going to move on because we're going to move to getting started with DynamoDB. But I encourage you. I know John's still out there answering questions, so if we didn't answer your question on screen, don't be dismayed. We're in the chat. We're answering these questions. Anirudh, I really appreciate what y'all are doing out there and you taking the time with us to come talk about it. Anything you want to throw out before we go?
No, I just want to thank everyone at AWS for helping us through the last couple of years. So we've had a bunch of issues with like something that we don't understand. There are support engineers or the solution architects. All of them are like really eager to help us. Just want to like thank everyone here.
Thank you very much. Appreciate your time and have a good day. We'll see you in the chat.
Thank you. Thanks a lot. Bye-bye.
You bet. All right. So next I'm bringing in, and I'm going to bring him in before I say his name because he's going to help me. Now, I've been working on it. Let's see if I get it right. Is it Shwetang Oza?
Close enough. Yeah. So my name is Shwetang Oza, and I go by Oza, which is easier to say.
Yes, yes. And I told Oza when we first met, I was like, if that wasn't already taken, I would take that. Much like Geek, I really like Oza, and I'm actually having my kids call me Oza now because I think that's really cool. Today, you're going to be talking about getting started with DynamoDB, and I'm super excited about this. We have a lot of folks talking about DynamoDB, but sometimes it's there's a learn. Anytime you do a new technology, there's a learning curve, right?
Yeah, and I have been watching previous session, right? So I would like to call this more like a back to basics, right? So we
Okay.
have a lot of customers who are advanced with you have advanced usage of DynamoDB, but sometimes it actually helps to just go revisit some fundamental concepts and
Yeah.
revise them, right? And then get a different perspective on how everything works and see what you can do with that.
Yeah, the basics are critical. I appreciate it. With that, I'm going to pass over to you. I'm going to bring on your screen, and I'm going to get out of the way. And Oza, take it away.
Thank you, Eric. And hello, everyone. Welcome to Getting Started with Amazon DynamoDB. As I said, my name is Shwetang Oza. I go by Oza, and I'm Specialist SA with Amazon DynamoDB team. So if you are a developer or a builder like me and looking to build serverless application or looking for a place to persist your high velocity data at a massive scale without worrying about database servers, schemas, and other heavy lifting, you have come to the right place. Today, we'll talk about Amazon DynamoDB's NoSQL journey. We'll review some key features and capabilities. In the Working with DynamoDB section, we'll look at capacity management, storage options, and then we'll jump into basic concept of DynamoDB table, global secondary indexes, and we'll also look at serverless architecture patterns using DynamoDB, AWS Lambda, and Amazon API Gateway. We'll also cover some developer-friendly tools which can help you get started. So as you already heard from Swami and others earlier this morning, so let's recap on how DynamoDB evolved to a tier 0 service it is today. On December 6th, 2004, Amazon.com website had a multi-hour outage. It was peak time for retail. Root cause, it scaled beyond relational database capabilities. Engineering team stepped back and considered a new way. Amazon's answer to these challenges was Dynamo, which was described in Dynamo paper, a seminal work defining what was later dubbed as NoSQL movement. And it inspired other NoSQL projects, including Cassandra. Amazon announced general availability of DynamoDB in January 2012. That makes it 10 years today. DynamoDB is tier 0 dependency for many of Amazon's and some of the most powerful applications in the world today. So let's just go through what Amazon DynamoDB really is. So Amazon DynamoDB is a fully managed NoSQL serverless database service that provides fast performance at any scale. Today's web-based applications often encounter database scaling challenges when faced with growth in user traffic and data. With Amazon DynamoDB, developers scaling cloud-based application can start small with just capacity they need and then increase the request capacity on given table as their app grows in popularity. DynamoDB is built for mission-critical workloads, including support for asset transaction for a broad set of applications that require complex business logic. DynamoDB helps secure your data with encryption and continuous backup of your data for protection with guaranteed reliability. With DynamoDB, there are no on-calls, there are no instance qualification tests, and there are no slow query logs. DynamoDB is serverless, and you can use the on-demand mode to pay for every request you send to it. All data plane operations can be logged with AWS CloudTrail. All change data capture logs are integrated with DynamoDB streams and Kinesis data streams. These features allow developer to build end-to-end serverless applications. Now let's look at some core capabilities that DynamoDB has. Amazon DynamoDB has many features, and I wouldn't have a lot of time to cover all of them, so I'll highlight some of them today. And we'll group them into some of the key features or some of the key use cases that we look at, right? So let's talk about performance at scale. DynamoDB is a key value and document database that can support tables of virtually any size with horizontal scaling. This enables DynamoDB to scale to 10 trillion requests per day and peaks greater than 20 million requests per second and over petabyte of storage. Customer gets microsecond latency with DynamoDB Accelerator, automated global replication with global tables, and advanced streaming with Kinesis data streams for DynamoDB. On the enterprise feature side, DynamoDB supports asset transaction for broad set of applications that require complex business logic. Point-in-time recovery helps protect your DynamoDB tables from accidental writes or delete operations. Point-in-time provides continuous backup of your DynamoDB table data, and you can restore that table to any point in time up to the second during the preceding 35 days. On-demand backup allows you to create full backup of your DynamoDB tables. You can backup tables from few megabytes to hundreds of terabytes of data and not affect performance or availability of your production application. Talking about global tables are built on DynamoDB's global footprint to provide you with fully managed multi-region and multi-leader database that provides fast local read and writes for performance at massive scale for a global application. Global table replicates your data tables automatically across choice of your AWS regions. Global table eliminates the difficult work of replicating data between regions and resolving update conflicts for you, which enables you to focus on your application business logic. In addition, global table enables your application to stay highly available even in an unlike event of isolation or degradation of entire region. For example, some of my customers use global table for hot standby in their DR solution. In this case, they always write to one region and read from many. In the event of performance degradation, they set up automatic failover to the other region. To get started with DynamoDB, developer only need to learn straightforward API using SDK in programming language of their choice. You pay for storage and I/O throughput that you have provisioned. DynamoDB is designed to scale elastically while maintaining high performance. When the storage and throughput requirement of your application are low, only a small amount of capacity needs to be provisioned. As the number of users of your application grows and the required I/O throughput increases, additional capacity can be provisioned on the fly. This enables an application to seamlessly grow to support millions of users, making thousands of concurrent requests to database every second. So when you start at table creation time, you only specify a table name and keys. And then you specify write capacity units and read capacity units. We'll look at table and keys in a little bit detail shortly. Now storage size on the table along with number of partitions automatically increases as you add more items. New partitions are added when either the capacity or size exceeds the formula here, where the size is for a partition is typically 10 gigabyte, and then your read and write, each partition delivers 1000 writes per second and 3000 reads per second. So now let's look at the capacity mode, right? I mean, as we spoke about earlier, is that there are two uh, controls you have as far as how your DynamoDB billing works, right? You basically go consume your capacity and then you pay for storage. So let's talk about capacity modes first. DynamoDB offers two configurable throughput modes: provision mode with auto scaling and on-demand scaling mode. With provision mode, you set your minimum consumption capacity, max consume capacity, and threshold of say 70%, which governs your max consumption. Auto scaling rules monitor your utilization of the table and scale similar to your EC2 instance. With on-demand capacity, there is no planning for capacity. You simply consume what you need with no throttling and pay only for those reads and write requests. For a spiky and unpredictable workload, on-demand table can scale much faster than auto scaling. So if you are considering as to, okay, if I'm getting started here and what capacity mode I should start with. So here are some considerations when you choose your capacity mode. Consider provision mode for predictable workloads and on demand for unpredictable workloads. Now you can always switch between capacity mode once every 24 hours. So after looking at capacity, now let's look at data lifecycle, which represents your storage cost. Let's consider a use case to understand data lifecycle. Let's say you launched your e-commerce platform. You start with DynamoDB standard table. You start getting more and more orders. However, as the expected orders come in, some of your orders actually get older. And these older orders are less frequently accessed, but you need to keep them to offer your customers the ability to view these orders quickly. Your throughput cost is growing at a steady state as you are gaining new customers, but your storage cost is also growing much faster as you need to keep your older order data in the table as well. You need to do that to allow your returning customer immediate access to your older orders. At a given point in time, storage becomes your dominant cost, and your total cost increases now driven by storage. You end up paying for higher throughput storage than your application requires. To address this, some of our customers use TTL and DynamoDB streams to keep the storage cost low by moving old data to S3 for future use. Now, DynamoDB now offers two table classes: the DynamoDB standard table class and DynamoDB standard infrequent access table class. DynamoDB standard infrequent access table class was launched at reInvent in 2021, late last year. Using table classes, you can optimize the cost of your DynamoDB storage for your e-commerce platform by storing new recent order in the standard table class and older infrequently accessed orders in standard infrequent access table class. For specific tables where the majority of your data is infrequently accessed and storage is dominant cost, you can switch to DynamoDB standard IA to start saving on total cost. You can save up to 60% on storage by using infrequent access. So now we're gonna get a little bit under the hood and we'll learn some basic terminology used with DynamoDB. And we're gonna look at how table is composed, and we'll also look at global secondary indexes. So DynamoDB data lives in what we call a table. A table is holder of your data. Table is unique to your account ID and a region. Table is a string literal. So for example, you can call it account, bookmarks, or I don't know, maybe metaverse. Your data sits inside an item. Conceptually, it is similar to a row. It is an atomic unit of data. All operations on an item are ACID. All items must have a partition key. A partition key is also known as hash key. Partition key is important to find your data. Without partition key, we don't know where your data is. In DynamoDB, it is super important that you know what that partition key is. The partition key could be something you derive, or it could be set of values that you randomly generate between 1 to 10,000, depending upon the data set that you have. Make sure that your partition key is high cardinality. Optionally, you could have a sort key. A sort key allows for one-to-many relationship in DynamoDB. Sort keys are often things like timestamp, version numbers, or audit log IDs. The sort key are used to create grouping of your data and are used to sort the actual data on the disk. This actually opens up a lot of query patterns where you can request a range of rows to be returned under a partition key using a between statement on the sort key. When you have a table with a partition key and a sort key, the two are collectively your primary key. Combined together, they two uniquely identify a single row or an item in DynamoDB. If you give DynamoDB a partition key and sort key, we know precisely which row or item you are referring to. Let's talk about global secondary indexes. Global secondary indexes allow you to have alternate schema on your DynamoDB table. GSIs underneath are actually DynamoDB tables. However, when you go to your AWS Management Console and you go to your DynamoDB table, you won't see your GSI listed next to your tables. Instead, they are under Index tab on your DynamoDB table. So what makes GSI unique? Only DynamoDB can write to global secondary indexes. DynamoDB is responsible for copying data from your base table into your global secondary index. Because this is a separate DynamoDB table, it is asynchronously updated. Thus, GSIs are eventually consistent. You get up to 20 global secondary indexes. You choose whatever partition key you want. Now, as I mentioned, it is important to have a good, unique, high cardinality partition key value. Next, we're gonna look at how you work with DynamoDB APIs. DynamoDB provides flexible APIs. All operations on DynamoDB are based on REST APIs using SDK or CLI and console. You can use these APIs with AWS SDK, which supports Java, JavaScript, Node.js, .NET, PHP, Python, and Ruby. As with any OLTP database, there are two primary functions we care about. One is write data, other one is read data. So let's look at first the write. For the write section, we actually have put item, which puts a single item. Batch write item inserts up to 25 items as a single API call. Update item updates an existing item and consumes the full item size as a write operation. Delete item removes an existing item and consumes the full item size as a write operation as well. Transact write items operates up to on up to 25 items as a single atomic unit, and it supports condition and checks. On the read side, get item is singleton operation to retrieve an item, which would require partition key and sort key if you are using sort key. Get batch item retrieves up to 100 single operations as a single API call. Query is a very powerful retrieval option. It allows for retrieving many items which share a single partition key as a single unit. Scan is primarily used for ETL or sampling data. It is only used in edge cases for normal production workload. Transact read item is a read that is consistent with your transaction that is being written. Now, let's look at some serverless architecture patterns. We'll get some detailed other serverless architecture discussion a little bit later in the day, but let's just touch upon some basic core concepts here. So for developers who are coming from Lambda or API gateway background, let me show you how DynamoDB can be part of your serverless application. So let's look at a serverless microservice pattern for many use cases, including your mobile backend, web, or e-commerce application. DynamoDB's low latency provides API-based access, which means no need for object relation mapping, making it very suitable for use in a Lambda function. In addition, operational data stored in DynamoDB tables can be easily and reliably delivered to downstream consumer using DynamoDB streams, along with Lambda. DynamoDB streams is a feature that reliably delivers all data updates as a stream event. Thanks to its seamless integration with Lambda, those events are passed into your Lambda function invocation. DynamoDB streams and Lambda do all the hard work here and provide a fully managed mechanism for reliable event delivery. So what is DynamoDB stream? And there were some comments I saw earlier about DynamoDB streams in terms of what services people love. So let's look at what DynamoDB stream here is. So DynamoDB Stream is a highly available, durable change data capture service for DynamoDB. It holds item changes from DynamoDB table for up to 24 hours. DynamoDB streams can be enabled with one click in DynamoDB console and incurs no immediate additional cost for enablement. Every change appears exactly once in DynamoDB Stream. Most of my customers configure DynamoDB Stream to store old and new version of the item so that they can compare changes from before and after the mutation. Technically, AWS Lambda polls your DynamoDB streams 4 times per second. Optimally, I like to configure 2 concurrent Lambda functions per stream. You can have more than 2, but at some point you may be re-throttled on the stream as you continue to add more lambdas. I should mention that DynamoDB stream is completely separate service from DynamoDB. So there is no way your access pattern on stream service could affect your production DynamoDB table. So here is the basic architecture of a serverless application or service that we see in many use cases. Based on core building blocks we saw earlier, you have an API and have a service to manage it, which is represented by API gateway. Then you have compute that does the work for your published API, and that is Lambda here. And you have to have a persistent layer for your compute, which is your DynamoDB. Now, then you have a DynamoDB streams that captures all your change data and makes them available to an endpoint. You can consume change event from DynamoDB streams and do a number of things with them. This seems like a good setup for event driven applications. So there were some comments I saw is that some customers actually store the data, stream data into S3 and use Athena with it. There were some discussions earlier saying, okay, how do I do a keyword search? Well, some customers actually stream data from DynamoDB streams with Lambda into OpenSearch. And then if you want to create some aggregates, you can take the stream data and put them back into a DynamoDB table. So this actually opens up two separate use cases. So on the left-hand side, you actually have your OLTP use case, and then you actually have a query side on the other side, which allows you the OLAP use case. So getting started with DynamoDB is easy. Next, we'll talk about developer tools and how you can get started with DynamoDB today. DynamoDB free tier allows customer to handle up to 200 million requests per month and 25 gigabytes of free storage space. If you do the math, that is 6+ million reads and writes per day for free. All you need to do is create a table, set up provisioned capacity. I would start with 5 WCUs, 5 RCUs, and set max 10 and a threshold of 70%. And then you can download AWS SDK or CLI if you choose, or you can use AWS Management Console. Here is the link where you can follow and get some documentation with getting started. AWS Management Console for DynamoDB provides users with visualization of tables in their account. It allows you to manage configuration and review table level events. Console now also includes built-in particle query editor. Support for particle provides a familiar query pattern for SQL developers. Please do keep in mind that unions and joins are not supported. I want to talk about another developer tool that I personally love is NoSQL Workbench, which is a unified visual IDE tool that provides data modeling, data visualization, and query development features to help you design, create, and query and manage your DynamoDB tables. With the data modeler, you can build new data models from existing design that are provided, or use existing model that satisfies your application data access pattern. And you can also import and export the design data model at the end of the process. Now, Alex Debris is going to have a session later on talking about how to design DynamoDB tables, and using this NoSQL Workbench could be very helpful as you go through that session as well. Data Model Visualizer, which also is part of NoSQL Workbench, provides a canvas where you can map queries and visualize the access pattern, which are also called facets of the application without having to write code. Every facet corresponds to a different access pattern in DynamoDB. You can manually add data to your data model. NoSQL Workbench also provides a rich graphical user interface for you to develop and test your queries. You can use the operation builder to view, explore, and query datasets. You can also use structured operation builder to build and perform data plane operation. It supports projection and condition expressions and lets you generate sample code in multiple languages. So earlier we looked at how you can write and read data to and from DynamoDB table. Here are some examples comparing particle statements with CLI or scan, query, and get batch items. Yes, you can use select statement to read data from DynamoDB with particle. Using select statement without specifying partition key, we can result in full table scans. A scan operation examines every item for requested value and can use a provision throughput for large table of your index in single operation. You can also disable full table scans using IAM policy. All right, so I think we covered quite a bit of ground, and let's quickly look at some takeaways from this session. I want to highlight some few takeaways here. Building and managing internet scale application can be challenging. DynamoDB can be very good fit for your serverless architecture. You can get started with DynamoDB for your serverless application today. Here are some resources which can help you get started. You can look at blogs on serverless patterns for additional ideas. Start with downloading of NoSQL Workbench, and then make sure you tune in to why data modeling is critical for your success with AWS Data Hero Alex Debris session later today. With that, I want to thank you, and we can take some questions.
All right, Oza, thank you very much. Yeah, we might have time to do maybe one question here. We had a question. Let's see. There's several coming in here. I'll ask you this one. There's a question on why does PartiQL editor take 3-digit milliseconds elapsed time? Is there a difference in speed between using Particle and the standard?
Yeah, so with Particle, when you do your queries, right, as long as you do a simple get items, that is equivalent to your get item response times. Now, if you end up doing, say, in clause, which is supported with Particle, then you are actually doing more of a batch get item, right? So it is equivalent to going through uh, multiple queries, right? So say, give me entire 3 partitions. If I say pk is equal to 1, 2, and 3, where I say in clause, I say 1, 2, 3. Now it has to go fetch all the data or items associated with that, including all the sort key, and it returns those.
Okay, awesome. So we're going to jump here to our next session, but I will. Oza, that was awesome. I don't know if you saw in the chat, but I posted, man. I wish I had your delivery. You're so chill. When I get talking, I go, you know. So I loved your presentation. A lot of great information. We do have folks answering questions. If your question didn't get answered in this, we have folks answering questions in the chat. Please keep them coming. Also, remember we have the office hours where we'll be doing a lot of talking, a lot of answering questions there. Oza, thank you so much. And we're going to jump to the next
everyone.
one. You bet. Okay, up next, we have a roundtable where we're going to be talking about the evolution of DynamoDB, a roundtable discussion featuring AWS and DynamoDB senior leaders about the past, present, and insights for the future. I hope you enjoy this, and here we go.
Hello, folks. My name is Joseph Idzorik. I lead product for DynamoDB. Thank you for joining us today. We are going to have an executive roundtable discussion about DynamoDB. What's particularly special about the audience we have today is we have 3 of the former of 4 total GMs for DynamoDB, and let me unwind that for you. So DynamoDB has been around for 10 years. We're celebrating DynamoDB's 10th birthday this year. And over that time, there's been 4 GMs. I kind of like to think of them as the Mount Rushmore of GMs. We have 3 with us today. Jim Scharf is not able to be with us today. He's on vacation, but I will do my very best to channel my inner Jim and share some of the stories that he had during his time. A GM or a general manager at AWS is really our single-threaded leader for a service. You can kind of think of them as the CEO for the service, as they are that single point of contact where engineering and product and other disciplines report up through, and they're ultimately responsible for the building and the delivery and the operations of the service. So these people that become GMs of services have big roles, and they have lots of responsibilities, and they have really good stories to share. So with that, we have 3 of our previous GMs for DynamoDB, or 2 of our previous and our current GM for DynamoDB, and I'll let them introduce themselves. Starting off, we'll go chronologically in order. I'll let Swami start off and introduce himself and just kind of talk about a little bit about the time period that he acted as GM for DynamoDB.
Mm-hmm. Hey, thanks, Joe. So really excited to be here, and just say just a little bit about myself. I've been at the AWS and Amazon now for 16 years or so. Joined AWS and Amazon as an intern, and since then I've built a bunch of things, all the way from the original Dynamo to also our parts of S3, and then RDS, our relational database service, and then cloud version of DynamoDB, which was the first time I actually started the role as moving from principal engineer to starting to build the service as a GM, and had the privilege and pleasure for conceiving and building DynamoDB with lots of smart folks who are still actually working with us and continuing to do amazing things here. So looking forward to the conversation.
Tony, you're up next.
All right. I'm Tony Petrosian. I've been around here not as long as Swami, almost 5 years, but I did start with DynamoDB as an engineering manager, and I worked on a bunch of stuff. And then I took on the GM role when Jim Scharf went off to do other things. And, I have to say that, working in Dynamo is a little special. You leave Dynamo, but it never leaves you. It's like one of those products that stays with you. So, I have a special spot in my heart for Dynamo. I learned a lot, and it'd be great to talk about it.
Great. And then nice to see everyone. I'm Colin Legier. I took over from Tony. So I have been at Amazon a little bit longer than Swami. I've been with Amazon since 2001. I was originally working on a number of things that all predate AWS, mainly working on sort of the overarching project to transform Amazon.com into a service-oriented architecture. Then I moved over to AWS in 2008. In AWS, I ran a bunch of engineering teams in EC2 for a number of years. Then I joined storage, became a GM there, launched a number of services, including Glacier and the Snow family of services, before taking on a chief of staff role for a year, and then moved on to be the DynamoDB GM. So I've been the DynamoDB GM since mid-2019.
Cool. Thank you, folks. I think kind of I was in preparation for this, I was tallying up all of your 4, adding Jim in there. We won't let Jim be left out. Collectively, you guys have 57 years of experience at Amazon between the 4 of you. So it's a couple turns of the crank building cloud services and building at this scale. So it's kind of fun. And Colin, you were also an intern at AWS or at Amazon, but way before AWS. But so both Swami and Colin are interns. So for kids out there, your next internship, you might end up on one of these N years later. So. All right, so to start off the questions, I always kind of like to start with customers, right? This is about it's really about what we're doing with Dynamo, and it's really the purpose. So for each of your times at GM, as a GM, can you share what was one of maybe your more memorable customer stories or events or things where, DynamoDB enabled customers to do something spectacular that they might not have been able to do before, or It was just push DynamoDB to the limit that we didn't think was possible. And if I'm going to channel my inner Jim here, I know Jim loves to share the story of Snapchat and the World Series in 2016, right? And you think about this, the Cubs won the World Series for the first time in 100 years. And everybody picked up their phone and started using Snap to be able to share stories about where they were and what happened. And there's a really great reInvent video on this about what that immediacy and that spike or that viral content caused on the back-end systems for Snapchat. And DynamoDB served a big purpose in making sure that those customer experiences were great and enabling Snap to be able to scale. And it's just kind of an amazing story about how you think about databases support viral events that happen kind of in our everyday lives. And there's another great story that Jim likes to share about how DynamoDB helps Snapchat during New Year's Eve handle the different spikes in traffic as they go through different time zones. So that is a context, and we'll kind of go chronologically. I think it's kind of fun is going through time. If Swami, we can start with you and love to hear one of your favorite, more memorable customer stories.
Sure. I'm going to cheat and maybe do two. But I'll say first, the genesis of Dynamo was that we were actually looking at Amazon's internal workloads and realized at a certain point that our own relational databases couldn't keep up with the scale and reliability demands for Amazon, which led us to build the original Dynamo system for critical internal applications. And we even wrote a paper about it. Since then, I moved on to work on various parts of AWS that I mentioned. And at some point, this is my first favorite customer story is Don McCaskill, who is the CEO and chief geek of SmugMug. And he's proud of the chief geek title himself. He was, I remember in our internal customer advisory board session, which is a forum where some of our large-scale customers come and give us a very clear signal and feedback on our roadmap. And early on, this is probably like 12 years ago or even more than that. Talked about, you all told how you can rethink databases using things like Dynamo, which is easy to scale and highly available, and you kind of change what databases could be. But why is that not available in cloud as an AWS service? And at that time, I think I was there, and James and Werner and several of us in AWS leadership was there. And we were having this discussion, and I always get reminded of that as one of the first story, which is a great example of us working backwards from customer demand. And John was a very, very vocal advocate for something that led to the genesis of Dynamo. And then the second one I would just flag is, as you mentioned, Dynamo has been incredibly powerful for applications that need instant scale up and down, like viral, like the Super Bowl, so the voting applications or various other things and whatnot. But I remember explicitly one, which is Valentino, the CTO of Adderall. I remember tweeting saying his team spends more on snacks than on Dynamo while running mission critical applications. That was a great summary of being able to take high throughput, high performance demand applications, but being able to do it in a way that was very cost efficient. It was really incredible. So
I like that, snacks. All right, Tony, can you share, please?
Yeah. By the time I took over, Dynamo had been around a while, and it had a lot of customers, and I had a lot of big customers. So no single customer, dominated, with their throughput or, any event that they had. It was just a little blip in the aggregate Dynamo world. But this one time I was talking to a customer, and I'm not going to mention the name, but they'd been using Dynamo for a long time and storing a lot of data coming from devices. And I asked them how big their table was, and they said they don't know. And I asked them how many items they have in their table, and they said, I don't know, we haven't looked. Why? Does it matter? because the performance seems to be fine and hasn't changed over the years. So then out of curiosity, we're like, okay, we're going to go look at this, So together we looked, and they had more than 1 trillion items in the table. And that was the biggest surprise, because I've been in databases a long time, and I had never seen a table, and then we're talking just a table, with more than 1 trillion items. I mean, people talk about billions or hundreds of billions, but this was a table with trillions of items, and the customer wasn't really concerned because they had noticed any change in the performance since they started the application. And that's one of those times where you go, okay, now I develop a particular appreciation for Dynamo that you really never had before, where things are growing and they're scaling, and application continues to run to a point where the customer didn't even care or monitor how many items they had in the table. So that was one of the interesting experiences I had. It was really interesting for me. Another experience was another conversation with a financial institution, and I was talking to the CIO, trying to get some feedback on features and so on. And the CIO told me that if he ever introduced the concept of stored procedure in Dynamo, he would quit using it because he didn't really want any of his developers to delegate application logic to Dynamo, because it's like it does the job and it's doing what I need it, and I don't want to mess with it, so don't ever do that. So at least I promised. I don't know if Colin's going to keep that promise or not, but I didn't introduce any push down functions or stored procedures to Dynamo. I'm pretty sure we still have that customer with us. So there are some of the things I learned early on about Dynamo.
So yeah, we'll talk about future looking maybe later. I think it's one of the things that's really interesting coming to Dynamo for me is that you have these big customer launches and customer events. Something pretty extraordinary in scale, at least every couple of months, and it does vary by time of year. Like Snap was mentioned, and they have a big spike in New Year's Eve, and there's other customers other times of year. One of the ones that really stands out for me like that was the launch of Disney Plus that happened in late 2019. And that one was particularly interesting because often it'll be a customer who has an event where there's some prediction of the traffic that they can kind of reasonably do, or they're launching something that then grows very quickly, and we can sort of see that ramp up over time. But with Disney Plus, it being such a large scale launch from a large existing company with an existing customer base, they had really no clue how many people would show up. And there were sort of wild guesses as to what that traffic would be. And this is we have a number of streaming services as customers, but this is this was anticipated and quickly became one of the biggest streaming platforms on the planet. And so the amazing thing about that one was their guess was sort of pretty high, but easily underestimated by I think a couple of factors. How many folks would show up, and just being there on all those calls with them. Seeing how well the system, performed, and seeing the system stand up, and working through that was really exciting and just kind of amazing to see. And they also relied on a number of key features that had just come out really a year before in Tony's time. So things like on-demand capacity mode and global tables, which was really great to see them, leverage and be very successful with.
No, I think those are great stories. When I first joined the DynamoDB team, I remember walking through the hallways on a Thursday night. And everybody was watching football, and it was like, okay, well, this is kind of interesting. This is a bunch of engineers watching football. And like, what's going on? They're like, oh, DynamoDB supports Thursday night football, and they're watching the performance of the system when Amazon Prime started to broadcast and how the system behaved, and we watched it live. Both the game, what was going on with people that were interacting in the game, and it was just a really cool experience to see that connection firsthand between kind of what you work on and how it manifests in the real world. I'll start off with Swami on this one, but I'd love to hear others chime in as well. We're kind of talking about, the common theme, I guess across all our different stories is, what DynamoDB enables customers to do something that is different, right? And this is kind of the whole thing of, we work backwards from customers, and Don McCaskill was customer zero, as I like to call them. What is it about DynamoDB that enables customers to do things where, say, other database technologies previously couldn't? Like, what kind of is remarkable about DynamoDB or is different that enables those use cases or those scale characteristics and performance characteristics?
If you see, historically, databases have always been designed for like a single box kind of outlook where the data actually and the performance to scale, you had to scale the box up. And then, of course, they had redundancy, but that's how databases were thought of. And then when we originally did the Dynamo system internally, while it was great, it enabled seamless scalability. It forced practically every user of Dynamo to run their own cluster and become a distributed systems engineer. So seamless scalability was not easily available for developers in the same way what cloud made it easy for compute. So that led me and few of us to ask ourselves, saying like, so what does a seamlessly scalable, high performance, highly available and secure database look like? And DynamoDB was born out of the need for a database to be able to seamlessly scale for any size workload while providing the consistent performance as a managed database. Kind of what Tony said about, that's exactly the customer experience we envision. It doesn't matter if they're using and storing 1 million item or 1 billion or 100 billion or trillion, consistent performance without them having to actually deal with migrating shards and clusters and all this stuff as well. And let's take Zoom as an example. Early in the pandemic, Zoom instantly went from like 10 million to 300 million daily participants, right? And I remember reading a quote from them, something like, using DynamoDB tables in conjunction with on-demand mode enabled them to scale nearly infinitely with no performance issues, even with their sudden spike in usage. That is like what, to me, even till date, it is the most remarkable feature for Dynamo.
I think, like the Zoom story, I always kind of think about as, what if the pandemic, or what if that would have happened 10 years ago? How would that have played out? What would have been the technology choices we would have used? Would have materially changed people's lives, differently based on the tools that were available at that time?
First of all, I hope the pandemic never happens. But let's take it instead of pandemic, a viral moment. But that was the key thing. The cloud did enable an incredible viral moments to happen. So I remember a Super Bowl customer who was doing an ad in the Super Bowl. And historically, it required months of planning to do an online ad and then procuring CapEx and so forth. And I remember my team working with the customer. They scaled to like million TPS or something like that 2 hours before. And then they scaled down to like 1,000 TPS 4 hours after Super Bowl was done. That kind of viral moment and still being able to do was never possible before Dynamo existed. I mean, think of a world where what you had to do before that. Now that is the new normal, but Dynamo kind of enabled this kind of thing. And that is what cloud has enabled. I mean, when I say cloud, that's what AWS kind of reimagined on developer productivity and all our services as well, from compute, storage, and also in databases across Dynamo and Aurora. But Dynamo just enabled this level of seamless scalability in a big way. And so many customers enabled this, all the way from all the customers we talked about, let alone Amazon for its Prime Day, where we saw like millions of transactions a second and whatnot. So very, very exciting team. And I'm really excited to see how much more innovation comes through. And maybe we might add store procedures, Tony. Who knows?
Looks like I'm writing a PR FAQ this weekend. So all right. So each of you, as you kind of go through the progression of time, each of you have been, faced with a different set of challenges, and you've got to build on, what the predecessor has done before you. Going back, for the time that you're GM, can you talk about like the different features, the different use cases that were really kind of central in the way that the product evolved and what that let you and what that let customers do. And Tony, you were more than welcome to take credit for everything that was built under the time that Jim was GM. So you can take credit for all that work.
You know, with DynamoDB, you know, you take over as a GM, and you know that you're inheriting quite a legacy from all the people that came before you, and you're the steward of something great for the time that you're there, and that you hope that you leave something better to the next generation who's going to pick it up from you. And that's how, you know, I looked at it. And you know, you're at awe of inheriting the thing that you got. And then, you know, as time has progressed, you know, the needs have changed and so on. So by the time I got Dynamo, you know, we had a lot of customers, and they loved the throughput, and they loved the performance and the scalability and everything. And then, you know, there's like, yeah, but I want now the extras. So I like backups, and I want point in time recovery, and all these other things that people, you know, didn't associate with this high performance stuff. It's kind of like, you know, I have a race car, it goes really fast, but now I want air conditioner and a stereo, and I want, you know, comfortable seats and everything. So that was a period where we were adding a lot of features that really people wanted, and it did start with backup. But, you know, the special thing about Dynamo was, it's not just about doing backups, it's about doing backups on tables that might be several hundred terabyte in size without actually impacting the performance. And that was one of those things that didn't happen in databases. Like, everybody had a window of time where they did backups on their databases on Sunday morning at 3 a.m. because they didn't want to impact performance of the primary workload. And with Dynamo, we're like, no, we're going to do a kind of backup where you can do a backup any time of day during the regular workload, because really, Dynamo never sleeps. Like, there's never a good time to do backups because people have applications that are running 24 hours a day. So that was a special thing, which was remarkable. Can you build a backup system that has zero impact on the workload? And so, you know, that was one of the things we did. And, you know, we built transactions because people wanted to make it easier for developers to write apps. We did global tables at the time because people wanted to build global applications with bidirectional replications between regions. And then we did on demand because, you know, the problem with the, you know, not knowing how much you need and how fast you need it and when you need it is something that we really wanted to solve with Dynamo. So we came up with the on-demand mode, which didn't require you to guess or predict how much capacity you're gonna need. You just put it on the on-demand mode, and, you know, you consume as much as you need, and then it, you know, when you stop it, you know, you don't pay for it. So those were the things we did. And, you know, they're pretty big features that enabled customers to do things that weren't just difficult, but impossible to do before. Like, really, you know, again, doing backups without impacting primary workload is, you know, was a difficult task in databases. So one of the other things, which was, you know, it's not a big feature, it's not really that interesting, but we spent a lot of time making Dynamo more efficient and less likely to throttle workloads. And, you know, I'm probably just as proud of that work as any other piece of work we've done, because just improving the efficiency of the system for customers and reducing the likelihood that you will ever get throttled. I think those were some of the things that happened during that time. And then, you know, hopefully I left something more manageable for Colin, because I think, you know, these features enabled a lot of customers to pick up DynamoDB and start adopting it. So that was exciting times.
Yeah, and I'd say that like that really, you know, there's a lot of sort of continuity from what Tony just described through when I took over. So, you know, when I came in, a bunch of that work had been in flight for a while, and so it was a series of launches. Probably, you know, the work on sort of not throttling customers and making that more predictable and even more seamless was some of the most important work I think that's happened over the last 5 years. You know, customers, you know, had to know a little bit about what was going on under the covers, more than we wanted them to. up until really about 2019, 2020, where that problem I think really got solved largely, where you could just set a number and we would manage that number and do a bunch of really clever things under the covers to manage capacity and manage heat in a way that's really just seamless to customers, where they didn't have to have any real cognitive load on that. That's been a really big one. It's allowed customers to get more efficient. It's taken a lot of sort of management burden off of them. That's been really great work. Similarly, we built on top of a lot of the work that was done by Tony and Jim and folks on backup to allow export to S3, where sort of very similar characteristics to what he was describing with backup, where it was just a call, a single API call. We could get your entire table dumped into a format in S3 without impacting your operational workload. And customers have built some really amazing things from that, just being able to get access to that data and being able to use it in all sorts of interesting ways. One trend we've definitely seen is sort of this emergence of major launches with on-demand and global tables. We did some upgrades to global tables, in around 2020, where you could now add and remove a region at will, convert an existing table into a global table. And then what we saw customers do with it is get into this mode where, for major launches or expansions, they would use a combination of global tables and on-demand mode, where they just couldn't predict in advance, similar to that Disney case we were calling out, like how much traffic would show up. They'd run in on-demand mode for a little while and then switch back to provision if they felt like it, if it made sense for their use case, and use that once traffic had stabilized. And probably the last and most recent one I call it would be the infrequent access table class that we just launched. So the other thing that we're seeing is sort of customers using DynamoDB for a wider breadth of use cases, and including cases where you have these extremely large tables with lots of storage, but maybe less I/O working against it. So making sure we can sort of have data for its entire life cycle, sort of just maybe that brief intensive period where it's been being sort of highly used in a viral moment.
It's fun to reflect back on those. I'd be curious. So Swami, one of the things that I've always kind of loved is like DynamoDB added the ability to do streaming. So like event-driven programming, way back in 2014, right? Which is still, we kind of think about databases and adding streaming is still, top of mind for a lot of people today. What was kind of the initial feedback on the product definition, and what kind of prompted, those kind of initial investments in, global secondary indexes and streams and JSON formats for the product shortly after launch?
Yeah, hearing what Tony and Colin and talk about key innovations. This jogs me back memory to streams and GSI and others too. But I'll say first of all, one quick thing. While Dynamo, as I mentioned, these seamless scalability, ability to create a table that does like 100,000 writes and 1,000 reads without having to spend like 3 weeks setting up distributed systems, clusters, and all this stuff was like a big innovation at that time. If at that time people knew how much work underneath the covers, all the workflows and all the setup that goes, it was like quite amazing engineering the team did in terms of innovation. But the other big one at the time was we were one of the first, if not the first, to actually use SSD optimized technology at the time to actually get single-digit millisecond latency at any scale. And that was, now it is obvious again, just like cloud is new normal. When AWS started, they were like, what are they doing to now? Of course, cloud is the new normal. It's the same way like DynamoDB kind of set the bar for what seamless scalability and consistent performance at scale was. Then, of course, when we launched it, we launched with primary key as hash-based key, and then a hash range and secondary indexes within partition or local secondary indexes. Then, of course, just like any database customers would want, they wanted more flexibility with global secondary indexes was a big innovation, and ability to store and query JSON document. But one of the things I put it on the bucket of like innovate on behalf of customers instead of doing exactly what customers want was the DynamoDB streams. Customers naturally don't just say, I want to change log from Dynamo. They typically are saying, I wish DynamoDB actually could replicate to a data warehouse right away, or to actually my other system this way or this. And instead of us actually building 100 point-to-point integrations, one of the things we realized early on is no database should be an island. This is something in my current role. That's what many of you hear from me in town halls and or in my staff meeting, that no system should be an island because our customers want the data to be able to not just be stored and queried in their transactional database. They want to be able to analyze in their analytics systems and also use it for prediction and machine learning. So DynamoDB Streams was a quick way to actually get the change logs so that you can actually start doing analytics and data warehouse and also leverage it in future for BI and machine learning and so forth. So that was a great building block for us that enabled us to do a lot of other things too. And it is really fascinating to see how customers are leveraging it now to actually build the bridges between their islands within their own tools too. So these are some of the interesting innovations that I'm still excited to see as stood the test of time.
No, that's fascinating. I think if you kind of look back at, event-driven programming and streaming in 2014, and we really, kind of to speak to Colin and Tony's stories about, building, DynamoDB isn't a single instance service. It's really a distributed system built of microservices that allow us to be able to do backups, continuously without impacting the performance of a database and be able to do exports to S3. And you look at all these things, those are microservices kind of long before the time we really started to talk about this in kind of, more kind of broader terms. I think the one thing that's really pretty interesting, and it kind of goes, somebody emailed me internally, last week and said, hey, can you send me the original press release for DynamoDB? And I was like, well, it's up on the website. The second question is, was DynamoDB serverless when it launched? And it was like, yes, absolutely. But kind of the interesting is the term serverless hadn't even been coined really at that point. I think it came later in the year 2012. So, I'd love to learn a little bit more of like what those discussions were like. But then, more from Colin and Tony as well is, what has that really meant to customers nowadays as, as they're even, continuing to modernize their applications and move to the cloud? Like, how has serverless really impacted their businesses and what this enabled them to do?
Sure. You're right that in 2012, I'm not sure the term serverless was even coined as a thing. You always used to say without having to provision servers or provision clusters and so forth. But the thing actually at the time, what was clear was that customers wanted amazing seamless scalability, and they actually didn't want to deal with all the element of running large-scale distributed systems to manage these things. And so we always envisioned, and one of the things we kept coming back to was having played a small part in also building things like parts of S3 and then finished building RDS. I kept going back to saying, like, what does S3 for database look like? And S3 is the best example of serverless storage mean. And we always thought of Dynamo as like, what does S3 for database look like? And not having to provision any kind of database clusters and racks and setting up replication groups and then knowing when to failover, when to reshard, all these things. So, and we wanted all these to be abstracted away so that customers can simply provision a table and then underneath everything else happens. And DynamoDB did come up with a model called provision throughput, and there was a reason to it, even though customers do have to specify the write and read throughput. But that was because we heard early on from customers that they deeply care about consistent performance at any scale. Since then, our customer bases have evolved to like hundreds of thousands of customers. They also said, hey, they want to be able to burst on demand. And I would imagine now it is pure on demand too. But now what is clear is if you see so many of serverless applications running on AWS with Lambda API gateway, DynamoDB is the by default backend that is just powering so many of these amazing serverless applications. And it's been great to see the level of innovation happening on it. So I'll hand off to Tony and Colin to see how serverless in their view has emerged. So.
Yeah, I think, by the time I was working on Dynamo, you didn't really have to explain the Dynamo serverless concept to any of the customers. They just inherently understood, because they just thought of it the same way as they thought about S3. And so what you said about the early days is exactly what happened. And occasionally you would have a customer who would say, hey, I have this database and I've got an 8-core HP machine or something. What do I need in Dynamo? And I'm like, well, how do you size your S3 thing? And go, well, we don't. We just put stuff in there. I'm like, okay, that's how you do it. And and then the conversation was done. And the sizing of the throughput and all of that over time, of course, it became easier and easier as we moved to the on-demand model. But it was such a nice thing not to talk about memory and cores and sizing of the system, and which is one of those things that you deal with more traditional relational databases, right? Everybody's sizing servers, right? And that's just not something you have to worry about in Dynamo.
I think from my side, I've been running large-scale distributed systems for about 20 years and working on them for that long. And just, I'm thinking back to sort of the earlier days of Amazon. This is pre-AWS, where, the conversation year after year was, how is this going to scale? How are we going to get this to be, 10x bigger year over year? And that was where a lot of our engineering energy went day in, day out. And I think one of the most sort of telling serverless stories I have going back to Zoom was, when they went from 10 million sessions to 300 million sessions, one of the stranger experiences I had is we kept reaching out to talk to them. This was a customer who was, just growing so quickly. And, the Dynamo team would reach out and say, hey, we'd love to check in with you. How are things going? We'd love to hear if you have any features in your roadmap. They did not want to talk to us. They refused to talk to us. They're like, you're doing just fine. This is working beautifully. We have other things we care about right now. We have no interest in talking to you. And just the fact that they could just, wave away that problem of how do they scale their database was really stunning, and just a huge contrast to, systems I'd had to build and run myself. So I think that's a fairly amazing experience for a customer, just not to have to think about those sorts of operational issues.
That's so, like, you think about serverless. Another one of those kind of interesting ones was NoSQL, and kind of, back in 2010, NoSQL was something that was was still something that was pretty new in the nomenclature of most folks, and it wasn't mainstream. And we talk a lot about consistent performance at scale, and we spend a lot of energy on the team, preserving that ethos and that value for customers. But what is it about NoSQL in DynamoDB that enables customers to really be able to achieve that consistent performance at scale?
I'm happy to go. I'd say, first of all, NoSQL is, a term that we as industry started going to explain any systems that doesn't have to support SQL API. But for me personally, when I thought about what does a database for the cloud looks like, one of the first things I asked myself was, what if I'm not constrained by the SQL semantics? And SQL at the time, but now Aurora has shattered all those limits of constraints of SQL underneath the covers. Maybe that's a topic for a different session one day. But at that time, SQL systems really did require data to be actually always mostly confined in a single box, or you had to scale up your storage system and processes and so forth. So one of the things we asked is, if you want to be able to scale from like 1 million items in a table to 1 billion or to 1 trillion, and not be constrained on how being able to store it, being able to query. So what does that API look like? And that was one of the first things where said maybe SQL is not necessarily the right way to explain these semantics. And you got to think about data model differently on how you define your base table, how you define indexes as the view of the base table, and then how you decouple systems with streams and whatnot, which is one of the realizations or ideas I had. Since then, I mean, the world is and so much, and now we have like various views on different kinds of data, from graph to in-memory world to all kinds of new data structures. And document and several other things as well. But still the core problem of customers being able to actually be able to store and query data seamlessly without having to worry about scale and what kind of access primitives that they have access. And I think Dynamo will constantly be on this a mission to support these customers, but also support new kind of access methods. I mean, Colin has to decide working with his customers if he wants to put a SQL API on top of that. I hope not, but nevertheless, I do think with streams, I can already see customers being able to get data seamlessly through from Dynamo to graph databases like Neptune and start building various things around knowledge graph and so forth. So I think not having to be constrained by your relational API is such an interesting freedom that customers didn't have before. And now it is available as part of the toolkit. So,
yeah, for me, it was, it was really never about SQL versus NoSQL, as in the language, not about the structured query language. It was relational versus non-relational model and the burdens of the relational model. And so with DynamoDB, the performance is predictable and it's always consistent because it's not related to the size of data operations. So your get and put, are always the same regardless of how many rows are in the table. Where in the relational model, the bigger the thing gets, the slower things get, right? It's not. And I think that's one of the big differences, in fact, the simplicity of the APIs. So you can put a SQL syntax to do a select instead of a get, that's fine, right? So it's really the difference is a relational versus non-relational model, which Dynamo has. And it is what gives you that consistent, predictable performance and less opportunities to shoot yourself in the foot because you forgot a predicate and now the query plan changed, then all kinds of bad things happen.
I agree.
Yeah, and really under the covers, in many ways, that's kind of the design philosophy around the API, is we have to be able to look at it and say, if we want to add this feature or that feature, can this scale indefinitely from 1 request per second to 1 trillion requests per second without having to change anything? So.
Yep. And we spent a lot of time making sure that we answered that question thoroughly before we release features. So other than maybe perhaps stored procedures, Colin, given you're the current acting GM, where do you see the future of the service evolving, and where do you see that we're going to innovate moving forward here?
Sure, and it's probably worth even starting off with the things we won't do. So everything that we do has to be consistent with the idea of providing seamless scale and consistent performance. And so, there's still a number of things, though, that we're seeing as the number of use cases come in the non-relational world, and we're just seeing a more diverse sort of set of demands there. And so, like, good examples of this in the recent past would have been things like launching, the infrequent access table class and on-demand. It's still the same access pattern that folks are using for us, but it's just, different mix of, how often they want to get at their data, where the value of the data is, or how spiky the workload is, but it's still sort of fundamentally a DynamoDB use case. So I still see a number of those in the future where we can expand the diversity of use cases for the service and let folks use it for more and more of these operational use cases. So I think we'll see more there. The other area where I definitely think we'll see a lot of movement is on integrations with other services within AWS and just with other ecosystems. So, the same sorts of things that we've done in the recent past with, integrations with AWS backup service, and export test 3. I think you'll see a number of things in and around those spaces where you can do more with your data, and it's very easy to use your data in other contexts if you've gone in and out through the DynamoDB front door.
Awesome. Appreciate that. And, DynamoDB is, we talk about this a lot, is, purpose-built databases. We have many other databases and a much broader, I would say, ecosystem of how customers can derive value from their data. Swami, how does DynamoDB fit into our overall data strategy? Kind of dovetailing on what Colin had shared about the future of Dynamo.
I mean, when you look at what is it that customers are actually trying to accomplish with data, now the broader trend we see at almost every company, let alone all the emerging startups, irrespective of whether they are an emerging hard tech startup to an 100-year-old enterprises, they all want to be more and more data driven. So, and what does that mean? That they want to be able to make data driven decisions. That means it's not just enough to store your database, your transactional data into a database. You want to be able to analyze them as quickly as possible and visualize them, let alone you want to be able to run predictive workloads powered by machine learning and so forth. So this end-to-end journey is super important. And one of the first steps is for you to be able to run these kind of end-to-end data journey. You want to be able to modernize your database infrastructure. And this is where AWS pioneered this one from the beginning, because at the time, almost every old database vendor would say, what is your answer to database? They will always give one database name answer. And it was a SQL relational database. And we actually said different databases tend to expose different semantics. And we pioneered the purpose-built database story. And we had RDS for our relational databases, and Aurora is our enterprise or RDS database that has all the properties of enterprise databases at the cost of open source database. And then Dynamo is our flagship non-relational database service. And then we have also Graph database with Neptune and so forth, and in-memory database with Elasticache and also MemoryDB and several others. But if you see, these are the necessary ingredients you need for building a modern data-driven application and to store, query, and process them. And from there, you'll also see us actually connecting the dots more and more. We touched on it with streams being an easy conduit to get your data to other systems. And from there, we want to be able to make it more and more seamless also to run analytics on top of these data from all these modern data stores, and then being able to run machine learning workloads so that you can do personalization as quickly or forecasting and so forth as well. So very excited about how this fits, and also to enable customers to innovate more with data as well through Dynamo and all our services across the board.
I appreciate it. Well, I want to thank Swami, Jim for all his contributions, Tony and Colin for joining us today. This has been really insightful and been fun to learn about past, present, and future for DynamoDB.
Thanks again.
Thanks a lot.
Thanks, everybody.
Hey, Eric, I think you're muted. I can't hear you, but I do see myself on screen now.
Okay, yeah, you are muted. I was muted, so hopefully that is fixed. That was a amateur move. So we're going to go back and do that whole session again, and then I'm going to do a transition again. So everybody buckle up. So
they're not busy.
Yeah, exactly. So hopefully that you hear sound now. Thank you. Yes, classic. That was an EDG geek move. I would like to say it's because I don't have thumbs. I couldn't hit the mute button, but nobody's buying it. So there you go. So Alex, glad you're here. You are one of our data heroes. Now, little known fact that your in-laws, if I'm not mistaken, live roughly 20 minutes from me.
So about that was directionally correct. I will say.
Okay, good. Okay. Good.
My parents, not my in-laws, so my wife's in-laws.
Yeah. Okay.
Used to live 20 minutes from you, but now they've moved about 20 minutes from me. They're in Omaha, Nebraska. They've left the great state of Colorado.
Thank you for making that little known fact absolutely pointless. I appreciate that. So,
but hey, you had some of the basics, right?
Yeah. So somebody lives somewhere near close to where I live currently. Exactly. So yeah, thank you. Alex and I go way back. We have sat in many dinners together. We have debated serverless tools. Alex lost, I won. So it is. So winner always writes history, right? So, but Alex, you're going to be talking.
Hold on, on a related point there, I've been told to tell you that not only is configuration better than code, but code is better than Diet Dr. Pepper.
Well, we've seemed to have lost Alex in the stream. I don't know what happened, but it is just kidding. So yes, thank you very much. I appreciate that. I'm going to turn it over to you. What is your session on today?
My session is on data modeling, why data modeling is critical for success, or even maybe a different title that I might have it for it. But yeah, we'll be talking about data modeling in DynamoDB and the process of data modeling. So got some new content here. Yeah, and excited to share with people.
All right. Well, despite how mean you are to me, I know you're very smart and you have a lot of great stuff. So I'm going to turn it over to you. Thanks for coming. And it's all you.
Absolutely. Thanks for having me. And everybody else, thanks for coming. Really grateful for you being here today. Again, I'm Alex Debris, and this talk is why data modeling is critical for success. As I mentioned with Eric, we've got some new content here. You know, I do a lot of talks on data modeling, but I want to have some new stuff here. And what it's really going to be is actually an extension and a deeper look at some of the stuff I do talk about in my other talks. So if you look at the screenshot here, I pulled this off YouTube from my reInvent 2020 talk. But often in my DynamoDB data modeling talks, I'll talk about this data modeling process, right? And I'll talk about this 4-step process where, you know, number one, understanding your application, check, that makes sense for most people because you're not going to be able to model your application if you don't understand it. So that makes sense to me. You know, that second step, create your entity relationship diagram, your ERD. That makes sense to a lot of people because they've done that with relational databases before. They're used to that sort of thing. You know, the third step, that's where it starts to diverge from relational database modeling, where you actually list out your access patterns. But we talk about why in the modeling sessions and why that's useful, and people picked that up as well. But then it's this 4th step, right? Design your table to handle your access patterns, where I know my application, I've listed out my access patterns, and now I go and do this. And I always feel kind of bad just leaving it there because that's a pretty complex step. And it sort of reminds me of the how to draw an owl meme, right? Where there are 2 steps in how to draw an owl. First, you draw 2 circles, and then you draw the rest of the dang owl, right? Well, today, I hope I'll teach you a little bit more about how to draw the rest of the owl when we talk about the data modeling process. So, you know, we put this up there as why data modeling is critical for success, but I also like to think of it as data modeling process plus, right? Where we're going to dive a little deeper into those 4 steps and figure out what you should be doing as you're working through designing your DynamoDB data model, and then what the outcome of that is. So just in terms of agenda today, you know, we'll start off with some DynamoDB basics just to get everyone on the same page in terms of terminology and what DynamoDB does well, what's sort of distinctive about it. And then we'll talk a little bit about that data modeling process. So those 4 steps we talked about before, we'll look a little deeper at those first 3 steps and what those look like, add some meat on the bones there. And then we'll go into designing your table. We'll talk about that last step. Hey, what are the actual steps as you're breaking that down? What should you be going through as you're actually designing your table? How do you know where to start? Different things like that. And then last thing we do is a more advanced thing, but a kind of interesting thing about Dynamo. I call it doing the math, which is kind of fun. So who am I? I'm Alex Debris. I'm the author of the DynamoDB book, which is a comprehensive guide to data modeling with DynamoDB. If you were one of the first 1,000 US-based folks to sign up for this event today, you should get a copy of this in your email. So be looking for that over the next couple days. I'm also an AWS data hero due to my work with DynamoDB, you know, talks, tutorials, blog posts, things like that. And then I'm an independent consultant. So if you have any needs around DynamoDB training or data modeling or just broader AWS serverless type stuff, feel free to hit me up. If you want to take a look at the book, it's at dynamodbbook.com. And with that in mind, let's get started off with DynamoDB basics. I always like to start off with terminology. So 4 key terms we're going to talk about here: table, item, primary key, and attributes. We're going to be looking at this by way of an example that's going to flow through this entire talk today. So this is an event ticketing application that we're going to be building, sort of modeling out. So think of something like Eventbrite or Ticketmaster or maybe even meetup.com, something like that, where you know, users can create events and sell tickets to their events. Other users can come and actually purchase tickets to those events and things like that. So that's the example we'll have today. You know, the first most basic thing we're going to need there is users. So here are some user records. You know, we've got 4 records, myself, Alex Debris, 3 other users as well. If you look at all that data together, that's going to be contained in what's called a table, right? So a DynamoDB table is going to hold all your data. similar to a relational database table in some ways, also maybe more comparable to a relational database cluster or instance itself, but comparable in some ways to that. Now, if you're looking at an individual record in that table, that's going to be called an item. So you can see here, I've highlighted this Alex Debris user record here. That's an item comparable to a row in a relational database or a document in MongoDB, something like that. Now, when you create your DynamoDB table, you have to specify what's called the primary key. And every item you write into your table has to have that primary key, and that primary key needs to uniquely identify each item in your table. You can see here on the left-hand side, we have this primary key. It's a username that's uniquely identifying each item in our table. You know, you might be used to a primary key in a relational database, but often that's going to be like an auto-incrementing integer that just sort of, is assigned when that row is created, has nothing really inherently to do with your record itself. With DynamoDB, as we'll see, your access patterns are really going to be driven by that primary key. So you want to use meaningful values there, like a username, an organization name, an order ID, different things like that. Something meaningful to actually look up your items there. Now, in addition to that primary key, we also have attributes. You can see attributes on the right here. First name, last name, email address, just different other attributes you might have in your application. You could think of this similar to columns in a relational database, with the big difference being you're not going to specify these up front, right? So DynamoDB is schemaless. And what that means is outside of that primary key, it's not going to validate a schema for your items when you're writing to your table. That doesn't mean you shouldn't have a schema in your application. You absolutely should, but you're going to handle that at your application layer. When you're writing to DynamoDB, when you're reading back out, you want to validate your items and their attributes there. All right, so those are the first four terms. I want to dive a little deeper on primary key because it's so important to working with DynamoDB. Two types of primary key with DynamoDB. The first one is called a simple primary key. This has a single element called a partition key. Second type is a composite primary key, which has two elements, a partition key and a sort key. If we go back to our users table that we already looked at before, that is an example of a table with a simple primary key. It just has that single element of username, that partition key there. This is great if you have basically like key value type application needs, right? You're just working on a single item at a time. Maybe it's like a persistent cache. Maybe it's something else, a users table where you have very simple application requirements. That can work for you. But if you have more complex application needs, if you have relationships, if you have fetch many type requirements, then you're going to probably use that composite primary key pattern. So to look at that, let's do an example of the actual events we're going to store in our event ticking application, right? And so an organizer can create different events and store those in their table. Here's an example of our table with a composite primary key. You can see that primary key now has two elements, right? The partition key on the left, that's organizer. And we have debris advisory, we have Jen's consulting, different organizers for these events. And then we also have this sort key of event title, has the name of the event for it there. I'm going to be using these sort of data model images a lot. These are created by NoSQL Workbench, which is a tool from Amazon to help you with your data modeling. And one thing I want to call out here is if you look at the, we have 4 items in this table. If you look at the top 3 here, those are 3 distinct items in our table, different event titles with different data on them. But if you look at it, that partition key value is the same for all of those items. And then NoSQL Workbench, what they're going to do is sort of merge those cells to indicate that they have the same partition key. And the reason they're doing this is because if you have that composite primary key, you can actually act on multiple items that have the same partition key. So I could do what's called a query operation against those items, specify just the organizer. I don't have to say anything about the event title. Maybe I want to fetch all the events for a particular organizer. I'm looking on their profile page or something like that. I could say, hey, query where the organizer equals debris advisory. It's going to find those items really quickly and return those back to me. In terms of terminology, we're going to call that an item collection. So an item collection is going to be any set of items that have the same partition key. And because Dynamo has that query operation, it's very efficient to work on these item collections, read multiple of them. So we'll use this for grouping type use cases, grouping and filtering type use cases there. Also notice that within that item collection, those items are sorted according to that sort key. That's why it's called the sort key there. That's going to be sorted within a particular item collection, right? So within all the items with a single partition key, it's going to sort according to that event title. notice that there's no sorting across different partition keys, different item collections. They're all going to be sorted just within their particular item collection. All right, so we have a little bit of terminology. I want to talk about DynamoDB distinctives, right? Because every piece of software you have is going to have something that's distinct about it, and there are trade-offs of using it. I think that's especially true in databases, right? Different databases excel at different things, whether that's OLTP, whether that's analytical OLAP type queries, whether that's time series, something else. I think DynamoDB is really interesting because it has the most clear trade-offs and sort of most distinct trade-offs from other databases, which is interesting. So 2 things I want to point out in particular. Number one, all your access patterns in DynamoDB are going to be driven by those primary keys, right? So if we go back to our application that has our events in them, we have that composite primary key. It's very easy for us to access our data using that primary key, using the organizer, the event title to figure out what we want. But it's not as efficient to query based on just those attributes directly. So we're not going to do that sort of thing. And what that means for you is that you become the query planner. If you're working in a relational database, you can query sort of on all different fields that you want. When you write your query to the database, it's going to parse that, and then it's going to make a query plan, and it's going to look at different table statistics and certain things it can figure out to try and figure out the most efficient way to do that query. With DynamoDB, that's not the case, right? There is no query planner. You're basically just getting direct access to these powerful data structures like a hash table, like a B tree. And what that means is you sort of need to arrange your data in the right way according to your query plans. You become the query planner. But then what you get out of that is consistent, predictable performance. And this is things we've seen, throughout the different talks today. When Don from SmugMug talking about what they wanted from a database, this is exactly what they wanted. They wanted consistent, predictable performance across all those different images they had in SmugMug and Flickr. So that's that first distinctive of DynamoDB. The second one is about its billing mode, right? Where you're billed by the data read and written directly. So let's talk a little bit more about DynamoDB billing. And again, what you're doing is you're paying for reads and writes directly rather than resources. And this is really different than relational databases or even a lot of other NoSQL databases where you're sort of provisioning instances, right? Where for each of those, you need to spin up some instances. And what you're saying is, I want to choose this much CPU, this much RAM, this much IOPS, things like that to handle my queries. But it can be tricky to figure out how my operations translate into these resources like CPU, RAM, and IOPS, right? If I know I have 1,000 queries per second on these user records, how do I know how much CPU, RAM, and IOPS that's actually going to consume? Whereas with DynamoDB, you're going to be charged for read capacity units, RCUs, and write capacity units, WCUs. And this is actual data you're reading and writing directly from your application. You don't have to think about CPU, RAM, IOPS, any of that stuff. If you know you have 1,000 operations per second on these users and you know they're 1 kilobyte, you can figure out exactly how much WCUs and RCUs you need. Maybe give yourself a buffer, for fluctuations, but it's pretty easy to figure that out. The second thing about DynamoDB, we've heard a lot about this today, but there are 2 different billing modes, right? There's provision mode, which is where you say up front, hey, I want this many RCUs, I want this many WCUs. DynamoDB is going to guarantee that that's available to you on a per second basis for your table for you to use, right? If you don't have a good sense of how many RCUs, WCUs you're going to use, you can also use on-demand or pay-per-use or serverless capacity mode, whatever you want to say there, where you're just issuing reads and writes against your DynamoDB table and saying, hey, send me a bill at the end of the month with the total number of reads and writes, and I'll pay for those on an individual request basis, right? So really powerful there, good for serverless applications or spiky applications or whatever you want where you don't know your particular access patterns yet. So that's that second distinctive about Dynamo. You're billed by that data read and written directly. And what I really like about this is there's a tight connection between DynamoDB's cost and your cost, right? What DynamoDB is saying to you is, hey, there's both a performance penalty or a performance cost and a billing cost with reading data, with writing data. And we want to expose that directly to you and make sure that you're sort of build on that your performance depends on that so that you can factor it into your applications, rather than sort of having this black box again of instances with CPU, RAM, IOPS. You can't really figure out what's going on there. And it allows you to sort of efficiently optimize your application to what matters to you. The other thing I love about this is you can do the math, right? You can figure out, should I do this access pattern this way or that way? Which is going to cost me more, whether in actual, your bill cost, whether in latency, you can make that trade-off. Or you can say, hey, should I add this access pattern and how much is that going to cost me itself? So we'll talk about doing the math later on. All right, last thing I want to talk about, just a little more terminology for DynamoDB, or our secondary indexes, which are super powerful, very common in DynamoDB. Let's go back to what we were saying, right? Where we have that primary key, we want to be querying with our primary key and not with our other attributes. And this can be very useful and flexible for us, right? If we want to be getting an individual record based on its organizer and event title, we can do a get item operation and specify both that organizer, the event title. That's going to be a very efficient operation. It's going to be a consistent operation. No matter if I have, 100, 1,000, 1,000,000, 1,000,000,000,000 events in my application, this is going to be about the same amount of time to get that particular record. It's going to fetch that back for me. Also, like we were talking about, maybe we want to get some related records, right? We want to go to this particular organizer's page and fetch all the events for them. That's where you can use that query operation, specify that partition key, get that partition key, get those records for that partition key and return all those back. We can even get a little more specific there, right? We can add some conditions on our sort key in that query. So we can say, hey, maybe we want all the events for this particular organizer where the event title, it comes before F in the alphabet, right? And again, this is gonna be a very efficient operation where it's gonna go find that partition key. It'll do that binary search to find out which ones match that sort key condition and return those back to you. So that'll be a very efficient operation. So you can see this is great for a lot of different patterns we might have, but we might also have some patterns that don't work with this particular primary key sort pattern, right? If I'm looking for events that I care about, I'm going to look by location, right? I want to see what's happening in Omaha, Nebraska. And not only do I want to search on location, I want to know what's happening in Omaha, Nebraska this weekend. I don't care what happened, last weekend or next year or anything like that. So implicitly, I need start time in there as well. So how can I query by location and start time? That's where secondary indexes come in, right? These are attributes. This data is spread across different partitions, so it's not going to work with our primary key. But what we can do is go to our table and create this secondary index with a new primary key. We can say, hey, we want a secondary index where the primary key has a partition key of location, a sort key of start time, and it's going to make basically a copy of our data in this secondary index for us, right? So we set that up. Let's take a look at that. This is our secondary index view now. This is all the same data that we had in our application before, but you can see it has a different primary key. And that allows me to make new queries on my data, right? Where I say, hey, if I want to query for what's happening in Omaha, Nebraska, I can do that query against my secondary index, use that partition key there. It's going to efficiently find those items in Omaha, Nebraska, and go fetch those back and get them back to me. So secondary indexes are going to be super powerful. Again, just a little summary of what they are. Data from your base table, your main table, right, is going to get copied into that secondary index you create with this new primary key you specify. And because your access patterns have to be on your primary key, this is basically giving you additional patterns on your table, right? So you can use this for read-based operations on a secondary index. You can go to that secondary index and make reads against it, but you can't do writes against your secondary index. If you want to write your data, if you want to delete, update, insert a new record, anything like that, you have to go to your main table and it's replicated out to your secondary index for you to do reads against. So why is this so useful, right? This is good when you have multiple read patterns on the same underlying data. If I think about my users before, maybe I want to fetch them by username sometime, maybe I want to fetch them by email address at other times. If I talk about my events, maybe I want to fetch them by the organizer or the organizer and event name at sometimes, but other times I want to fetch them by the location start time, different things like that. That's what secondary indexes give to me, just additional patterns there. All right, so now we've got our DynamoDB basics out of the way. Let's talk a little bit more about that data modeling process. Again, these are the 4 steps that I introduced early on here. I'm just going to run through these and we'll talk a little more in depth about these. Again, number 1, you want to understand your application. You really want to know what you're building before you start trying to model it, or if you don't have clarity there, you're gonna have a problem. Second, you'll create that entity relationship diagram, your ERD. Those first 2 steps, again, very similar to what you'll do in a relational database if you're modeling for that. But, in a relational database, you often take that ERD and ship it straight to your database, right? Where every box in your entity relationship diagram becomes a table in your relational database. Then you set up foreign keys or maybe a joining table to handle those relationships you have. And then once you've done that, now you go think about your queries and things like that. But in DynamoDB, you're not going to do that first because, again, those access patterns are so important to how we model. So what we want to do is model for our access patterns. So the next step you want to do is you want to actually list out your access patterns and be very thorough here on what we're actually doing. And again, the reason we're doing that is like we were talking about before. You are the query planner. This is part of the steps here, right? You are planning out your queries during this design process. So you list out your access patterns, and then once you have your access patterns listed, now you sort of methodically go through your table, design that table to handle those access patterns specifically. And one thing I want to call out is these 4 steps are probably all happening before you're writing any code here, right? The outcome of this is going to be a design document where you're saying, hey, this is what we're building. Here are the different requirements. Here's how we're modeling it in DynamoDB. And if I'm a new engineer on your team, or if I'm someone from another team, I'm trying to figure out what your application or your service does, I should probably be able to read this design document and have a pretty good sense of not only what we're building and what our requirements are, but also how it works and how it's implemented, right? So that's the outcome here. Let's talk a little bit more about some of these early steps here, especially let's start off with understanding your application, right? You have to know what you're building here, and you want to spell that out pretty clearly. And when I'm working with teams, I think this is the place where they get into trouble if they don't have enough clarity on what they're actually doing. So, the beginning of your design document might look something like this, right? You write some background. Hey, we're building an event ticketing platform. Organizers can create events. Users can purchase tickets to that event, right? This is what we're doing. Maybe you have a little more detail there, but say what you're doing. You also want to describe the different entities in your application. And I think naming these things and being pretty descriptive on what they mean will help you later on, because sometimes we get into sort of language battles about what we're actually talking about here. So I think describing those out is really useful. You can see I have organization, I have user, I have events, all these different entities in my application. I think another thing you want to do is talk about the constraints in your application, right? So I'll have a section about constraints, right? So we look at this. An organization is uniquely identified by its organization name, and a user is uniquely identified by its username. What this means is these are constraints we actually have to handle as part of our access patterns, right? When we're creating a user, we need to make sure there's not a user with that username already. Same thing with an organization. If we're creating an organization, we want to make sure there's not an organization using that name. We also say users can belong to an organization and that user can act on behalf of that organization. But here's another constraint we have, right? An organization may have a maximum of 10 users that belong to it. That's the max we're going to allow in our application. That's a constraint. We're going to need to model for that, right? So when you create a new user, you got to make sure that organization isn't beyond the limit already. And at this point, we're still in sort of the logical part of our application, right? We're describing what our application is, what we want to actually have happen. But at some point, we need to move to the physical part, right? How are we actually storing these records in DynamoDB to accomplish our requirements and our constraints? So what I do is I like to have what I just call like a DynamoDB items chart. And it's going to talk about the different types of items I have in my table and have a little bit of metadata about those different items, right? Let's just walk through the different columns in this chart. I'll start off with an item type. What are you naming that particular item? When you're getting started here, I just look at my entity relationship diagram, and every single box I have, I put it in here and say, I'll create an item for that. That might change later on. You might have to consolidate 2 different entities into a single item. You might need to split an item or an entity into 2 different items. You might need to have other type of items, different things like that. But you can start off here. Same thing, next column over, what entity is represented by that item? When you start off, it's going to be a one-to-one between your item and the entity. But you might combine, you might split later on. We'll see an example of that. I also like to get a sense of just like the cardinality of these items, right? And this could be across your table, right? So when we're talking about organizations and user, we're saying, hey, this is about how many organizations and users we need to plan for across our database. But this cardinality could also be sort of in relation to another item, right? So we have these membership items here. As we said in our constraints, this is going to be fewer than 10 per organization. We know because of that, there's probably going to be some sort of like list all memberships access pattern. And because this is going to have a strict limit of 10 items, we can probably handle pagination in a particular way. Hey, we don't need to have a paginated endpoint here because it's only going to be 10. We could probably fetch all those. Whereas if you compare it with events, right, and you can have hundreds of events per organization. If an organization is putting on lots of different events all over the place, that needs to be a paginated endpoint. We need to plan for pagination as part of our access patterns. Next thing I like to think about is just item size, right? We talked about how item size or the amount of data you're reading and writing from Dynamo affects your billing. And I think getting a sense of how big those items are help you think about billing during this process, right? I don't think you need to be super precise on how big those items are. I like to think of it in sort of thresholds, right? So, the membership item, all it's going to store is information about the user, about the organization, maybe the role type, maybe a created at time, things like that. But it's probably going to be less than 1 kilobyte. And that's a good threshold because that's how much a write capacity unit is. So I know for a membership item, hey, every time I read it, every time I write it, it's only going to cost me 1 WC or 1 RCU. Next threshold up might be, less than 4 kilobytes. That's the size of a read capacity item. So organization users, they might be a little bit bigger. You're saying, hey, it might cost a little bit to write them, but it's still going to be less than 4 kilobytes. It's less than 1 read capacity unit to read them. But then you might have bigger items, right? Our event item. If you think about an event that someone is describing, right, they're going to have a big text description about what that event is. They're going to have different ticket levels, and each of those have descriptions. We got images all over the place, different things like that. So that event item can get quite big. You're just estimating the ballpark here, maybe 12 kilobytes. Last thing I like to have is read frequency and write frequency, just to think about how often I'm going to be manipulating these items in which ways. This will help me for understanding which access patterns to prioritize later. It can also help me thinking about cost, how my patterns are going to work with this sort of thing. And you don't have to get super precise here. I just like to use words like rarely, occasionally, often, different descriptive words like that. So again, that first step is to understand your application, describe your entities, describe your constraints. You want to be really clear here, because I think the more work you do up front to figure out this sort of stuff, the easier it's going to be later on, the easier it's going to be for someone reviewing your design document to make sure it's not going to cost a lot, to make sure it's going to scale well, all those sorts of things. So that's that first step. Second step is create your ERD. I'm not going to go into that because a lot of people have done ERDs before. But I do want to talk about listing your access patterns, right? With DynamoDB, again, we have to design specifically for access patterns. So that means you need to list out your access patterns, and you need to make sure you're thorough on these, right? You don't want to say generally, hey, we're going to read users, we're going to write events, different things like that. You want to figure out, hey, we have this specific access pattern, this specific access patterns. Be very thorough. 2 tips in this part where people sometimes get tripped up is, hey, list out your read and your write patterns, not just your read patterns. For whatever reason, people just want to list out the read patterns as if that's the only thing that matters, but write patterns matter too. Make sure you're thinking about those as you're listing these out. So this is what I'll often have in my design documents, right? I'll have an access patterns section. I'll have a write access patterns table. Write patterns and read patterns are different enough that I usually have different tables for each of them. You can see I'm just listing the different patterns I have down that left-hand side there with the right pattern. Purchase ticket, create an event, create an organization, create a user, add a user to that organization, right? We're just listing out those patterns, and then we'll fill out these other columns, items altered as part of this operation. Do I have condition expressions? How frequently does this happen? Anything like that. Likewise, I'll also have read-based access patterns. I'll have a totally different chart for that. You can see the patterns down the left side there, different ways to get events, different ways to get memberships, and then those columns. Hey, what am I targeting? Am I targeting my main table? Am I targeting a secondary index? Things like that. But the big key there, make sure you're thorough, make sure you're listing out read patterns and write patterns. Second thing I tell people when listing out your access patterns is you want to think holistically, not atomically. An example for this is this page, right? So this is Jan Trey. He's an AWS serverless hero. He's awesome. He does these production-ready serverless workshops. So this is his actual page from Eventbrite. If you want to learn more about serverless, absolutely take his workshops. They're really great stuff. Probably no one else that knows more about building well on AWS and serverless applications than Jan. But if you look at this page, this is going to be similar to a page we might have in our event ticketing application, a profile page. And if you look here, we have 2 different sets of data, right? We have information about the organization, right? Who's actually hosting this event? What are their name? What are sort of their profile? Maybe their Twitter links, things like that. And then we also have a list of events for that organization. And a lot of times people will treat these as 2 separate operations, right? You can say, hey, get organization, get events for organization, things like that, and think, hey, when someone hits this page, we'll just make 2 separate requests and go. But you can actually think of these holistically. Hey, that's a page that's going to happen, fetching this organization profile page, and you can actually list that together, right? Get organization and events. And that leads me to a little sidebar about DynamoDB single table design. If you've heard a little bit about DynamoDB and single table design before, might be kind of weird to you. I want to talk a little bit about that. We don't have a ton of time to go super deep on it today, but with a relational database, you're probably going to have a table for each entity you have in your application. So you'll have a users table, you have an organization table, an events table, tickets table, all that stuff. With Dynamo, it's common to have maybe just a single table for your application, or at least to combine multiple different entities into a single table. So why would we do that? I think there are 2 key points about Dynamo that are worth thinking about. Number one, you have to use those primary keys for your access patterns. And because of that, you really want to think, my primary keys aren't really just attribute values, but they're basically how am I efficiently indexing my data in DynamoDB. And one thing, Jeremy Daly mentioned this earlier in our roundtable with Jeff Barr, but you want to think of those separately. Your primary keys is almost separate from your data. They might contain data from your application, from your items, but they're often sort of specialized attributes just for indexing well in DynamoDB. And then that data will come along for the ride when you fetch those items. Second thing about DynamoDB is there are no joins, right? That page we showed before, maybe you'd handle that with a join operation, but DynamoDB doesn't have joins. It doesn't have sort of a complex query planner. You are the query planner. So you need to think about these things in advance. But because you know your query patterns in advance, and because you're a smart person that can be the query planner, you can actually handle sort of complex join-like queries or different things like that in DynamoDB. So I'll show an example, and I want to show, just an example. Keep going with our example we have. I'll show a table with organizations and events in them and how you might do that in single table design. Let's get started with a couple organization here. We have 2 organization items in this table, Debris Advisory and Jan Trey. First thing I want to call out and mention here is the primary key, and specifically the names of the attributes for our primary key, right? We're using very generic attribute names. We're, PK for partition key, SK for sort key. So PK, SK. And the reason we're doing this is we're going to have multiple different types of items in our table, and they're not going to share the same attributes, right? I can't put event name as one of my primary key attributes because an organization doesn't have an event name. So I'm going to use these very generic values. Again, they're just used for indexing. Same thing if you actually look at the values for those primary key attributes, right? You might see sort of these weird values that maybe have a prefix saying the item type, maybe have a value in there, maybe it concatenates multiple values together. But what you're doing there is you're just indexing your data in a way that's efficient for your particular access patterns, right? So sort of think of these separately from your data attributes, which are on the right. These are your primary keys, which are primarily for DynamoDB. Last thing I'd say there is you might want to have a type attribute, hey, organization, event, something like that, just to indicate what type of item you're working with if you have lots of different items in your table. All right, so let's kick this up to some true single table design and add some other items in there. You can see we still have our 2 organization items that we had in there before, but we've also added these 3 event items just to show how they can be modeled in that same table for us. A couple things to call out. Notice that the sort key pattern is different for events, right? It's event hash and then this ID, which is this sortable ID called a ULID that's help identifying that event. A second thing you can look at here is look at the different attributes for our different item types, right? An event has event name, event date, things that are meaningful to that event item, whereas an organization has organization name and plan type, things like that, things that are meaningful to the organization item. And because we have these very generic, because DynamoDB is schemaless, we don't have to declare that up front. We can have different attribute types for our different items in here. All right, so let's go back to why we were talking about single table design in the first place, right? We have this sort of organization profile page where we want to show the organization itself, but also the events for an organization. We know we don't have a join operation. Hey, can we do this in a single request? Remember when we were talking about that composite primary key, that query operation can very efficiently get all the items with a particular partition key, right? That's called an item collection. We can fetch that item collection very efficiently with that query operation. If we go back and look at our table here, Notice that we have an item collection here. We've got 3 different items that have this same partition key of org hash yon tray. So that's going to be called an item collection. But if you look at that item collection, it has different types of items in it, right? So at the bottom, it has that organization item. That's Jan tray. It's going to say information about Jan and his organization. You can also see we have 2 event items in there. So in this item collection, we have heterogeneous items in here, but what we can do is we can do a query operation against that item collection using that PK value and fetch all those in a single request. That's one request to DynamoDB. It's a very efficient operation. And because we knew we had this access pattern, what we've done is basically pre-joined our data to handle that access pattern. So basic single table design concepts here. Use generic primary keys to focus on your access patterns. Think of your primary keys almost as separately from your data and just think, how do I want to retrieve this data? How do I want to identify this data if I'm going to update it? And that's what you'll jam into your primary keys. And the rest of the data, that's going to come along for the ride in your operations. Second thing here is you want to create item collections to satisfy your use cases, right? So remember, an item collection refers to a set of items that have the same partition key. You want to make sure you're assembling item collections that handle your use case. And it might be like we just saw where we have heterogeneous items. We have the organization, we have the events in a single item collection, but that doesn't have to be the case. It could be homogeneous items, like maybe it's just event items, maybe it's just the memberships for an organization, things like that. You don't have to do that, but you do want to think in terms of item collections and how can I group these items together to satisfy my use cases. All right, so when we're talking about listing our access patterns, again, I had those 2 tips. Think about read and write patterns and think holistically, not atomically. Think about your access patterns as a whole and try to reduce the total number of requests you're doing to DynamoDB. Now we've done a lot of that prep work, right? We have our design docs, sort of the prep stuff figured out, but now we need to get to that last step, right? Designing your table to handle your access patterns. And that's sort of that drawing the rest of the owl part. Like, if I have all this stuff, what am I supposed to do next? So let's talk about designing your table and a little bit of the process there. Before we do, I want to talk about DynamoDB strategies, right? This is what I usually talk about in my data modeling talk. And what DynamoDB strategies are just different ways or different approaches to handle a specific category of problem, right? So we can think about one-to-many relationships. You know, in previous talks or in the book, I talk about 5 different ways to handle one-to-many relationships. Those are different strategies. And you sort of pick the right strategy depending on your application needs and your requirements, whatever is going to work best for you. Same thing for many-to-many relationships, right? I have 4 different patterns for handling many-to-many relationships. Same thing with sorting, with filtering, with aggregations, lots of different things. You have to know these strategies before you get started. This is what I usually talk about, but sort of once you have this toolkit, once you know these strategies, now you're actually set up to actually design your table. So let's say you know those strategies and you're looking at your access patterns and you're like, man, I got 5 write access patterns. I got 6 read access patterns. Where the heck do I start? Which one do I bite off first? And how do I do this so I'm not just going in this endless circle and not knowing what to do? So that's where I want to talk about the process here, right? If you know those strategies, how do you know which ones to do? I always recommend start with your critical patterns first, right? What is the most important thing in your application? If you have very strict requirements around certain things, especially performance requirements, that might be useful. So when I talk about critical patterns, what does that mean? You might have latency requirements, right? Maybe you have some sort of ingestion endpoint where you need to ingest data very quickly and you want to optimize for latency there so that it returns pretty quickly. Or maybe, in the case of Dawn and SmugMug, they want to be able to show a particular image very quickly, figure out where it's located on S3 or whatever. So they're optimizing for that read-based pattern. You might also, when you're thinking about critical, it could be the frequency of particular operations, right? So some operations are going to get called a lot more than others, and it makes sense to optimize for those. If we think about some of the Dropbox patterns we said, they're storing all this metadata about their stuff. Well, there might be certain operations on individual pieces of metadata that are called a lot more frequently as compared to some data point that's hidden like in the admin settings of the panel and is only get called a couple times a day, right? So make sure you're optimizing for frequent patterns and trying to make those nice and efficient first. we talked about, just having a DynamoDB items chart before, and that's why I like to list out, hey, what's my write frequency? What's my read frequency on these different items, just to get a sense for how often these things are changing or how often I'm reading from these things and how I can optimize for that. You'll notice here, right, for our event items, we're reading those often. Whether you're looking at a particular event, whether you're searching by an organization, whether you're searching for a particular city, we want to make sure that's fast because you want people to be able to find those items. That might be something you optimize for. A third thing you might be optimizing for is throughput. So one thing that's great about DynamoDB is it has very clear limits on sort of what you can and can't do, right? So you can't make an item over 400 kilobytes. It's going to actually block you from doing that. Or you can't exceed your provisioned throughput, your provisioned capacity, read or write capacity, you'll get throttled and sent back at you. Another limit it has is just the number of operations you can do on an individual partition per second, right? So you can't exceed 3,000 read capacity units, 1,000 write capacity units per second on an individual partition. If you have access patterns that you're like, hey, we could actually exceed that. Maybe something's going to go viral. We're like a social media application, or a bunch of data readings are coming in at the same time for a particular sensor or something. You might need to design around that throughput and think about that. So knowing that up front is good. So you can design, figure out how you need to maybe shard this particular partition key or just handle some of the back pressure on the throughput. So again, always start with critical patterns first, and critical is going to depend on your application, but generally look at, hey, if you have strict latency requirements, if you have something that's happening more often, a lot more often, or if you might be pushing those partition throughput limits, look at those first. But once you've gone through your different critical patterns there, hey, you still have a lot more patterns left. I usually recommend doing your write patterns before your read patterns, right? And again, for whatever reason, people want to leave write patterns for the end. I think you want to start with write patterns first. A couple reasons here. Number one, you might need to be maintaining constraints in your application. So remember early on how we talked about constraints in our application, and we said an organization is uniquely identified by its organization name. If that's the case, your main table is going to need to take that into account to make sure it's built into the primary key, right? So if we go to our primary key, we want to make sure that organization name is built into the primary key for that organization. So we can, when someone's trying to create an organization, we can say, create this organization so long as there's not an item with the same primary key. So you want to think about write patterns first, just to help you maintain those types of constraints. Another reason you might want to think about write patterns first is because you might have dependencies between items, whether on the read side or the write side. So let's go back to our table. I've modified it a bit where we've got two events. I've got an organization. I've also got a membership item in there. And let's say we have a way for members of a particular organization can edit the organization, right? Maybe they can change the plan or change certain things about the organization. So for that access pattern, edit organization, we want to make sure that membership item exists for that particular user. So, this is basically going to be a two-part operation where we allow that edit to the organization item so long as that editing user is a member of that organization, because we don't want anyone to be able to go and change that organization, only people that are members, right? To do this, we need to wrap that in a DynamoDB transaction. Now, DynamoDB transactions, love them, great feature, came out in 2018, simplify a ton of access patterns where you can do multiple operations in a single request where they're all dependent on one another, right? So if one operation fails, the rest of it fails and is rolled back as well. Super useful. A couple downsides of DynamoDB transactions would be they're slightly more costly than if you were to do those operations separately, number one. And also it could have contention issues, right? So when you have items that are involved in a transaction, they're sort of locked during the time of that transaction from other operations. So if you have a very high contention operation, or excuse me, an item, high contention item, you might not want to use it in a transaction because it's going to sort of lock it up for processing there. So while we're handling this pattern, hey, maybe we have a high contention item or we just want to save some money, we might think of some other ways to do it right. And we still have our two different items here, our organization, our membership item. But I want to call out this members attribute, which I've added to my organization. And what this is a denormalization, right? We've duplicated some data from this particular organization item onto that organization, or excuse me, from that membership item onto that organization item. We're just storing a set of members for this particular organization, right? And the nice thing about that is now when I have that edit organization operation, I can say, hey, allow this edit to happen to the organization item if the editing user is in the members attribute, right? So now I can do this as a condition expression without a transaction. It's not working across multiple different items. It's only working on a single item. It saves me cost. It gives me higher throughput. I don't have to worry about those contention issues there. And because of that, I'm thinking that up front. Now I know, hey, I'm going to need to duplicate some data whenever I'm adding a user, adding that membership item, right? I also need to sort of duplicate that up onto that organization item. Or when I'm removing a user from an organization, I need to remove it from that members array as well. So I think that's why you want to think about those write patterns early on. Again, just identifying dependencies between items, which can really speed up processing there. The place I see that come up the most is with transactions and duplications, but it come up even optimizing some read-based flows and different things like that. All right, so you've done your critical patterns, optimize for those. You've done all your write patterns. That's where you can usually layer in your read patterns. And I always leave read patterns to the end because they're super easy to add at the end using GSIs, right? So we talked about GSIs. What they give you is additional read patterns on that same data. And if you've planned out the rest of your table, you can usually layer those in pretty easily. So let's look at our read-based access patterns here. We've got 6 different patterns. If you actually look at those closer, right, the first 4 patterns, they're just different views on the event item, right? Might want to get an event by its ID or get an event with by its organization, get an event by city, by facility, different things like that, right? So it's the same underlying event data. I'm just indexing it in different ways. If you look at those bottom 2 access patterns, those are just different views on membership items, right? I might want to see all the memberships for a particular user and all the memberships for a particular organization, right? So again, same data, just indexed in different ways. And the great thing about this is it's super easy to just go through and add some secondary indexes. You see this target here, some of my operations are happening against the main table, but when the main table is used up for something, then I rely on those secondary indexes. So I can add in those secondary indexes super easily after the fact. That can work. Once you've done your critical patterns, once you've done those write patterns, add your GSIs to get those additional read patterns. All right. So I hope that gave you a sense of how to think about some of that stuff. Last thing I want to close out with here is what I call doing the math and thinking about, optimizations or choosing between different things. Dynamo allows you to do the math in certain use cases, right? So a couple things to remember here about DynamoDB. You're going to be billed by that data read and written directly, as we talked about before. And because of that, you can do the math and figure out different access patterns, figure out how a new access pattern is going to cost you, different things like that. Just talking about DynamoDB billing real quick, right? We talked about write capacity units. If we get more specific with that, basically a write capacity unit allows you to write up to 1 kilobyte of data to DynamoDB. That's going to be rounded up. So if you write half a kilobyte of data, they're going to round that up to 1, charge you 1 write capacity unit. If you write 9.5 kilobytes of data, they're going to round that up to 10, charge you 10 write capacity units, right? Now, the important thing here is this applies to your main table and to any GSIs that were written to, right? So you're going to get charged for write capacity units for all those. So let's see how that plays out in practice. Imagine I have my main table in DynamoDB and I have this update event operation, right? Sometimes people want to update the event. Maybe they sold a ticket and we just have remaining tickets left, or maybe we want to change the description or different things like that. So we have this update event operation. If I go look at my DynamoDB items table, remember that I wrote that item size in there before. It's about 12 kilobytes for a particular event item is what I'm budgeting. So whenever I do an update event operation, it's going to cost us 12 WCUs. But if you also remember, we just talked about our read access patterns, right? We're indexing those event items in 3 other ways, right? So we have our main table, but we also have our 3 GSIs here. So now our event is not just in our main table, but it's in these 3 GSIs, GSI1, GSI2, GSI3. These are different secondary indexes where we're re-indexing that data. And now when I update that event in my main table, it not just only updates it there, but it asynchronously updates in all these separate secondary indexes, right? And each one of those is going to cost 12 WCUs. So now that update event operation is going to cost me 48 WCUs per event update. Which seems like a lot. Once we were talking about 1 or 2 or 12 WCUs, now it's up to 48, but that's still not going to break the bank for you, right? That's going to cost you, If you're using on-demand capacity, that's going to cost you 6/1000ths of a cent for every update operation. So that's not going to be a whole lot. That's not going to break your bank there. It's going to be even cheaper if you're using provision capacity. And it's especially not going to cost us very much because, you know, the write frequency on events are rare, right? You know, every time we sell a ticket, we need to update that event. Every time someone changes the description, we update an event, but we're talking maybe 5-10 times a day, not happening a lot here. But let's change our requirements a little bit. Maybe we want to show some analytics, right? We want to be able to show our users the number of page views for each event. We can show this in the admin panel for them, and we can say, hey, how popular is your event? How well are you converting that to actual ticket sales? So if we look at our data here, we have our organizations and our events. I'm going to add this new page views properties, right? And it's going to be a map. And that map is just going to be a simple counter where we say, hey, this is a particular day. This is how many page views we got for that day, right? So you can see this top item here. On the 24th of February, I got 3,214 views. That's nice, but now, you know, every time we want to increment that page counter, that's a write operation to our event item, right? So now we need to go back to our table and say, hey, we're not updating this event item rarely. We're updating it often. Every single time there's a page view. This could happen thousands and 10,000 times a day for very popular events, right? That also means every time we record a page view, we're going to pay 48 WCUs for that, right? Just to reindex it in all these different places. And that might start to be more expensive than we actually want to do. Just recording, we don't want to pay that much just to record page views, right? So we can think about, hey, how could we actually split this up? Given that those page views are just going to be shown to administrators, right? They'll be shown in a different part of the console. We don't need them in these different GSIs, different things like that. So how could we do this well? Well, maybe we go back to our table and we'll split that data actually into two different items here, right? So we have our event items as we had them before. That has all our event data, including location, event name, date, description, things like that. And then we have a separate item. We'll call it event analytics items. And that's just keeping track of the page views there, right? And what we've done here is we've split these based on their actual needs, right? So we have this event item. They're 12 WCUs. They're rarely updated and they're replicated to 3 GSIs. So a lot bigger item, but they don't change very often. And even though we're replicating, you know, we don't have to replicate that often because they don't change that often. That's great. But we also have these event analytics items, right? These are changing all the time, but they're super small. They're less than a kilobyte because all we're doing is just a map of dates to page views. They're going to be frequently updated for each page view, but we're not replicating those out to any GSIs because we only need to show them in the admin panel and things like that. That's going to save us a ton of money on WCUs there. So if you do something like that, now you need to go back to that DynamoDB items chart we created at the beginning. You know, we had that event item. It's 12 kilobytes. It's written often. But let's just change that up, right? Now we added this new event analytics item. So this is a new type of item we're adding into our table and describing what that's like. Notice that our event item, we've split it into two. So the event has the event metadata, most of the stuff about the event, whereas the event analytics items just contain its event page views. Again, there's only one event analytics item per event, right? Because it's just tracking the page views for that event. You can see the different in item sizes, right? That event item is huge. It's 12 kilobytes. Event analytics is less than a kilobyte. And they have those vastly different write frequencies, right? That event is rarely updated. Event analytics is often updated. So again, this is just one example of sort of doing the math. Hey, where can I optimize these things? Because Dynamo is giving that cost to you directly, you can think about some of this stuff and get a sense of how you can optimize your latency, your cost, different things with DynamoDB, right? So that might be write amplification on GSIs, right? If you have a large item that's replicated a lot of times, maybe you want to reduce the number of updates to that item in some way. Could also be pagination with heavy filtering, right? If you need to fetch a lot of items and then discard those based on different attribute values, how can you slim that down so that you're not sort of overreading, paying a lot more RCUs? The last thing might be partition throughput limits, right? So we talked about those hard partition throughput limits that DynamoDB has. How can you sort, if that's going to be a problem for you, if you have some very hot items, how can you work around those? How can you do the math and figure out what you can support and whether that's acceptable for your application? All right, that's going to close us out. Made it through 230 slides here in 50 minutes somehow. So summary, just what we talked about today, you know, DynamoDB basics, vocabulary, key concepts, things like that. Then we walked through that data modeling process, and we started with that early part of the process, right? What are we doing to set up our design document so that we can actually go and design our table, right? We're describing our application, our entities, we're creating some initial charts to do that. And then we're actually going into that table design process and working through those patterns, you know, focusing on critical patterns first, then write patterns, then read patterns as we need to. Again, building out that design document, and then talked about doing the math and some of the factors you should consider and how you think about the math with Dynamo. If you want to look at other resources, you know, DynamoDB book, I talked about that earlier. DynamoDB guide, that's a free resource I have out there just to help you learn DynamoDB. You can also check out my blog, alexdebris.com. I mentioned before, you know, all those data models I did, those are NoSQL Workbench. That's a tool from AWS that you can use, free tool for you to help model that if you want to. Also, just check out the DynamoDB developer guide. And with that, I think we have a few minutes for questions. Hope you all have some. Hope you can make sense of that. Yeah, I'll take some questions if we have any.
That was a crazy amount of slides. Well done, sir.
Thank you.
So, yeah, no, you were channeling your inner Rick Houlihan because that's fast.
That's all I've learned from. Yep.
Yeah,
exactly.
there you go. So we did have a question, and it goes back to what you were talking earlier, but if you kind of take this out of context, how to find all events which has modeling in it. Right.
Yeah.
So it's kind of just how to isolate those events. We saw a reply about using regex, not clear, how to do that. So can you clarify on that?
Yeah, and I'd say that's a tough pattern for Dynamo, right? Dynamo is going to excel at certain patterns with known access patterns. You're saying, hey, fetch this item by these two parameters, or fetch this set of items by a particular parameter, right? The organization that's putting that on. But this is sort of a complex filtering or a search type access pattern where you're saying, hey, someone's going to give me some free-form text. I need to figure that out. That's probably not going to work well in DynamoDB unless you know you can sort of reduce the search space you're looking at, right? If you said, hey, find me all of Alex Debris items that have modeling in it, that's easy. Maybe I can fetch all those, and that's not that much. If you're saying find all the events across my entire application that have this specific word in it, that's going to be trickier, and you probably want to use some other type of data store, sort of supplement Dynamo, using Elasticsearch, OpenSearch, Algolia, different services out there for sort of supplementing that.
Okay. Another question we had is, and Jeremy Daly kind of talked about this, but see if you can expand on, is condition expressions versus update expressions.
Yep.
What's the difference? How do you use them?
Yep. So a condition expression is used on any write-based operation, inserts, updates, deletes, and basically it's evaluated before that write happens. And it says, only allow this write to go through if this condition is true. And if it's not true, then you can reject it. And that's how you can maintain constraints like uniqueness on that organization name or on a username, or making sure a member or an organization has fewer than 10 members, things like that. Whereas update expressions, you're also going to write those out sort of SQL-like statements for your updates, but they're basically saying, hey, if this write goes through, this is what I want to change. I want to increment this value by 1, or I want to add this person to an array, or I want to change this value to that. So that's what you're saying. You're saying, what am I changing about that item? Whereas the condition expression is saying, do I allow this write to go through at all?
Got it. That makes sense. All right, here's a question for you. If I'm building a direct integration, okay, and I want to and insert, let's say API gateway to DynamoDB, and I want to insert a new item and return that item to the client. What's the trick?
How do you get that? Well, I mean, the thing is, if you're inserting that item, that's going to, like, if you're doing an insert operation, a put item operation, you as the client, and I'm saying client as the direct integration there, you have all the data that you're sending up there. So you could just keep that. You don't need to tell DynamoDB to give you anything back because you know everything. It's just going to take whatever you sent it and put it in there. You just return that back as well.
And I actually get this question a lot. Here's the interesting thing about that. If you're doing direct API gateway to DynamoDB, you can't pass that data from the request to the response. It has to go through the integration and come back. So the trick is if you use an update item, it'll actually return. You can get the new one. So there you go. So that's something I learned. And I actually had that question out of band a little while ago. So I was bringing that up.
Yeah, you're okay. Oh, that makes sense. That makes sense.
That make sense?
You have different for the request. I forgot that you have different ones. I don't do a lot of direct integrations. You're the wizard of that. You and Richard Boyd are kind of the masters.
I've done it once. So yeah, I've become the wizard.
Yeah, that's enough.
No,
that's enough.
I do that a lot. But yeah, that's some of the you gotta work around those kinds of things. That's always fun. But all right, so we had another good question on modeling strategy. Is there a way about how to know how many partitions you will need to create while you're modeling, or some way to know if these partitions are correct? Are they
Yeah, that's a good question. And I talk about partitions a lot. I think it's helpful to understand how partitions are working under the scenes. But the thing is, like, as a DynamoDB user, you don't need to know how many partitions you have under the hood. That's like completely opaque to you. And Dynamo's doing like a lot of awesome work. This wasn't true 5 years ago, what I'm saying. 5 years ago, you might need to know how many partitions you have. With the adaptive capacity stuff that they've done, they're splitting up partitions either by size or by heat or just different things. And like, you really don't need to know that much about partitions. I think it's helpful to know about how many partitions you have, just because it gives you a mental, or not how many you have, but how they work, just because it gives you a mental model of like, oh, this is how Dynamo is working under the hood. And that's why primary keys are so important. That's why the partition key is important, why you can use the sort key to filter very efficiently, things like that.
Okay, great. All right, so I have another question. I think it was answered down through, but maybe expand a little bit. It says, when using update item, I'd like to create an attribute for the create on date. If it was an insert, what's the most efficient way to do this for an update item call?
So I'm pretty sure I need to double check this, but I'm pretty sure you can do an if not exists function in there. And you can basically say, like, set this value if not exists. If the value doesn't already exist, if this attribute doesn't already exist, then set it to this. And that's what that's saying is, if this is an insert, that item doesn't exist, it doesn't have that attribute, it's going to set that value. But if that item does exist, it's already going to have that value. It's going to ignore this part, and it'll do the rest of the update operation for you as well.
Yeah, I'm pretty sure that's what Jeremy Daly said, the same thing further down. So yeah, I think we have consensus on that. In fact, I'm going to go ahead and bring Jeremy in. Jeremy, get ready. I'm bringing you in here.
Yeah.
All right. So Jeremy
I'm
was
ready to go.
Is that what you said already too?
That's what I said.
Yeah.
Yes.
Yeah.
Yeah. Correct.
All right. So we are just about time to transfer. We're going from one hero to another. I do have a question, critical question. Who told you to say that about the code being better than Dr. Pepper? Was it Daly? It was,
no,
wasn't it?
It was not Daly. It was our friend Bryson.
Oh,
our friend Bryson in Minnesota.
Yeah.
Bad guy.
Yeah. He's bad apple right there. He's causing problems.
Yeah.
So, hey, Alex, a phenomenal session. So much great information. I didn't put them all up on screen, but a lot of great feedback. This is awesome. This is great. We're all friends here. That's also true. We'll put that up on screen. We are all friends here. So, all right, let's do one. Go ahead.
Oh, yeah, go ahead. I was just going to say, thanks for having me. Super excited to see Jeremy's talk. I'm sticking around for that. He's working on a course. Check out his course. Sign up for that. Like, this guy knows a lot of stuff. So stick around for sure.
And Alex, you're still in the chat, right? You're going to be hanging on the chat?
I will be in the chat. Absolutely.
Okay. We have a couple other questions that are coming in. So if you want to grab those, that'd be great. And then you can help answer questions in Jeremy.
Cool.
Jeremy. So there you go.
Absolutely.
All righty, Alex, thanks a lot.
Take a breath, Alex.
I'll try.
You took a breath for the last hour. So.
I'll take a breath. You break a leg. Good luck.
Get yourself a Dr. Pepper and expense it to DynamoDB. I'll take care of it for you. So
there you go. There you go.
See y'all.
See you, Alex. All right, Jeremy, do you have a screen you can share?
I didn't scream. Sorry about that.
There you go.
Let's see here. Share.
Jeremy's an old pro.
Share screen. Sorry about that.
But
here we go.
Earlier I came on and I was muted, so it was really a bad thing. So Jeremy today is going to be talking about the perfect data companions, serverless and Amazon DynamoDB. This is very near and dear to my heart, so I'm excited to see this. I do like to do serverless, if you didn't know that. So with that, I'm going to get out and I'm going to pass it off to you.
All right. Thank you, sir.
See you, buddy.
All right, so my name is Jeremy Daly. So we're going to talk about the perfect data companion for serverless, which it's all about DynamoDB today. So we are going to focus on DynamoDB because it is, in fact, I think, the perfect companion for it. So a couple of things we're going to talk about today. I'm going to try to keep it a little high level. I don't want to dig too deep into some of the specifics here, but we're going to talk a little bit about integrating DynamoDB into our serverless projects and the different serverless services that are available and how we would do that, and a little bit on the integration models and the security models around that. We're going to talk about scaling and concurrency and how that works with serverless and why that is a problem or that can create problems with traditional databases, and we'll look at some ways to solve that. We're also going to talk about some security best practices as well as maintaining data integrity. So this is something that's super important, especially if you have a lot of apps and a lot of things that are connecting to your DynamoDB tables. You want to make sure that that data is that you're maintaining that data integrity, and also that you're following security best practices. And then we're going to talk about something that I really love to talk about, which is application stack isolation and serverless development workflows. So this is near and dear to my heart, something I've been working on for a while now. So I love to see the ability for people to sort of take full advantage of the cloud and for them to run their applications, including all the different stages in the cloud. So we're going to get into that and discuss that a little bit more. So just quickly, some background on me. I'm currently the general manager of Serverless Cloud at Serverless Inc. It's a new application platform we're working on, all backed by AWS and all their serverless services, which is pretty fabulous. I also do a lot of consulting and work with companies in the cloud. I had been doing this for a very, very, very long time, so I've seen quite a bit with technology startups. I started working with AWS in 2009, about the time where it was just EC2s and some of that stuff back then. And then as soon as Lambda came out, GA in 2015, I immediately fell in love with serverless and just started doing things there. I have a blog, jeremydaily.com. I do some open source things, and I also publish a newsletter every week called Off by None that just focuses on things happening with serverless, the serverless industry, and a lot of stuff with AWS. And I am the co-host of the Serverless Chats podcast, where we have all kinds of great conversations about serverless, including Eric, who was just on a couple of episodes ago. So, and I'm also a Serverless Hero, which is just a fabulous program that AWS has for their community heroes and their data heroes and all that kind of stuff. Something definitely, if you're involved with the serverless community or the AWS community, something to look at becoming part of that program. Okay, so let's talk about integrating DynamoDB into our serverless products or projects. So first, just in case, and we'll just start with the basics. If you don't know what serverless is, essentially what serverless is it doesn't mean there's no servers, but essentially it eliminates server management. So we don't have to worry about running our own servers or EC2s or things like that. So it takes care of that for us with a couple different services that they have. It's very flexible scaling. So this is sort of scale to zero in most cases, and then almost scale infinitely. I think you heard some speakers earlier talking about, that basically DynamoDB is almost infinitely scalable, right? And there are a lot of other services that are very similar to that. We like to talk about pay for value because some services, depending on what mode you put them in, there is an ongoing cost, but a lot of them are just pay per use, which is super great, especially when we talk about how we do our serverless workflows and the application stack isolation. And then the other thing is automated high availability. I mean, one thing I think people don't always realize is that a Lambda function, maybe it costs a little bit more to run a Lambda function than it might if you were running an EC2 instance, but that Lambda function is available across multiple availability zones. All of the routing is done for you, all of that load balancing and so forth. So it's a built-in feature of it that is just absolutely amazing, and would cost a lot more time and mental effort and everything else just to get that set up, that same amount of high availability with these serverless services if you were to try to replicate this yourself with EC2s and even containers. So at AWS, there's a whole bunch of services. There's 200 plus services. But the primary serverless services that we have are kind of broken down, or that they have, I should say, are kind of broken down into three categories. And the first one is compute. And so we have AWS Lambda that is the function as a service that allows us to invoke these functions and run on demand whenever we need to do something. And then AWS Fargate, which is the containerized service that allows you to run serverless containers. And this has different scaling capabilities than Lambda and different provisioning capabilities. So Lambda will start up instantaneously. Fargate takes about 30 seconds, I think, in order to start that up, but then that would run continuously. And then we have application integration services. So EventBridge is sort of the corporate or the enterprise event bus that allows you to do choreography if you're passing events around your system and communicating with all these different services. AWS Step Functions is an amazing service that allows you to do orchestration. and all kinds of really cool things there. SQS is the queuing service, SNS is the pub sub service, API gateway is the API interface that allows you to do HTTP requests and forward those requests to a number of services, including AWS Lambda, and then AWS AppSync, which is the GraphQL service, the managed GraphQL service, which is also another quite amazing service. And then we have storage and databases. So Amazon S3 is a blob storage, hugely, 11 nines of availability. Amazon DynamoDB, which is we've talked about today, is an amazing service. And then Amazon RDS Proxy, we'll talk a little bit about that. And then Amazon Aurora Serverless, which is a serverless implementation of either MySQL or Postgres. So those are pretty good services there that you can use as well. All right, so what I want to do though is I want to go through a couple of these different compute models and the application integrations, or some of these application services that are available, and talk about how those would actually integrate with DynamoDB, and then what the security models are around those, because they are slightly different, but and some of them give you more fine-grained control versus some that are a little bit more less fine-grained controlled. So first one I want to start with is Lambda functions. And if you're not familiar with Lambda functions, they're functions as a service. They're an execution environment. They are absolutely amazing. They run on demand. They run in response to events. I can't even remember how many event triggers there are for this now, but everything from triggering off of Kinesis and API Gateway and Event Bridge and SNS and pretty much every other service you can think about integrates with Lambda functions. They really are sort of a workhorse for a lot of the application glue and some really cool things that you can build there. So this is like building in containers or building on an EC2 instance. So the integration model here is going to just use the SDK. And what this will do is this will allow you to go ahead and write pretty much anything you want to interface with DynamoDB using that really flexible low-level interface. So pretty much anything you want to do, anything you can write in code in terms of manipulating data structures and things like that, you can take advantage. We were just talking about condition expressions and update expressions and all that kind of stuff. All of that stuff you can do clearly within the SDK, and you can use that to integrate integrate DynamoDB there. The other thing that's really, really great about using a Lambda function is because we try to keep our Lambda functions very lightweight. We try to separate out, sort of focus each Lambda function on one piece of business logic. That means that every function needs its own IAM role. So the security model here basically allows us to give very fine-grained permissions per function. So this is great if you have something like, maybe you have a function that only needs to query data, or only needs to update data, or only needs to insert data. You can be very, very prescriptive about what features or what permissions each function gets, and this actually gives you a lot of control. This is a good way to minimize the security risks of opening up a function, for example. So this is just sort of a nice way to think about it, and a nice way to be really, really safe and secure with your application. So these are just two examples of code from either the serverless framework or the serverless application model. Very simple, right? I think you can read through these and probably understand them. These are both integrating with DynamoDB. Both of them, I just made them so they both have 17 lines of code. But essentially, cloud formation. So you define a table with DynamoDB like this, and this is how you connect to them. Just a matter of making sure that you have the right role, that they can actually access the data, and then just referencing them and being able to access them. So super simple, basically the same way you would integrate with DynamoDB if you were using any type of other type of execution environment. But the cool thing here is that you can get very, very fine-grained with your permissions, which is super great. And we'll talk about a little bit more later on. So another service that is heavily used, and we've heard Eric and a few other people talking about this today, is service integrations. So the service integration here, the integration model uses VTL. So if you're not familiar with Velocity template language, it is not the best. Not everybody loves Velocity, but it is quite powerful. It does allow you to do a lot of things. You can do loops, you can do conditionals, and there's a lot of things that you can do. So you have a lot of flexibility when a call is made directly into API Gateway, and then it proxies it into DynamoDB. And the great thing about this is, if you look at some of those, some of the earlier I think it was Oza that mentioned that model where it's, you call a Lambda function, or you call API gateway, calls a Lambda function, queries DynamoDB, brings that back to the Lambda function responds to API gateway, responds back to the client. That's fine. It works super fast. It's, that's a majority of the applications I build will use that pattern. But because it's proxying directly to DynamoDB, the latency is a little bit lower. So you don't have to worry about that Lambda function actually needing to run some sort of process. And of course, as Eric always talks about, you're introducing more code there where you could make a mistake, right? Where if you go with that direct proxy model or that direct integration, you're getting rid of a lot of that custom code that could cause some problems. Now, the security model around this is actually pretty good as well, because you can create a separate IAM permission on every single route. So every route that runs, you can actually define what that DynamoDB table, what that route has access to on DynamoDB. And you can actually integrate this with API gateways access controls, which can use IAM, Lambda authorizers, you can use OAuth, you can use JSON web tokens. There's a whole bunch of things that you can use to do that authorization. And then you can actually match that up, saying which routes a particular user has access to, and then each one of those routes can be locked down in terms of what it can do within DynamoDB. So a pretty good security model around that, a lot of flexibility. And again, with VTL, as long as you're not afraid of it, you can do some pretty interesting things to, sort of manipulate those, manipulate the data going in and format that data going in, and sort of sanitize and clean up the data that's coming from, that direct integration. So this is just an example. I know Eric said that it's kind of, it's not for the faint of heart. Once you get through it initially, it's actually not too bad. This is just a simple integration. It's a post integration. You say you want an AWS service. You give it the execution role. You tell it which action you want it to do, and then over on the right-hand side, you see that the mapping template. And essentially, what that mapping template is just saying take these these three values from the input path and put them in here. Now, again, you can use VTL in here, and you can get a lot more fancy with that and do some other things. But for the most part, it's fairly straightforward. And depending on what you're doing, especially if it's like a webhook and you're capturing some data, things like that, this makes for a great way to do it, because then you can just cut out the Lambda function entirely. And you can always sort of sanitize the data and put some security checks in there to make sure that things are being handled correctly. So let's move on to AppSync. So AppSync is GraphQL. So if you want to use GraphQL, there's a number of different databases and connections you can connect to with AppSync. One of those is Lambda functions. So if you wanted to, you could have a Lambda resolver that actually connects to Lambda, and then Lambda can call DynamoDB. Unfortunately, I don't say unfortunately, but there's a little bit of a delay there, right? So you do have some latency that you add in when you use a Lambda function. So it is much easier, or much more efficient, I should say, to connect with a DynamoDB resolver. So the integration model here is very similar to the API gateway. You can use VTL, so you can do a lot of that transformation work. It's a little bit different in terms of how that's structured, but for the most part, it gives you a fair amount of flexibility in terms of what you can do with that. And same with as with API gateway, you have a much lower latency because you're proxying directly into DynamoDB. Now, one of the disadvantages of using DynamoDB resolvers is that right now resolvers only have you can only have IAM permissions set at the data source level. So for example, if you have a DynamoDB resolver that has mutations as well as other queries and things like that, then you need to open up the permissions so that the entire data source can handle all those different things. So you lose a little bit of security there, but again, as long as you're very conscious about what it has to do, you can go ahead and limit those individual those permissions at the data source level, and make sure that you're protecting your data pretty well. And then AppSync has a whole bunch of authorization strategies, so you can use API keys, IAM, Cognito, Lambda, you name it. There's a whole bunch of things you can integrate there. So even at that top level, you're not just giving full access. So if you say, oh, well, allowing this GraphQL query or this mutation to update or delete data, you can protect those operations based off of the authorization strategy used for people to connect to AppSync. Now, the other cool thing about AppSync, though, is there is this import DynamoDB table wizard that you can go ahead and just run this, connect to your DynamoDB table, and then what this actually does is it will auto-generate a whole bunch of schemas. So you'll have all of your mutations and some of those queries already generated for you, and then you can just go in and kind of clean them up and make them do what you want. But very cool feature, and again, it's sort of the only, notice it's the only database that's called out specifically, so kind of cool. All right, so let's move on to step functions. So step functions, again, orchestration, they're state machines that give you all kinds of power, crazy stuff. The integration model here, there's two. One is optimized, and the other is this new AWS SDK integration. Optimized was before, it was sort of a single item. You could only kind of sort of get items or put items. With the AWS SDK integration, you're fully open to be able to query and all kinds of things. And the cool thing that the SDK integration added was the wait for task token support to the DynamoDB integration. So before, everything had to be synchronous, and essentially you would have to wait for DynamoDB to respond, and then that would move on to the next task in your step function. But with this now, you can actually go ahead and say, let's say you want to do a put operation or something like that on DynamoDB. You can have that do the wait for task token, and then essentially like read off the stream with a Lambda function or something like that, and then trigger back the step function to kick off again. So a little bit more flexibility now with the SDK integration, and again, it's just step functions are super cool. So definitely take a look at those as a way to do it. Now, unlike some of the other ones we talked about, the integration or the ability for you to manipulate the data that goes into these calls is a little bit more limited. So it uses Amazon States language, which has a concept of paths, which is very similar to JSON path, if you're familiar with that. So you don't have that VTL, you don't really have that imperative, be able to manipulate things that way. You certainly can restructure data, and you can have those paths in there, so you can change the format of the data and things like that. But you're a little bit more limited when it comes to actually making decisions or sanitizing or something like that. Now, you certainly could just pass that into a Lambda function or put it directly into the database and then do some processing on a Lambda function off of the stream. So there are ways to do that, but it's certainly not as robust as you can with a Lambda function if you were manipulating it directly, or if you're using VTL. But still, super powerful. And now with the wait for task token, you can do both synchronous and asynchronous workflows here. And the great thing about step functions is, DynamoDB has a whole bunch of cool things built in, like transactions, for example. But if you want to orchestrate multiple, queries or multiple inserts, or make sure that one service updates correctly and the other service updates correctly, this is something that AWS Step Functions is just perfect for. And not only that, but it has all these retries built in. So if it tries to do it, you can have it retry a couple of times before you just say, oh, this is dead. Whereas if you did a transaction, as soon as that transaction fails, the whole thing fails. So this gives you a little bit more control over that. It can handle all those failure states, and if you're familiar with Saga patterns, this is a really great way that if you do have multiple steps, multiple steps in a transaction that you're trying to follow, you can actually go back and unroll all those, and again, have all the retries you need to say, this is going to keep retrying until it goes ahead and marks this, back to its previous state or whatever. So you do have a lot of control with it, which is very, very cool. In terms of the security model, you're limited to one role per state machine. So depending on how many state machines you build and depending on what it is that state machine needs to do, this is still a pretty good security model here, because you can limit that DynamoDB connection, or the permissions that DynamoDB gets. You can limit that to whatever that one particular function needs to do, or that state machine needs to do. And of course, depending on how complex your application is, you might have hundreds of state machines depending on the different workflows in your organization. So this is the DynamoDB. This is the AWS Step Functions Workflow Studio, which is relatively new, super easy to use. It's honestly one of the best developer experiences that I've ever seen from AWS. It's so good. You go in here, it's drag and drop. You get the ability to just go ahead and manipulate your parameters over there. Again, it uses Amazon States language, so you do have to use the JSON paths. But again, you have a lot of control here, and it's super great to see this visually and see how the data flows through there. Okay, so let's move on to serverless and concurrency, let's check the time here. So serverless and concurrency. So one thing that we do need to understand with using Lambda. Now, all the different services I talked about, API Gateway and AppSync and so forth, they have different models for this. But the big thing to think about with Lambda is if we are running functions as a service and we're connecting directly to DynamoDB, it's important to understand how concurrency works. So with Lambda, you actually have one container per concurrent invocation. So this is much different than you would get with EC2 or you would get with using containers or something like that. So every connection from the outside world gets routed to one container, and that container is the only connection that is accepted by that container. And the reason for this, though, is actually pretty compelling because theoretically every single invocation should have the same resource allocation as well as the same performance characteristics. So if you notice an application that maybe has 100 connections or 100 concurrent connections, you start to see degradation in the performance as more and more users start using, say, a virtual machine or a container or so forth. And usually you scale out and it's not that big of a deal, but with this you don't have to worry about that because every single invocation has the same resources and their own resources and the same performance characteristics. The execution environments are all reused. So if people have heard of the term cold starts, it's essentially when a new container has to spin up. That means that there's not a container available for a new incoming connection. But those connections, once that connection drops and that container becomes free again, that stays warm for a period of time. So as new connections come in, it can do that. And then if we're trying to actually limit concurrency, which is something that is not always easy to do when you're dealing with EC2 or some of these other things, is the functions themselves have independent concurrency settings. So you can say that this particular function can only have 50 concurrent users, and this function can have 2,000 or whatever it is. So it gives you a lot of fine-grained control over how many users can connect to this, which is usually helpful when you think about how well Lambda scales versus maybe how well other downstream services like an API, a third-party API might scale. So having the ability to limit that concurrency is a pretty good feature that's built in here. Now, this does have an impact, though, if you're using a traditional database like a relational database management system or anything that is connection-based, because each container actually requires a separate connection. So there's no database pooling. You certainly can do pooling in Lambda functions. I've seen a lot of people that I've consulted with. They're like, oh, we're using connection pooling. Well, yeah, you're basically taking up 5 or 10 or whatever your connection pool is. You're taking up all those connections for just a single Lambda function, which in most cases doesn't make sense. Now, the nice thing is that as that Lambda function releases connections to the outside world or whatever the service is that's calling it, then it will actually freeze the connection and it will reuse it, which is great. But the problem is that as you get higher concurrency, you need more and more connections, and of course that's going to affect the CPU on the database server or whatever it is that you're connecting to. So it's efficient the way that it does it, but if you have 1,000 concurrent connections, you're going to have 1,000. You're going to need at least 1,000 connections to the database, and then you always deal with zombie connections and things like that. So there's a service called Aurora Serverless, which I mentioned earlier. This definitely helps with scaling, but it doesn't help with the connection limits, right? So even though you put Aurora Serverless behind there, it'll scale, and it will scale pretty big, but the problem is that you're still limited by the number of connections. So how do we solve this particular problem? Well, the first step is with Amazon RDS Proxy. This is a service that essentially allows it to hold idle connections. So you could have thousands and thousands of Lambda functions connecting to the proxy, and then this will go ahead and maintain a connection pool to your database for you. This works really, really well. It lets you scale to a whole bunch of connections. So if you're absolutely dead set on using relational databases, Amazon RDS Proxy is a really, really good solution that'll help you solve this scaling problem and this connection problem. But we're talking about Amazon DynamoDB today. So what's great about Amazon DynamoDB is it uses an HTTP-based connection model, which means there are no long-lived connections. You can use HTTP keep alive to keep the connections open, which is sort of saves you that little startup blip there. But for the most part, you don't have to worry about how many of those connections you can keep open, because it's not actually connected to a back-end service, and that other service doesn't have to maintain those connections. So you can make fresh calls whenever you want to, as many as you want to, and that will not affect the scaling, and won't have any impact on DynamoDB, because it is auto-scaling. So you could just start sending a ton of traffic through it. You have thousands of Lambdas that are spun up. They're all making connections to it. DynamoDB is going to go ahead and scale and handle that traffic without a problem. I know we talked a little bit today about DynamoDB capacity modes, but just to review this quickly, both the provisioned and the on-demand capacity capabilities are great. So if you have reliable, consistent traffic, provisioned is a great way to do that. There's some burst mode that's built in there, so you don't have to worry that if the traffic gets a little bit higher, that you're going to drop things. But on-demand capacity is great because that'll literally scale down to 0, which means you can set up as many DynamoDB tables as you want to, and it won't cost you anything until they're actually used. And we'll talk about this a little bit later, but that's why there's such a great sort of component when you're dealing with the workflows where you want to be able to spin up multiple application stacks. So just a couple of things here. Default service quotas, 40,000 read requests, 40,000 write request units per second. And these are default. So you can have them scale this up if you for some reason are getting more than 40,000 read requests per second. I mean, this is high traffic, and this is just out of the box, and this can keep going and going and going. And this is why DynamoDB is such a perfect sort of companion for these high throughput serverless applications. If you look at a lot of these applications that have to call out to another API, or even have to talk to a RDS cluster or something like that, the scaling characteristics of those services are no match for what the scaling characteristics are of DynamoDB, and that'll just keep going. You can keep throwing more and more work at these things or at this, and it just is amazing. Okay, so let's move on to security best practices and maintaining data integrity. I'll start with this quote from Jerome Salzer. Essentially, every program and every privileged user of the system should operate using the least amount of privilege necessary to complete the job. This is known as the principle of least privilege. And this is super important. And the reason why is because we want to make sure that we're not over-provisioning or over-privileging our DynamoDB tables for any of these services that are interacting with them. And certainly, I think we know about star permissions and stuff like that, but let's talk a little bit more about this. So functions and integrations should only be allowed to do exactly what they need to do. Anything more than that, essentially, if that IAM role for some reason gets reused somewhere, or somebody was to compromise a third-party, NPM package or something like that, or another package in one of your Lambda functions, and they were able to do something beyond what your function originally intended it to do, then giving them more permissions is going to allow them to do that. So we want to limit that. So if anybody has spent any time with IAM, you'll know that it is very, very powerful. But in some cases, learning all the details of it probably require a PhD. I'm kidding there. There are some amazing people at AWS who know this very, very well. But even if you do know it well, it is very, very easy to over-privilege this. And we have to be honest, the biggest reason for this is a human factor, right? Just people are lazy about it, or they don't quite understand what they're doing when they use like a star permission, for example. And what we typically see with the customers that we work with at Serverless Inc., as well as other customers that I've worked with, is that overprivileged issues are the most common mistake that they make. So if you look over here on the right, I have a very simple role statement that says, hey, let's give DynamoDB.star permission to everything in US East. So this is essentially saying I can do anything I want to any table in US East in my account. And that DynamoDB.star, we're not just talking about connecting to it to say maybe get an item or update an item or delete an item. You're giving it all of these permissions. So not only are you saying they can create a new table, they could delete an existing table. They could manipulate streams. There's all kinds of things that they could do. So you do want to be careful about using that star permission. And it is really a good idea to just kind of go through and figure out what the right permissions are. And the errors for this are pretty good. So if you were to try to do something, we'll come back and say you don't have permission to do query table or query delete item or whatever that is on this particular table, and then you can use that to go through and make sure you add the proper permissions in. So the way that we would limit these IAM permissions is, especially with the Lambda functions, we use a role per function model. SAM, the serverless application model, has these things called policy templates, which are pretty cool. You just say DynamoDB cred policy, for example, reference your table, and that will make sure it just gives you the right permissions. And there's a whole bunch of these, and you can find these in the documentation. If you use something like the serverless framework, there's custom roles per function that you can do, or there's a cool thing called the serverless IAM roles per function plugin that makes it super easy for you just to go ahead and use that and specify specific actions that you can do there. And the whole point of this is just to minimize the blast radius. We want to make sure, again, anything gets compromised. We don't want our data or our tables, something to get messed up that we don't want it to get messed up. All right, so maintaining data integrity, I'll go quickly through this. This is a long discussion, but a lot of people have said today DynamoDB is schemaless, right? Which is great, gives you a whole bunch of flexibility, but that also means that you are responsible for managing the integrity of your data. I built a thing called DynamoDB Toolbox that sort of maintains entities and that structure of the data itself. This is something that, for the most part, you have to enforce these data structures and schemas on your own. And again, it takes a little bit of forethought and some ideas of, and some planning on how you would do that. And then the other thing that's really big is that, DynamoDB doesn't store metadata. So it doesn't store internal metadata that's available to you. So you don't know when an item is created. You don't know when an item is updated. You don't know maybe when an item was marked deleted unless you specifically put that information into the item itself. And as you're doing that, as you're going through that process, you want to make sure that that doesn't get overwritten. We were just talking about if not exists at the update level. That's one of the great ways that you can use to make sure that if you're using update item, if the item already exists, you don't want to overwrite that item, or you don't want to overwrite the value of that item. I have a blog post on this called Ensuring Data Integrity with DynamoDB. Goes into a little bit more detail about that. Okay, so there are a couple of different strategies I'll just talk about quickly. I'm just going to give you two, but there's more in that blog post. So you can use IAM in general just to disable actions on your data. So the first thing I like to think about, or I like to think about these as service level protections, because they're at a much higher level. So this is where you would omit, or you could deny certain permissions based on an IAM policy. So here we see that we're only giving access to put item and update item, not giving access to delete item, for example. So this is something that you could use to say, okay, well, I want people to be able to put an update, but I don't want them to be able to delete something. And this is a good way to limit certain destructive actions. Again, you have to create multiple roles depending on what each individual service or integration is doing. But again, it's worth it because you have that extra layer of security that is super helpful. The other thing you can do is you can actually disable specific attributes. So there are a lot of fine-grained access controls that IAM supports. Again, something you have to dig into the documentation to learn more about. But in this specific example here, what we're doing is we're saying you can update an item, but you can't update it if one of the attributes you're trying to update is created or looks like it matches created. So essentially, this gives you some really good controls where you can say, I'll give you the update item capability, but I'm not going to let you manipulate that created date. I want to keep the integrity of that date. I want to keep that. I want to keep that the same. I don't want somebody updating that. Now, there are some really cool things you could do with DynamoDB Update. You can do upsearch, right? So you can insert an item if the item doesn't exist, provide defaults with that if not exists. There's a whole bunch of cool things you can do. You get a little limited with that when you start putting in these specific attribute sort of conditions. But again, it's still a good way to do it. And where I find this type of stuff works great is if you are doing those API integrations and things like that. So this helps you minimize a lot of that VTL logic that you need to use. You don't always have to check things to make sure that something exists or something is not getting overwritten or something like that. So super helpful to use that in those situations. All right, and then finally, just a few more minutes, I want to talk about application stack isolation and some development workflows. So if we think about our development practices, the hygiene of our AWS accounts, and how we manage all that stuff, as we get to be larger organizations, we get more team members, things become a little bit, things don't always evolve as cleanly as we'd like to. And I think that most of us will fall into this category of what I sort of call the less than ideal stack isolation model. Now, hopefully we've all gotten the message and we've all adopted this idea that every stage of our application, so our production stage, maybe our QA test stage, maybe we have a separate development stage, that all of those are in their own AWS account. They all have their own dedicated resources. We're very smart about who we allow to access the production accounts and things like that, and we've got audit trail turned on and all that fun stuff. But typically we see in most companies that developers are sharing a single account as their sandbox. And that means that they're typically utilizing shared resources like RDS, OpenSearch, whatever the other services are that they're using. So all as part of the development process, they're all hitting up against the same resources. Now, again, it's low usage usually, so it's not like that's too big of a deal, but there is some resource contention there, and then sometimes somebody overwrites something that somebody else was using, and it gets confusing. And then the other thing is that most pull requests, so if you're using Git or hopefully you're using some sort of a code repository, that when you make these pull requests, you're not deploying these you're not deploying them automatically. You don't have an individual stack that shows you what this pull request looks like. Instead, you have to actually merge those and get those deployed into some sort of a shared dev or QA stage in order to do sort of full end-to-end testing or to maybe have some people look at it. So to me, this is sort of where I think a lot of people fall, but it's less than ideal. And again, it's hard because you're using things like RDS or OpenSearch, and you're using some of these, these provisioned resources. So if you look at what I would maybe call the ideal stack isolation model, is that every app and stage, of course, would have its own AWS account with dedicated resources, but also every developer would get their own AWS account to avoid resource contention. Every PR, every feature branch has its own stack and resources, so each one of those can be tested independently. You'd be able to do repeatable deployments all through CloudFormation or the framework of your choice. This would be ideal, but for most people who are using or developing that aren't using all the serverless services, and you're doing something like RDS or EC2 or even EKS or any of these other services that are provisioned, it becomes a little bit inefficient and it can become expensive. You've got 100 developers, every single one gets their own AWS account, and you're not going to provision an RDS cluster for every single developer, and if you were, that's hugely inefficient. And we just talked about at reInvent this year being able to have the sustainability pillar, right? So having an RDS instance that's running 24 hours a day, or hundreds of them running 24 hours a day for developers that are only using them every once in a while doesn't make a lot of sense. So if you're willing to, and you can get yourself into a serverless mindset, and you can adopt the serverless application stack model, then essentially you get this out of the box, every app stage with its own account, dedicated resource. That's pretty easy to do. You get the devs to have their own AWS accounts, and so they can avoid that resource contention. Every PR feature branch has its own stack, repeatable deployments with the framework of your choice. And the reason why this is efficient and possible to do is because most of those serverless resources are in fact pay per use. So Lambda, API Gateway, DynamoDB, EventBridge, Step Functions, SQS, they cost you nothing if those are not being utilized. They don't take up all that extra energy, and you're not wasting all that money and having all that confusion of trying to figure out, do I need to shut down these RDS clusters and all that kind of stuff. So it does allow you to have this low to no cost application stacks that you can spin up and tear down very easily. And to spin up a DynamoDB table or Lambda or API Gateway just takes a few minutes, as opposed to trying to spin up an entire RDS cluster and shut that down and the whole deal. So super efficient way to do it. I love this model. This is the model we're trying to kind of force on everybody, I guess. We're trying to certainly get more people to do this, and it is, if possible, if you can utilize these services, it is quite amazing. So just a couple of quick takeaways here. Multiple ways to integrate DynamoDB into your serverless applications. Again, different integration models, different security models that you need to be aware of, but a lot of flexibility and super great database to use on that back end. And as Alex showed you with the modeling, a lot of interesting things you can do with with relational data as well. So it's not like you have to always have that relational database to lean on. The high scalability in the connection model makes it an excellent choice for high throughput serverless applications. You get a lot of fine-grained security and data integrity controls to protect your data. So one thing I didn't mention is, if you're on an EC2 instance and you have to do all these different things, or even in containers, you have to do all these different things in your DynamoDB table. You just need to give it permission to do all those things, right? So that means that, any type of compromise to any of those systems means you give them a lot of control into DynamoDB. Whereas with serverless and with something like Lambda or even step functions or any of those things, you can limit that, and you can really be specific about what you give them access to do that just really boosts your security profile. And then finally, using pay-per-use serverless resources really gives you that efficient and cost-effective way to create these isolated application stacks and deployment workflows. So just a couple additional resources. The AWS Serverless Advocates have serverlessland.com, which is absolutely amazing. Patterns there, all kinds of great stuff. Feel free to check out my newsletter, subscribe to that, offbynone.io. The podcast, DynamoDB Toolbox, is that open source project I told you about that helps you manage entities with single table design. I'm working on my DynamoDB modeling course, which will hopefully be out soon, and I publish all kinds of stuff at my blog, jeremydaily.com. So thank you very much.
Wow. Talking fast. That was some good stuff, man, as always. Jeremy, I always appreciate excuse me, what you bring. And there's lots of discussion going on what you were talking about. Covered a lot, and I appreciate it. Anything you want to throw out before we head out?
No, I mean, you
just threw out a lot.
I just threw out a lot. Yeah.
Yeah.
I hope I didn't go too fast, but
no, you didn't. It was great. Yeah, no, it was great. We had we have a couple things going on. Huge fan of the Dev One stack model that you were talking about. Getting a lot conversations on great information. So,
awesome.
And then they've been answering a lot of questions. So, as always, appreciate you and thank you, sir.
Well, I appreciate you having me here today, and this is awesome. And go DynamoDB.
Right on. Thank you. All right. So the next thing we're going to be jumping into an office hours. You're going to start seeing folks pop in around me here, and then we're going to do some introductions. So let's get everybody in here. All right. There's a lot of us. Every person on here is smarter than I am. So just so you know, we'll be covering a lot of information here. So let me make this a little bigger if I can. It doesn't look like, there we go. All right, let's see if that works. So what I'm going to ask you to do is real quick. I'm going to say your first name and give a quick introduction of who you're here or who you are and why are you here. So Pete, I'm going to start with you.
Hey everybody, Pete Naylor. I'm a product manager on the DynamoDB team. I was a specialist SA for DynamoDB before this role. I'm kind of a big fan of the service because I got to work with a lot of our internal Amazon teams in some of their migrations to DynamoDB, and just love getting to see the difference that it made for them.
All right. Somu.
Hey, everybody. My name is Somu, and I am an engineer in DynamoDB team. I've been with DynamoDB for about 11 years now, since its launch.
Wow. All right, very cool. Jessel, tell us about you.
Hi, I'm Jessel, Senior Principal Engineer at AWS. I've been at AWS for a really long time, worked on S3 for a while, and for the last few years, I don't remember how long, I've been working with DynamoDB.
All right. Joe, we've seen you already.
Yeah, I just
You're back though.
Joe.
Okay.
No, nobody wants to see this guy again. No,
it's just Joe.
It's just me. I get to work with all these fine folks every day. I work on the product team here and looking forward to everybody's questions.
All right. Chad, you're back with us. Welcome back.
I can hear you now. Yeah.
All right. Great. The world is a
Nice
sadder
to be back.
place when you can't hear Eric Johnson. So, I'm glad you can hear
100%.
me.
100%.
All righty. All right. Akshat.
Hey, I'm a principal engineer with the DynamoDB team, and I also have been with DynamoDB for about 10 years. Before DynamoDB, I was part of the SimpleDB team. So yeah, it's been a lot of NoSQL databases.
You've been DB for a long time. That's awesome. All right, Eden.
Hey everyone, this is Eden Zulich. I'm on the solutions architecture team for DynamoDB.
Excellent. Thank you. And Rashmi.
Hi, this is Rashmi here. I've been with Amazon for 12 years now and working with DynamoDB as a principal engineer from 5 years now.
All right. Perfect. And finally, not last but not least, Amrith.
Hi, everyone. My name is Amrith. I've been with the DynamoDB team almost 2 years now, and been working with databases for, I don't know, about 2 decades now. So,
all right.
About me.
So here's how we're going to do this. Throughout the day, we have had a lot of questions come in. So I'm going to take these questions and I'm going to try to disperse them. It's okay if someone goes, hey, I'd be the better person to answer that, or hey, I'm not the person to answer that. So feel free. This is very casual and comfortable, so I'm going to kind of distribute them out probably in the same order that I've gone in. But I'm grabbing these. We've got, like I said, we've had a lot come in. But if you're watching this now, that doesn't mean you can't add more questions. If you have a question about DynamoDB or, who does my hair or anything, throw the question in and we'll answer the questions. So we'll start going through those. So the first question we have, I'm just going to throw this. Why DynamoDB versus Cassandra or MongoDB? And anybody want to jump on that?
I'll break the ice.
All right.
I'll start. How about that? Yeah. Why not DynamoDB? It's serverless, right? And it scales, and it's very, very reliable, highly available. So how about that for a start?
All right. I like it. Anybody else want to add to that? All right. So we have another question coming in that says, what is the replication lag for global tables? And is there one, and what's causing it, and what work is being done on this?
Amrith, I'm gonna throw this one to you.
Okay, I'll jump in. So,
Okay, I'm not. That sounds like Jasso. Go ahead, Jasso. Go ahead.
Jess, are you taking this one?
okay, so the lag is actually pretty small most of the time, right? The reality is we are using streams under the covers to drive the global tables, and so there's a small a small delay in streams. And if you've ever written code against streams, you know that you pull the streams interface. You send a request, say, hey, give me records out of the stream. And, if there's records there to be read, we'll replicate them immediately. But we don't, if there are no records, we sleep for a little while, and then we wake up and we grab those records. So that can actually cause a bit of a delay on it. And that's really kind of the main delay that we have is the time that we wait for new records to appear in the stream. So, this is not done synchronously. It's all done asynchronously from the streams. And that's essentially why we have the lag.
I'll add a little bit to that, Eric. It also depends a little bit on where your global table copies are being stored. It's one thing if your global table copies are in US East 1 and US East 2. It's another thing if they're in US East 1 and, say, in Singapore. The delta is related primarily to what the speed of light is. For the vast majority of times, it's like Jasso said, the delay is going to be almost imperceptible. Once in a very short while, you might notice a slightly longer delay and in your applications. And in general, it's a very small amount of time. So it's eventually consistent, very short time, pretty close to what you can expect variations from speed of light.
Okay. I want you all to notice that when he said speed of light earlier, I nodded my head like I knew what he was talking about, although I didn't have a clue. That's how you look like you know what you're talking about right there. There's the, because I was like, okay, yes, I have no idea. But now I do. That was great. Thank you, Emrith. I appreciate that, Jasso and Emrith. Really helpful. So, Jasso, that almost sounded to me, and this could be really oversimplifying it, but it almost sounded like a cold start. Is that a fair statement? Or is that way too simplified?
Almost sounds like, I'm sorry?
It's a cold start. Amrith's shaking his head at me already. So it's not the same idea. Okay.
I don't know.
Okay, all righty. I think we're breaking up a little bit. All right, so we're going to jump in here. Okay, so is there anything similar to database migration, also known as schema migration, for DynamoDB, or there's some good practices to keep in the changes?
So I'll take that. I think the question is asking about database migration service, DMS. And DynamoDB is actually supported as a target for DMS. It's not always a great fit for migrations. One of the reasons being that oftentimes when people are moving, say, from a relational database to DynamoDB, if you really want to get all of the advantages of DynamoDB, you're going to completely restructure the way that you store that data. And DMS can only do so many kinds of transform. For example, if DMS is going to read one record, it's going to want to write one record in DynamoDB. Whereas if we wanted to use item collections and kind of break that single record up into multiple pieces, then that's not really going to be all that helpful. So there are use cases for DMS and DynamoDB. I would say majority of the time the migrating data is and the access patterns that we want to support make it not necessarily the best fit.
So follow-up question on that.
I'll add on to that if I can.
Yeah. Okay, go ahead.
Yeah. Well, so DMS originally, if you think about why it was created in the first place, it was really created to handle like-to-like migration. So you have an Oracle instance running on premises and you want to migrate it to an Oracle instance running in the cloud, or you have a MySQL instance running on premise, you want to migrate it to a MySQL instance running in the cloud. So that is really like the bread and butter of what's made for. We've since extended it to handle these other types of things where you're moving from a relational data store into DynamoDB, or you want to migrate from Cassandra into DynamoDB or something like that. And so, as Pete said, there is some sort of transformations that need to happen when that goes. One technique that some people have used successfully for this is to create views on their relational database that are structured in a way that is how you want it to be represented in DynamoDB. So you could think about things like doing joins on the relational side and sort of pre-joining data into a view which you then could do a one-to-one mapping between that view and into DynamoDB. And just yesterday, actually, we merged in some changes into our set of immersion day labs. We now have a relational to DynamoDB immersion day lab that uses this exact technique where we take data from IMDb, we load it into a MySQL database, and then we go through the process of defining what our schema wants to be based on the access patterns that we've defined in DynamoDB, and then we map that data from MySQL into that new set of structures using a view, and then we use DMS to migrate it across into DynamoDB. So that is a technique that has been used successfully, and if someone wants to do that immersion day lab, they should reach out to us, and we can help them do that.
Awesome. Okay, thank you very much. And that answers the question. I was going to follow up with what are some good patterns. That's great. I appreciate that, Chad. All right, so here's I'm going to actually jump ahead a little bit, and actually right in the chat we had a question said that is burst capacity. I'm sorry. Let me back up for a second. Let me give you the original question. It says, is there a reason to only allow 5 local indexes? Is there a thought process behind that? And then the following up is that is burst capacity 5 minute. Actually, that's a different one. So I'll leave that there. So bring that back up. Is there a reason to only allow 5 local indexes?
I'll jump in. Yes, there's got to be a limit.
Yeah.
Right?
Okay.
I don't want to put my opinions out here too strongly, but local indexes are not very powerful compared to what the GSIs can. And I don't remember how long ago it was, a year, with COVID, it's all a blur. 2 years ago, we upped the limits to 20 GSIs on the table. And so, anything that you can do with a local index, you can do with a GSI. So, we have a limit on the local LSIs because Well, one thing, they will impact performance because they are done synchronously with the table, whereas the GSIs are replicated, and we can, like I said, we support 20 of them. So I, highly recommend that you use the GSIs, and the limit is lifted higher there.
All right, perfect.
I think the other important thing to note with LSIs is that the data in the LSI is stored alongside in the same partitions as the data of the base table. So if you do have LSIs on your table, you've now created a limit for yourself on the amount of data that can be stored in the same item collection, or the amount of data that can be stored under the same partition key, said in another way. And so if you have a 10 gigabyte limit for each physical partition because you've enabled this LSIs, now if you have one LSI, you might have something like 5 gigabytes for an item collection in the table and 5 gigabytes for the corresponding item collection in the LSI. And now if you go and you use 5 of those, now you have 2 gigabyte limit for 1.7 or whatever gigabyte limit for each of the 6 things. And so there does have to be some limit there. We can't just keep increasing it forever.
All right. Excellent, Chad. Thank you. All right. So here's another question that came in. And this is interesting. It's kind of posing the idea that there is no serverless caching solution. So can DynamoDB with DAX be used as a serverless caching solution? In lieu of like a Redis, there's no serverless Redis or service equivalent with AWS. Are there any downsides to that? So DynamoDB with DAX as a caching solution. Possible downsides. Yeah. Okay.
Yeah, there's one downside. DAX is not serverless.
Mm-hmm. That's correct.
So you have the same issue that you have with Elasticache, right? So that would be kind of the key thing about DAX.
Okay. Anyone want to add to that? I agree with you. Obviously, that's undebatable. No, it's not serverless. I get that because you're spinning up clusters. But a lot of what DAX is doing becomes transparent, doesn't it? A lot of the work is done for you automatically. Would you compare? Would you recommend that over a Redis or a Memcache or some Elasticache?
Yeah, if you're really dealing with reads, whether it's read latency or the volume of reads. DAX is a really good approach because the API is the same as DynamoDB. So the act of incorporating DAX into your application is fairly seamless. There is a minor code change, but it's not. It really involves using the DAX specific constructor, and that's it. But other than that, it's an inline cache, which means your code otherwise stays as simple as can be and use the same DynamoDB API. So I would definitely recommend using DAX for that use case.
Okay, excellent. Thank you. All right, Rashmi, I'm going to start.
Yeah,
with you
hold on. Let me add on to that too, because there's some nuance there. The reason why sometimes we would advise people to use Elasticache instead of DAX might be because their application or their microservice might be talking to more than one database. It might use DynamoDB for some things. It might use another database for other things. And so sometimes they want to have data from multiple databases stored in a cache. And then it makes more sense to put everything into one shared cache, which of course DAX can't do because it is DynamoDB specific. And so this pattern does come up from time to time where we say, look, just use Elasticache because you can take the Dynamo stuff and whatever other stuff and put it all together in one place. It does mean that you have to manage the cache yourself, application side, as opposed to being write through and read through. But that is a common pattern as well.
Alrighty. All right. Love seeing things like this. Time to recreate my table after the LSI explanation. So we're making headway here. So I have a question, Rashmi. I'll throw this to you and a couple others that haven't spoken yet. But what is a feature of DynamoDB that the panel thinks has the greatest potential, but not many users are aware of this? I love this question because this is sometimes the battle we fight is, did you, because as DAs, a lot of times we'll question, how do we do, or why doesn't this do this? It's like, it does do that. It's done it for years. So what feature do you think would fit this description?
I think the one feature that probably fits this description is, let's say, transactions, because the NoSQL database traditionally do not support the concept of something like a transaction. So transactions are usually associated with something like a relational database. So, but DynamoDB does support the concept of transactions, where you could both for both writes and reads, where you could have an atomic way to write up to 10 different items, where you could modify many items at once, or you can also fetch the items in an atomic fashion through transact get items.
Okay. All righty. I'm gonna Akshat, do you have the same, or do you have a
Yeah.
different one? Okay.
Yeah, I think that's the same. And I would say it's also predictable performance. So you can do reads and writes at predictable performance for multiple items. And those items, they don't have to be of the same table. They could be of like multiple different tables that you can deal with, that you're using for your table, all in the same account.
Okay. And we had a question. I'll have y'all clarify. Is what's it called again? Transact get items. It's just the transactional support in DynamoDB, right? Okay.
Yeah. So transact write items is like you do transactions atomically across multiple items. Transact get is things you want to read atomically, multiple items together, and you do in that case transact get items.
All right. So same, or do you have a different one?
No, same.
Same.
I think
okay.
transaction is a big time enabler for a lot of applications, and it kind of enhances the capability of customers who want to do cross-table item mutations in an atomic fashion. So I think it's a big feature enabler.
Okay. So, and I think you just described it, but I'd actually expand. At what point in my application I go, you know what? Let's use transactions. Is that too broad, or is that answerable?
I think it depends upon the use cases, right? Like, so at any point in time where, I mean, a typical example of this one is, let's say a bank transaction where you have to deduct some money from some particular customer, and you have to add that money to the other customer. You do not want to have a failure scenario in between. So that's a typical point where, a transaction is probably the right way to go, because you could do both of these operations atomically at the same time.
Right.
So, yeah.
Okay. So let's just pretend for a moment, because we know this isn't true. I'm not real familiar with transactional. So, okay. So if I understand it correctly, if I'm using transactions, then everything has to succeed for the whole thing to be called successful. It's not that it's rolled back. Is that correct?
Yes.
Okay, excellent. Thank you. Or if not, it's written. All right, thank you. So I know, but for those who didn't know, there you go. That helps. No, I've never used transactional, so that's I came into the world when I started really heavily using databases. DynamoDB was my database, and transactional wasn't something I ever worried about. So, very cool. All right, so here's a question.
Let me add on to that. The nice thing about transactions as well, other than just the transactional semantics and all the ACID stuff around modifying more than one item at a time, is that it provides this functionality which we call an item potency token. And if you use this item potency token functionality, it means that if for some reason your application happens to issue the same transaction more than once, and this is not uncommon in a retry scenario where you've issued the transaction into the database, and the database is actually processing it behind the scenes, and it does process it successfully, but somewhere in the chain between that and when you get the success, there's some sort of failure somewhere. And so the SDK might automatically retry and send the transaction again. Now, if that happens and you weren't using transactions, it's possible that you might do the same thing more than once. Like I might have incremented a counter by 1, and now when I do the retry again, I'm going to increment it by 1 again. I'm going to actually double increment it, which is not what I wanted the outcome to be. So if I were using transactions with the item potency token and I send the same transaction twice, I'm just going to get a message back from DynamoDB saying, you don't need to do that. We've already successfully done this transaction and it's over. And so we avoid this problem of something like a double increment. So this is a really nice feature that you get with transactions that you don't get. Even if you were just modifying one attribute, this is a really nice feature to use. The other thing that I wanted to call out as a feature, which I think doesn't get used as much as we might expect, is the ability to query DynamoDB using Particle or use SQL-like queries. And we shipped this feature And, because one of the common things we hear is like, maybe the DynamoDB API, it's just not like what I'm used to using when I use other databases. And so we've created the ability to use SQL-like queries with this language called Particle. And I think we haven't been, I think we've been a little surprised that the uptick on it has been higher. And so that's something I would recommend anybody watching consider. If you've not written your code yet, it's actually just easier and faster to use SQL-like queries to read data from the database. But Pete has one, which is a really obscure feature of LSIs. And I know he talks about it a lot. And I don't want to call him a defender of LSIs, but sometimes I think LSIs get a bad rap when they shouldn't. But there is a feature you can do in LSIs that doesn't happen in GSIs. And maybe Pete can tell us about it, because it's one of his favorite things to talk about.
I don't disagree. I think transactions is number one, and I am really excited about the particle support as well. But some of the indexing stuff that I think people are not necessarily aware of or using as much as they could. Firstly, just understanding that you can have sparse indexes, right? That's a very powerful functionality, be that in an LSI or a GSI. The other thing is knowing about selective projection. I see a lot of people who just go with the default of all. And they could very easily be selective about which attributes, which columns they want to project. And that can be a really big deal when it comes to efficiency and scalability in the index. But the functionality that Chad brings up is something that I kind of refer to as reading through the LSI. And it comes back to this projection. If you actually create an LSI on your table and you say that the projection is going to be keys only, so you would think that in that LSI, then there are no other attributes that you could read. But if you go to that LSI and query it and actually say, I want these records back and I want these additional attributes, in the background, DynamoDB will go into the base table and pull those additional pieces of information. So particularly, if you're building an LSI to support a use case that is maybe a lot of volume of data that would be projected into the LSI, but it's infrequently read. You can make use of this to keep your LSI smaller, to reduce your storage cost, and just to be able to read through based on the primary key of the LSI. It's kind of a neat thing that I think few people are aware of.
Yeah, that's a good one. I like that. I brought our view down a little bit so folks could see your connection information as well, because I think we're going to have a lot of questions about this kind of stuff. So so you can see emails and Twitter accounts and stuff here. So I have another question here. I like this a lot. So since knowing access, more about methodology, right, and how do we approach it? Since knowing access patterns is so important in designing a DDB table, with DynamoDB table, is it an anti-pattern to use DynamoDB when starting a new application, new startup with evolving business needs, where access patterns will change often? Are you glued to your initial access patterns in DynamoDB? Thoughts?
Yeah, that's a really good question. Yeah, go ahead.
Oh, I was going to say, the hard part here is your software, right? That's the hard part, right? Most people, when they get an item from a DynamoDB table, I know I do this almost every time, is just get all the attributes. And, you have to be ready to deal with that. I think with any software engineering, you need to think about how you're going to version your data going forward. And that's has nothing to do whether it's Dynamo. Dynamo makes it easy because, you can just throw a document in and it'll give you that document back. But, the flexibility that you get is hugely empowering. But you still, I think, need to have reasonable software engineering practices to be able to modify or change the data that you're storing in Dynamo as you go along.
Yeah, and I think to that point, Jasso, one of those is when you to be basically more defensive when you're unmarshalling data, right? So ignore the fields that you don't know, that you don't recognize, don't error out, for example, right? So that as versions evolve and whatnot, you're open and remain flexible, right? For example, but yeah, I think it's an interesting question, but I think what we see with our customers for the most part is that even when requirements do change, right, they don't necessarily completely get overhauled, right? They evolve. right? So that if you select a partitioning scheme, chances are that partitioning scheme is going to remain valid, right? And that's kind of what we see for the most part. And if you're adding new access patterns, which is fairly common, there are ways to accommodate that, right? One very common way is to use GSIs to add those new access patterns with DynamoDB. And then finally, we talk about purpose-built databases here. So for some of the access patterns, why not think about a different technology? It doesn't always have to be DynamoDB for everything, right? So that's kind of the other thing to keep in mind.
Right tool, right job. Yeah, I really agree
Exactly.
with that. Pete, I think you were going to say something.
Yeah, I was going to point out the same things. Having that schema flexibility is really helpful in kind of being able to move forward and adapt around new requirements. Being able to add and remove GSIs is a very powerful thing. But the other part of this is, I think, if with DynamoDB at least, if you did have a change in your data in your schema that you needed to literally go through the entire data set and update everything, you can do that with DynamoDB, right? You can provision your write capacity up and drive that load as fast as you want to make that change in bulk. The reality is in many other databases, if you want to make those kinds of changes, it feels easy because it might be easy to describe what you want to have happen. But in the background, there's an awful lot of work going on. And that work to actually make that schema change in a large data set can be somewhat disruptive. It can actually compete with your live operations. And so it doesn't come for free anywhere, I think.
The interesting thing to add on to that, Pete, is anybody who's tried to reindex a table in a relational database or add a new index to a large table, that can take your application out for a fair amount of time. But to what Eden just said, if you happen to have a new access pattern and you want to add a new GSI with a smaller projection, that is something which happens asynchronously. And during that entire operation, the operations on your primary table are not impacted one bit. You still get to get whatever reads and writes you want to have on that table. So the first thing I'd say is that there's a little bit of additional flexibility there. The second is the places where we end up getting involved for the most part is where customers have enormous data sets. You don't get to an enormous data set from zero to an enormous data set in a very short period of time. By the time they're at the enormous data set, they've gone through a bunch of iterations in smaller data sets, and we make it a whole lot easier in DynamoDB for you to get there. And so I think when your application is small, put the data in, start innovating on the place where it's important for your application. Before you get too large, look hard at your data and figure out how you're accessing it and refactor your data. That's probably a better way to go about it.
I like that. Get something on the page, reevaluate.
Yes.
Yeah, I agree with that. All right, so you had a question come in earlier today, and this is pretty straightforward not straightforward, but it's a technical question. So assuming I'm using on-demand capacity, if I've ramped up traffic and have a partition key that is exceeding the hard partition throughput limit, will DynamoDB split the key into two partitions and continue doing so, or will I need to help DynamoDB by adding shards to the key? Sorry, it's too
I
big
think
to
we
print
need
on the
help on
screen.
that question a little bit, right?
Okay.
Because, will we split on the hash key? Yes, we will split into the range key if we have to. Okay. But if you have a single key that is a hash and a range key, and that item is being requested, 10,000 times a second, that we will throttle.
All right.
Right.
All right.
So we will partition, but we will throttle a single key with high throughput.
All right. So I'm going to make sure I understood this correctly. So you'll take, if it's a single key, meaning it's not a composite key, just a single key, you will create a composite key. Did I understand that? Okay.
No, so your most of the time when we split a partition, we just do it on the hash key.
Okay.
Right. But if you have, and this is one of the downsides of LSIs, is that we can't split an LSI beyond the hash key. But if you just have a regular base table and you have a hash key that is very, very common, we don't recommend that you choose a low cardinality hash key. But if you do, and then you have lots of range keys within that, we will split at that hash key into the range key area. And so, you know, like I'm not going to recommend this, but let's say you chose a state to be your hash key, and maybe the customers who live in that state to be a range key. Terrible schema design, but if you did that, right, in California, you would have a huge number of customers in that hash key range, right?
Yeah.
There we would split that partition in California to have the A through M's in one place and the N through Z's in another. And we would continue to do that on demand to satisfy the workload as it comes in.
Okay, that makes sense. All righty. Now the question we have in here is, how do you scan a DynamoDB table end to end without consuming all the RCUs at a certain time? Would using the scan API's paging and making calls with a small delay between the different paging calls solve this?
I'm gonna take this one. If you don't want to use the read capacity units of your table and you want to scan your entire table, you can just export the table today from DynamoDB to S3 directly, and that would just save you all your read capacity units and give you a copy of the table. That's the easiest way to do it without consuming any read capacity units.
Okay, so that makes more sense than pagination and hitting it over and over. Okay,
yes,
yeah, I would agree with that.
Yeah, that's one way to do it. Another way that people will do this is using the Elastic MapReduce EMR Hadoop clusters, and there is an EMR connector into DynamoDB, and the EMR connector essentially would parallelize your DynamoDB table, split it up into a bunch of little pieces essentially, and it can have these Hadoop jobs that are sitting there running and scanning your table in parallel, so that you could actually go through this process using a parallelized compute system. Now that would consume RCUs of the table, but one of the options that you can pass into this library is to say what percentage of your provision throughput do you want EMR to consume. So you can say, whatever I have provisioned, just use half of that and leave the other half for my actual operational use case with my app.
All right, excellent. So you made Sananmo very happy. They did not know about exporting at all. They were very excited about this. So yes, very, very true, and a smart way to do that. You can also do it. You know, we have folks that as stuff hits the database, that we talked about streaming all day long. We've heard that stuff coming out of the stream and getting analyzed or dropped in automatically as well. So there's lots of different ways you can do that. So. All right.
You can, in the cases where you do have application, APIs, right, calling in, where, you need to do paging. You can also control this by controlling the page size. There's a limit attribute, right? And that's, so you can use.
Yeah. And that's a common pattern where you're listing stuff on a website or something like that, where you do chunk it down, auto page it, things like that. I'm sorry, I interrupted somebody.
Oh, no, that's all right. Another pattern, just for completion here, or completeness, and if there's more, we should talk about those too, because this is a common thing that people want to do, though. Sometimes people will create a GSI, which has the same partition key and sort key as of their base table. And essentially, then when you do that, the GSI just becomes another copy of your table that has its own capacity allocated to it. So sometimes you'll have multiple users who want to use the same data set but not impact each other. If you have a use case which is like, well, I have my application running, it's using the base table as an OLTP type system, but I have this other business user who needs to do these large reports periodically where they need to scan the whole table or something like that. And I do not want those analytics jobs to impact my operations on my OLTP system. So you can create another copy of your table using a GSI and let the OLAP users actually use the GSI, which completely remove them from the base table.
And another improvement that you could do on top of that, like if you do want to, or if you do plan to use scan APIs, and especially if your table is large, DynamoDB does support a feature called parallel scan, where you could divide the whole table into the number of segments that you want to and scan them in parallel so that you could get the data faster. And it's also, you could break it down so that you're reading data across different partitions.
Okay.
Eric, you talked about scanning an entire table.
Yeah.
It'd be important for the person who asked this to think whether on every item they're going to be looking at every attribute or not. Think about what Chad said. Have a GSI where you project only the columns which you're going to need. It's going to require much fewer RCUs to go through that GSI. So extend on that idea, do a smart projection and use that.
Okay. Great. There's been a lot of solutions here, a lot of good advice. So great. Thank you. All right. So I have another question here. Yeah.
Hey, Eric, I just wanted to point out in terms of scanning, something that's kind of interesting that I think a lot of customers don't really think through is maybe they're scanning the table and they're going to take that data then and maybe feed it into another DynamoDB table. When you scan and you start at one end of your table and you read through, it all comes out of there in an order.
Right.
So if you take that then and try to insert it into a new table in that same order, you're essentially going to be hammering one of those partitions. You're going to move along and then hammer the next one, and it's going to constrain how quickly you can ingest that data into the new table. So one of the things to think about is the ordering of that data. If you want to ingest quickly, you basically shuffle the order, right? You take the output data, shuffle it, and then you can insert it into DynamoDB as quickly as you want to. So just kind of an interesting trick that I think trips some people up.
Yeah, I agree. But I would also go back and man, Eric isn't supposed to talk in this session. Y'all are the DynamoDB experts. But from an EDA point of view, from an event-driven application point of view, if I'm needing this data somewhere else, why not do it on a rather than me having to scan at any time? Why not take it off the stream and put it somewhere else as it builds up? And so what you have there is an almost real time, because it's not a batch process, it's an event driven process. And so if you're looking at, for that reason, making another table or dropping it in, putting it somewhere else for reporting later, you can do that at a batch process or on individuals and save yourself some time and have it pretty current. So
streaming is definitely, I would say, my favorite way of building views in real time for that reason, because they're there and because it scales, right? It's a way of doing it that scales really well. So
yeah, I agree
for sure.
All right, excellent. All right, so we have another question. We've got about 10 minutes left here, so we're doing all right. Excuse me. All right, so I like this question, and we may not be able, well, let me just ask it and see what you think. Are there any services within AWS that work quite nicely with DynamoDB regarding compliance concerns, anonymization of PII for GDPR, etc.? Does a full scan in DynamoDB also have two modes in the strong and weak consistency? I think let's start with the first one. Are there any services within AWS that work quite nicely with DynamoDB regarding compliance concerns, anonymization of PII, things like that? How would you approach that in DynamoDB?
So let me start, and maybe we'll see where it goes.
Okay.
When the person, maybe the person who's asked the question can follow on. Is the issue that you want to return some of the attributes, but you want to scramble other attributes, or what are they actually looking to get out of this? I understand the note. So are they trying to build a test cluster? Are they trying to, sample the data but not look at PII fields? What are they trying to do?
So Sanamo, I know you're on. You might be able to add some more context for this. But let's say, I'll throw context out for a minute. Let's say I want to run some reports against test data, but I need it to be scrubbed. How would you approach that?
Okay. What AWS service would I work with?
Well, I think
we don't really have an out of the box, right?
Yeah.
Service.
No, I think this is a good time where we would say we want to work with partners, and there are many partners who do this type of thing that are certified through the AWS Partner Network. If you just Google AWS Partner Data Sunrise, that's one example. That's just one of many, but there are many third-party vendors who integrate with storage services like DynamoDB and who handle data masking, data auditing, that type of thing.
Yeah.
There is another way. This isn't answering the question directly, but Dynamo has fine-grained access control. And so one of the things that you can do is prevent certain users from ever seeing particular data or doing certain queries against that data. And so, setting up fine-grained access control is one way to limit what some other party is able to see out of your table.
So that's going to protect PII, like Jasso said. But what you're looking for is test data, which is going to look like your production data. It's hard for us to do that at DynamoDB's level because that is a business policy decision. That's entirely dependent on your schema. Which attributes do you want to scramble in which way, and so on. So within the database itself, or I'll step one step back and say I haven't seen many databases which natively build that kind of capability into them, but I'm sure partners will be able to help with that, and they have helped some of our customers with that.
Okay. All right. Okay, excellent. All right. When using data,
what was the second part of that question about strong?
So all right. So there was some more to the question here, and I'm going to read it here, make sure we understand it. Does a full scan in DynamoDB also have two modes in the strong and weak consistency? And it goes on to ask, if yes, does the strong consistency take into consideration what was added during a scan and keep it out? Does it work if I'm using paging?
I can probably take a stab at that. So yeah, scan does support both strong consistency and eventual consistency. So there are some intricacies of when you're using scan and especially when you're using paging. So let's take the example that Jasso was referring to and think about if you are scanning the data from A to Z. So if you have scanned the data from, let's say, A to M already, and if you insert the data, let's say P, so the next scans, when you do read them, the strong consistency will make sure that the data P will always be read. However, if you do insert the data C, which is already read before, you would not get that data anymore. So you would have to start that scan from the start to be able to read the data C because you have already passed that point. Yeah.
Awesome. Okay. All righty. All right. Yeah, and that explains that question. I think we have time for maybe one more question, depending on how long it is. Does DynamoDB keep my unused WCUs and RC? This may be a short answer. I don't know. Okay, let me start over. Does DynamoDB keep my unused WCUs and RCUs within a 5-minute running interval? So if I don't use a WCU within a second, it gets stored and expires after 5 minutes. I guess bottom line is, how are WCUs and RCUs managed?
So, Jasso, you want to talk about burst capacity or something?
Right. Okay. So yeah, we use a token bucket, and the timer on that token bucket is 300 seconds. So the token bucket is filling up at the RCU rate, and it will fill to whatever 300 seconds worth of RCUs or WCUs are. And after that, the token bucket is full. No more tokens are added, and so you can burst into the last 5 minutes of whatever your RC or WCUs are.
All right, excellent. Anybody want to add or that makes sense to me? Okay. All right. So here's one more about encryption. Looks like we have just a few more minutes. So when we use DynamoDB encryption client, does the data get encrypted at the DynamoDB endpoint and encrypted again using KMS by the DynamoDB endpoint?
When you use the DynamoDB encryption client, the client encrypts it at the client side. It is not encrypted at the DynamoDB encryption endpoint. If you want DynamoDB to encrypt your data, you can use server-side encryption, and we have two different modes where you can either use our default mode where we use Amazon-owned keys itself to kind of encrypt the data, or you can provide your own KMS key to encrypt your data, and we would do the server-side encryption.
All right. So there's a difference between the client side and the server side here, and there's two modes at server side. Okay. Excellent.
So even the client side, even if the client side you encrypt it, whenever you hit server, by default, if you don't pick any encryption, we would do server-side encryption.
And with an AWS managed KMS key, right? Okay.
Yeah.
Or an AWS managed key. Okay. Excellent. That's why we say out of the box, encrypted in flight and at rest. So, okay.
Worth mentioning that even if you don't use encryption client, we do encrypt end to end. right? We do basically data is encrypted in transport and at rest. So by default.
Yes.
All right. Well, with that, I want to thank all of you. We got Robert Table says encrypt everything. That is very true. We do have a few more questions coming in. We're not going to be able to get to all the questions, and I apologize for that. But you can see we've got EDJ Geek as my Twitter handle. Several of us put our Twitter handles, our email up. Feel free to reach out to us, and we will make sure that we can get these questions to the right folks. And real quick before we end, panel, is there anything y'all want to discuss or throw out? Something that's burning that you just need to tell everybody within reason.
Just to mention, if there are other questions, definitely reach out through the DynamoDB Twitter handle too.
Yes,
a lot of us are watching that and happy to answer some questions.
That's the best source. Go there. We'll put that in there. That's just at DynamoDB on Twitter. So, anyone else have something they want to throw out real quick?
I'll throw out, Eric. You've done a great job of hosting today.
Thank you very much.
A long
appreciate
day.
That.
It's been fantastic. Yeah,
good.
Thank you.
Good. It's been a great day. Ton of information. I appreciate you all. And so I'm going to start dropping some folks off, and we're going to do a wrap up here. Chad and Joe, I'm going to keep you on. So here we go. I'm going to remove everybody else. Thanks all.
Thanks.
Okay. You bet. All right. I want to give props to the team behind the team. Giselle and Sue Ellen and their team have done a fantastic job of organizing this. I think Giselle and I have talked more in the last 3 weeks than I've ever talked to her. So that's great. But
yeah, you guys are
Joe,
besties, I bet.
We very much are. Yeah. Joe, I'll start with you. How'd the day go?
Yeah.
What did you learn anything today?
I always learn something. You know, it's funny is like getting this last group of people together. You know, there's the collective knowledge and the brain trust on that screen is phenomenal. And like the fun thing is, I get to work with these people every day, right? And it's chat. You know, like you learn, you know, and Pete and Jasso and Rashmi and Akshat and Somi, like you learn something every single day.
Yeah, I can imagine.
And it's kind of where I really like databases, right? Like you just never bottom out on it. There's not something where you just kind of like, yeah, we kind of understand this now. It's always challenging. So did I learn something today? Heck yes. You know, every time Alex Debris or Jeremy Daly talk, like those guys are just so clean and thoughtful, and they just have a good way of simplifying things and talking about patterns in a way that is very approachable. So I very much appreciated both their talks today.
All right. Yeah, I agree. Yeah, I have shared the stage with those folks or just sat in rooms while they talk, and I'm blown away every time. The fun part is I've sat and had, you know, Jeremy and I are speaking in the same conferences, or Alex, and we've sat and had talks, and sometimes the dinner table track, and it's like, oh my gosh, I just absorb what they have to say. Chad, what about you? You learn anything today?
Yeah, I really enjoyed the talk with Don McCaskill, and I'm a Flickr user. I've been using Flickr since 2005, and you know, to store my own pictures, and I don't think I fully appreciated the scale of the migration that they went through until he was talking about that today, and how much data had to move from Yahoo servers into SmugMug servers in AWS. That's really interesting. And anytime I hear a customer talk about a use case that big, there's always going to be something that they learned that they can teach us.
Yeah, I would agree. You know, it's interesting in our role, we build a lot of proof of concepts for customers, right? We will, you know, we'll build this, but we don't work at scale much. And so when I hear these stories, I mean, think of Amazon.com scale, you know, why we built DynamoDB and a lot of the things going on. I mean, the massive amounts of data getting thrown around is just crazy. Getting thrown around. You know, so this is why I don't work for the DynamoDB team. But yeah, it's crazy. So tell me your. Go ahead, Joe.
Well, I was going to say the other thing I thought was really interesting with Don's story is the confidence that DynamoDB gave them to be able to do the acquisition and be able to think that they could actually perform that migration in a year. Just having that confidence that you have a database that's going to be able to do that for you. I thought that was like kind of cool. Right? You know, it's one of those things where like a database factors into the acquisition of a company, like that's a, it's a difference between a yes and a no. And I think, that's a different level of impact than we usually talk about.
Well, also knowing that what it's going to cost. I think the ability to know in advance, like, this is what we're doing, this is how much it's going to cost, and you're not going to get hit by some big surprise bill from some vendor who comes in and, whatever, jacks up the rates and wants a renewal or something.
All right, so I agree wholeheartedly. I want to take you all back now. The three, I know we've been around. I think you two have been around a lot longer than I have. But go back to those. You weren't in the meetings, but imagine sitting in that meeting with Swami, with Werner, those guys, and thinking about this. That we need to build something that doesn't exist. How do you approach that?
I mean, it's funny. It's like you go back and you kind of think about like the decisions they had to make on the APIs on, whether they did HDs, hard, like SSDs or, HDDs, and like what that API set was going to look like, and whether, what they're going to do indexing and consistency model. And those are really hard decisions on the early days of product. And I kind of I think I asked in multiple ones is like, just even talking about serverless back then, like it really wasn't something, like, to go fully serverless back then, and to go on SSDs, and also think about adding streams in 2014. Like these guys are really making some really great product decisions, and they were it just comes down to innovating on behalf of customers in gut feel and just a deep understanding for where the world's going to go. And then you look at who's in that room, right? That's James Hamilton. It's Warner, it's Swami. It's kind of no coincidence these guys have been incredibly successful. And it's you go back and it's that's a lot of horsepower sitting in that room making decisions. But I don't know. I always kind of in awe in these products that come out, and they really haven't had to. We've added stuff, but we haven't pivoted DynamoDB. And I think Chad made that point earlier today. It's not like it was like a rewrite. We had to do something majorly different. Like they really nailed it. And it also comes like we iterated on Dynamo and SimpleDB, and then we got to DynamoDB. So it's not like it was, first try. It was, this is our collective knowledge of building these systems, and it's persisted. It really has.
Yeah, the visionary is off the charts. The smarts, obviously, smart. There's just no two. But the visionary, the ability to go, we can make that happen, or we need to make this happen, or this is what it takes. And Chad, I do like the comment you made. I mean, that base of not having to pivot. Talk a little more about that. There's importance of having a strong foundation. Talk a little more about that, Chad. Sorry, I got you muted.
Well, speaking of strong foundations, look, DynamoDB is a massive distributed database here. Now, the hardcore computer science and the algorithms and everything that people know of when they think about distributed databases, those have been around for a long time. I mean, Leslie Lamport was creating the Paxos algorithm in the 80s. And so there is a strong foundation of theoretical concepts that they had to work from when they came to solve this problem here in the 2000s. The hard part is, how do you take this foundation of theoretical concepts and build something that's concrete, that runs on commodity hardware, that you can operationalize at scale? Okay, because once you build it, now you have to run it forever, right? And we're talking about things where we have single tables that have petabytes of data in them, which means behind the scenes, we're talking about exabytes of data. I mean, we don't publish how much, but you can just think in your head, if this is what customers are doing. And when we add it all up and sum it all up, and millions of users and Amazon and all these other major companies that are built on top of it, operationalizing that becomes very, very challenging. And Joe knows this. He's dealing with it every day, being a product leader. So it's not just about, how do we take these theoretical concepts and build this nice API that's easy for people to use, but like, every time we ship a new feature, that might mean that we need to go do some sort of asynchronous migration of data behind the scenes, or move things around, or recompress everything using some new algorithm or something like that. That's happening at this massive, huge scale, and that is also not easy to do. Okay, so it's not just impressive that they built this thing, but that it maintained how it works and how it's structured through these massive migrations that we do behind the scenes. It's very cool and not at all easy to do.
All right. And I'm going to, we know we're at the end of the day because my headphones just died. All right. I don't know if y'all can hear me.
Yeah, you're good.
Okay.
There we go. All right, good. But they died right there. Oh, great, Chad. All right. Well, on that note, the one thing I want to add to what you were saying, and then my headphone died. Maybe that's a sign I shouldn't add it, but I'm throwing it out anyway. I think part of the impressive part is taking all this massive scale, all this massive vision, everything's done, and making it usable by clients in a way that two developers in a garage have the same power as enterprises. And, when I talk to people building, obviously DynamoDB and serverless hand in hand, like Jeremy talked about, when I talk to folks and say, how are you building this? Well, we're doing, we're doing this database. A lot of times it's SQL, and I'm not anti-SQL, but again, right tool for the right job. A lot of times the question I ask is why? Is it because that's what you know, or is it because of what you need? And 90% of the time it's what we know. And so we talk about DynamoDB and the simplicity of simplicity is probably an overstatement, but the how it can be used very powerfully and a lot. Yeah, I'm gonna say it's simpler. So, all right. With that, we are going to wrap up. But before we do, I'm going to share this. We have this coming up. March 14th is AWS Pi Day. 2022, celebrating 16, if you remember the rules, that's a 16 years of innovation with Amazon S3. We're going to be talking, 14 AWS storage sessions. There's going to be a lot going on with Kevin Miller there, Jeff Barr. I encourage you, it's always fun to see how these services have evolved over the years. We've had a great day talking about DynamoDB and how that works. And so I encourage you to join us on March 14th. I want to thank everyone who participated. I won't go through all the names. I wish I could, but we've had a lot of folks from the VPs who have, past and future, future. We don't know who the future VP is, but past and present, from Joe and Chad and the whole team that came on for everything from our heroes, and then of course the folks who organized it all. And with that, I'm going to give a goodbye. Joe, Chad, you want to throw anything else before we go?
We just want to thank you, Eric, your energy and, making this fun for everybody. We really appreciate it. We want to thank our customers. Obviously, we don't get to do this without them, and they push us in all kinds of fun and fantastical ways. And then there's a lot of people, behind the scenes, the teams that compose, solution architects and, go-to-market specialists and the engineers and the product managers and all the leadership that make this happen. So we just have the opportunity to say thank you.
Thank you very much. All right. With that, we are out. And I hope y'all have a great evening